Swagatam, Suswagatam, Shubha Swagatam. I extend a very warm welcome to all the distinguished dignitaries in this international conference on emerging trends in physical sciences sponsored by Pradhan Mantri Uchchatar Shiksha Abhiyan 3.0. I also welcome all the online resource persons and delegates who are joining with us from across the globe. May I request all to kindly stand for the university song.
नित्यं हि विद्याचिन्तनं नित्यं च विद्यामन्थनं नित्यं हि विद्यासर्जनं नित्यं च विद्याजीवनम्
संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले.
मुनीने आता पुढे अडाणी ज्ञानाचं विज्ञान कळाले.
पर्णकुटीतील प्रतिभेलाही आभाळाचे पंख मिळाले.
दशसूत्राचे अक्षर अक्षर वेद नवा बोले.
संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. किती रंधले किती गांजले किती आंधळे डोळे पांगळे.
कर्मयोग निष्ठामनाचरून कवेत घेता बांधव सगळे.
भूतदयेच्या ओलाव्याने माणूस मोहरले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. धर्मजातीच्या पलीकडे माणूस केवळ माणूस असतो. भेदभ्रमांचे बंध तोडूनी मानवतेचे पूजन करतो. पिढ्यापिढ्यांचे जीवन दर्शन विश्वात्मक झाले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले.
जनमन नागर करीत निरंतर विद्यापीठ चाले.
संत गाडगे बाबा तुमचे स्वप्न पूर्ण झाले. तुमचे स्वप्न पूर्ण झाले. तुमचे स्वप्न पूर्ण झाले.
Thank you all. Dear delegates, today we are elated and honored to have eminent personalities amongst us. We are honored to have Honorable President Shikshan Prasarak Mandal, our parent society, Honorable Dr. Taratai Hatwalne, as the president of this inaugural ceremony. We are proud and privileged to have Honorable Dr. Yi Seng Tan Sir, Sunway University, Kuala Lumpur, Malaysia, as the inaugural guest. We are equally delighted to have Honorable Dr. M.D. Shirsat Sir, Dean Faculty of Science and Technology, Dr. Baba Saheb Ambedkar University, Chhatrapati Sambhaji Nagar, as the chief guest of this inaugural ceremony. Accompanying Accompanying them on stage is Honorable Officiating Principal of the College, Dr. P.S. Pandey sir. Convener of this conference, Dr. S.K. Devde sir, and Treasurer of this conference, Dr. Kharat sir. Today, we are living in an era marked by unprecedented advances in technology, challenges in understanding the universe, and unprecedented opportunities for collaboration and innovation. And hence, such conferences are organized to provide a platform for the academia and researchers to share their knowledge. And to commence this conference, may I request the inaugural guest and all the other dignitaries on the dais to kindle this lamp of knowledge and officially inaugurate the conference. May this lamp of knowledge eradicate the ignorance and indifference. I would also request all the dignitaries to kindly garland the image of Maharashtra State's first Chief Minister, Deputy Prime Minister of India, and the man who had graced many positions like Home Minister and Defense Minister, Honorable Yashwantrao Chauhan. Today is his birth anniversary. Let us pay homage to his work. Thank you so much. May I now request Honorable Officiating Principal Dr. P.S. Pandey sir to kindly deliver the welcome note.
Honorable dignitaries on the dais, President of inaugural function of this international conference, Honorable Dr. Taratai Hathwarne, President, Shikshan Prasarak Mandal Akola, Keynote speaker, Mr. E. Sang Tan from Sunway University, Kuala Lumpur, Malaysia, Guest of honor, Professor Dr. M. D. Shirsat, Dean, Faculty of Science and Technology, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar. Convener of this conference, Dr. S. K. Devde sir. Organizing Secretary, Mr. R. K. Shirsat. Treasurer, Dr. H. J. Kharat. Esteemed speakers, researchers, fellow scientists, and participants. A warm welcome to all of you to the International Conference or Emerging Trend in Physical Sciences, sponsored by Pradhan Mantri Uchchadar Shiksha Abhiyan, that is PM Usha 3.0. It is both an honor and a privilege to gather here with such a distinguished group of individuals who share a passion for advancing the frontier of knowledge in field of physical sciences. This conference marks a significant occasion for collaboration and innovation, providing an exceptional platform for all of us to exchange ideas, foster discussions, and explore new avenues of research. Today, we will delve into some of the most exciting and cutting-edge developments in the field of physics, material science, quantum mechanics, semiconductors, renewable energy, and other sub-themes. As we all know, the physical sciences play a vital role in addressing some of the most pressing challenges of this type. This conference is more than just a forum of presenting research. It is an opportunity for all of us to engage in meaningful dialogue, to form connections that transcend borders, and to spark collaboration that will lead to transformative progress. In this world that is increasingly interconnected, sharing knowledge and working together across discipline is essential for the benefit of the society as a whole. I would like to extend my deepest gratitude to the organizing committee, sponsorer, that is PM Usha, and volunteers whose hard work and dedication have made this event possible. Your efforts have created an environment where ideas can flourish and where the best minds in physical sciences can come together to push the boundaries of what we know. I also want to express my sincere appreciation to our speakers and panelists who are leaders in their respective fields. Your willingness to share your insights and expertise with us is valuable and will inspire the next generation of researchers. Thank you. Thank you very much.
Thank you so much, sir, for your kind and knowledgeable words. Now, to express our sense of joy and gratitude, let us felicitate our guest. I request Honorable Principal Dr. Pandey, sir, to kindly welcome the President of this inaugural ceremony, Honorable Dr. Taratai Hatwarni. Now, I take this opportunity to introduce Honorable Inaugural Guest Dr. Yi Seng Tan to you all. His CV is very exhaustive and I will try my best to cover it all. Dr. Yi Seng Tan, sir, is a skilled crystallographer with an extensive experience in various aspects of crystallography, including crystallization, diffractometer instrumentation, diffraction experiment design and measurement, instrument operation, data processing, structural solving, data validation, and interpretation. His particular interest lies in the structural dynamic aspects of crystallography, focusing on polymorphism, supermolecular isomerism, and stimulus-responsive structural transformation. He is proficient in conducting independent research and collaborating with teams as demonstrated by his experience in both solo and group projects. Beyond his research, he is readily available to assist other faculty or university researchers with crystallography experiments. He is working as a senior research fellow at Sunway University, Kuala Lumpur. He has research experience of operate and maintain X-ray diffractometers for single crystal and power diffraction analysis. Ensure the X-ray diffraction facility is fully functional, overseeing daily operations, system maintenance, and radiation safety compliance. He has also served as a radiation protection officer, RPO, ensuring compliance with safety regulations and conducting trainings for users on proper handling of X-ray equipment. He has managed XRD facility services for internal and external collaborators, including reviewing fee structures, handling billing and procurement of consumables, and updating standard operating procedures. Research fellow at Sunway University, he has designed and developed the X-ray diffraction and chemistry laboratories for the Research Center for Crystalline Materials, including procurement and cost estimation for equipment purchases. Operated and maintained single crystal X-ray diffractometers, ensuring the collection of high-quality data and resolving complex structures, including twinned and disorder systems. He has supported faculty and students with training and technical guidance on crystallography related projects. Research assistant at PhD Research University of Malaya, he is engaged in crystal engineering of zinc and cadmium diethylate coordination compounds, observation of structural transformations, extensive training in crystallization techniques, gaining hands-on experience with single crystal X-ray diffractometers. A man with such research orientation and aptitude is obvious to be conferred with many grants and awards. He has been awarded Sunway University Research Reward Fund in the year 2017, Sunway University Research Fund 2020 Metal Organic Frameworks. In the year 2021, he was awarded with Sunway University Individual Research Grant, Rewarding Research Output Fund in the year 2022, Royal Society of Chemistry Researcher Development Grant in the year 2022, Fundamental Research Grant Scheme tailoring supermolecular isomerism for efficient carbon dioxide absorption in the year 2022. He has professional membership of Royal Society of Chemistry, Hope, Japan Society for the Promotion of Science Fellow, and Malaysian Crystallographic Association as a committee member and member of Malaysian Institute of Chemistry. He has presented over 67 publications are there to his credit, and he has exhibited his leadership qualities as co-lead the design of laboratories and oversee the acquisition of equipment items, served as the radiation protection officer, acted as the chair of the chemical crystallography workshop organized in the year 2022, and served as the scientific program chair in the year 2024. It is our proud and privilege to have you here, sir. May I request Honorable President Dr. Taratai Hatwalne to kindly welcome and felicitate Honorable Dr. Yi Seng Tan, sir. Moving further, I take this opportunity to introduce Honorable Chief Guest Dr. M.D. Shirsat sir to you all. Dr. Mahendra Shirsat sir is presently working as a senior professor in the Department of Physics. He is director of the RUSA Center for Advanced Sensor Technology, head of the Department of Electronics, and dean of the Faculty of Science and Technology, Dr. Baba Saheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, India. He has shouldered several other administrative responsibilities at Dr. Baba Saheb Ambedkar Maratha Universities as a registrar in the year 2015 and 16, director incubation and innovation linkages in the year 2018, director IQAC cell 2017 to 19, director academic staff college from year 2011 to 13, and head department of physics from year 2013 to 16, and director Deen Dayal Upadhyay Kaushalya Kendra from 2013 to 2021. He was a postdoctoral fellow and visiting scientist at the Department of Chemical and Environmental Engineering, University of California, Riverside, USA. He was visiting principal fellow at the University of Wollongong, Austria in the year 2006, visiting professor at Hanyang University, South Korea, and National Taiwan University of Science and Technology, Taiwan. He was visiting professor under National Scholarship Program of Slovak Republic, Comenius University, Bratislava, Slovakia, Europe from March to December 2023. Honorable Shirsat sir has 36 years of experience in teaching, research and innovation, and he has 13 years of administrative experience. He has 310 research publications to his credit. Out of these, 226 research publications from Science Scopus Web of Science Index journals, peer-reviewed journals, and 84 from national peer-reviewed journals. His H index is 41 and I-10 index is 145. His work is cited in 6,263 times on Google Scholar, and H index is 37. Citation index is 5,126 on Scopus. His cumulative impact factor is 630 with the highest impact factor of 16.74 from Thomson and Router. He has 2 patents to his credit. He has successfully supervised 27 PhD and 5 postdoctoral scholars. Presently, 8 PhD scholars are working under him. He has undertaken 26 major research projects and infrastructural projects at the national and international level with total grants of 17.19 crores from various funding agencies. He has played a pivotal role in the capacity of Dean, Faculty of Science and Technology during the 4th cycle of NAC accreditation of Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar to secure an A+ with 3.38 CGPA. He has visited many universities in foreign countries including United States, Australia, Japan, Thailand, Hong Kong, etc. It is our extreme delight, sir, to have you. May I request the convener of the conference, Dr. Devre, sir, to kindly welcome and felicitate Honorable Dr. M.D. Shirsat, sir. Thank you so much, sir. Now may I request the treasurer, Dr. Kharat, sir, to kindly welcome the principal of college, Honorable Dr. P.S. Pandey, sir, and head department of chemistry. Thank you. Any conference is aimed at a particular purpose in mind. Hence, now I request Dr. S.K. Devre, sir, to introduce the aims and objectives of this conference to us all.
Honorable Inaugural Function, Dr. Taratai, guest Dr. Tan, sir, guest of honor, my friend, Professor M.D. Shirsat, sir, respected dignitaries, team guests, distinguished speakers, dear faculty members, research scholars and students. A very warm and heartfelt welcome each of you to the International Conference on Emerging Trends in Physical Sciences, ICE-TPS 2025. It is indeed a moment of pride and honor for Shankarlal Khandelwal College, Akola to host this prestigious event under the esteemed guidance of our principal and my colleagues of Department of Physics. It is funded by PM Usha 3.0. This conference is the testament of our commitment to fostering collaborations, innovations, and knowledge sharing among academicians, researchers, and industry experts in the field of physical sciences. Our aim is to explore emerging trends in quantum physics, nanoscience, renewable energy, material science, computational physics, and various interdisciplinary applications. As we gather here today, we look forward to the meaningful discussions, lightful presentations, and groundbreaking ideas that will shape the future of science and technology. We are privileged to have an eminent panel of the National and International Advisory Committee members who have extended their valuable support in organizing this conference. We also extended our gratitude to our chief patrons, Honorable Milindaji Barhate sir, along with our esteemed patrons and sponsors whose contribution have made this event possible. This conference will feature keynote address, technical sessions, and poster and oral presentations by leading experts, providing a global platform for researchers, faculty members, and students to showcase their work and exchange the ideas. We encourage each one of you to actively participate, engage in discussions, and make the moment of this opportunity. This conference has registered 240 participants, and we have received 113 research articles to publish in the international journal. Once again, I extend my warmest welcome to all our distinguished guests, note speakers, and participants. May this conference serve as a catalyst for new collaborations, knowledge exchange, and innovative advancement in physical sciences. Wishing you all a productive and enlightening conference ahead. Thank you. Thank you very much.
Thank you so much, sir. Now, may I request Honorable Inaugural Guest Dr. Yi Seng Tan, sir, to kindly declare the inauguration of the conference. Thank you so much, sir. Now may I request Honorable Dr. M.D. Shirsat, sir, to kindly address the delegates participants on today's occasion.
Respected is on the dais. They are president of this session, inaugural function, and president of Shikshan Prasarak Mandal, Dr. Taratai Hathwalne madam. मतलब वास्तव थोड़ा सी जरा एक principal of this college for some reason Dr. Sabu, obviously Dr. Pandeji, the convener of this international conference, and my friend Dr. Devdeji, my another friend who is treasurer of this conference, in fact we are classmate, Dr. Haridas Kharas sir, and very young and enthusiastic organizing secretary Rohan, all respected members of organizing committee, my friend who is sitting in the audience, Professor Gajanan Mode from Amravati HGB Amravati University, all respected teachers and dear student, very good morning. In fact, this has been really great pleasure for me to be here, part of this inaugural function of International Conference on Recent Trends in Physical Sciences. At the outset, let me express my sincere gratitude to the principal of this college, a visiting principal as well as regular principal, organizing secretary, convener, all the organizing members for being invited me here to speak few words about the research status in India. Friend, in fact, let me tell you, my friend, because I know like I have to speak very less today in the inaugural function. I will be speaking at length in my technical talk. But still, since we are here, it is my responsibility to tell you what kind of R&D happening in India these days. I'm really happy to note that India is leading, I would say a global leader in terms of IT outsourcing. We have a talented, large number of talented people across the globe, across the country. And I would say across the globe because most of the Indians have been placed overseas universities and overseas organizations they are leading. And every day they are working hard for technological innovation and enhancing digital infrastructure. However, when it comes to the R&D innovation in India as well as in India in particular, because I would like to speak about the Indian situation, somehow we are lagging. In fact, the kind of resources we have in India, resources in terms of intellectual manpower, talent, physical resources, we are fifth largest economy in the world, and we are very strong, truly speaking. But in spite of that, in spite of having all those strong features, truly speaking, in globe as of now, after US and China, India is the richest country. And I would say we are ahead of China and US in terms of richness in every aspect. I'm not talking only money. Yes, we are global leader even in money. As you can see now how BCCI is leading across the globe in cricket. And same thing is true in science and technology as well. लोग कहते कि यार हम India is poor country, but I don't believe on that. Somehow our wealth is not being converted into prosperity for one or other reason. And therefore, if you see the index of happiness in the world, and if you want to see where India place, we are well behind. In spite of having all sort of wealth in India, we are more than 100 rank as far as happiness index is concerned. Somehow it is not being transformed. Whatever we have is not being transformed. If you look at the kind of resources we have, because I have seen the world, I have visited many countries overseas, and what I have seen is Indians are doing extremely well in India as well as abroad, extremely well. But unfortunately, somehow, because very recently China has started pulling back their talent back to their country, and they are leading like anything. Many talented people in India, they are here, but they are not being given opportunity, one hand. And there are many people, they are outside the India. Somehow, although there are many institutes at government of India, but people those who are sitting on the front, those who are in the implementation, somehow there is a serious question of their integrity. And that is why somehow whatever wealth we have, that wealth is not being converted into prosperity. Now, why I'm raising this question? Because we all are teachers. We need to see like how this can be transformed, how this need to be, because this need to be changed. If you don't do this, because we need to work as a catalyst for change. If you don't do this, we will be struggling a lot in the coming years. If you look at Malaysia is a very tiny country. But if you see the infrastructure there, their economy is nowhere comparable to India. Nowhere comparable. In spite of that, they are spending ahead of India in R&D. They are spending just now I have seen on Google. They are spending 0.95% of GDP for R&D, and we are spending only 7. I am very happy that now India has established, you must have heard about ANRF, Anusandhan Research, National Research Foundation. Now very recently, Government of India started giving funding to colleges as well as state universities. And PM Usha is again another example. This college has received 5 crore for all the development grants. Like it includes this kind of programs as well as the research infrastructure. My university, Dr. Babasaheb Ambedkar Marathwada University, we have received 100 crores. There are many universities across the globe. So our government of India is, they started thinking everything, there are many policies of government of India, but somehow the people who are in the implementation, they are not honest, unfortunately. And that is why there is a complete lag. So let us hope that in due course of time, they will get themselves motivated to convert this wealth into prosperity. Now coming back to the teachers, but what I believe is, in spite of all those problems in India, as far as research is concerned, let me tell you, my friend, we should be very happy that in terms of number of publications, we are next to China. We are in first 5 top countries. But when it comes to the quality publications, we are well behind. So number is good, quantity is good, but quality, we are still struggling. We are in global rank, we are 14th. And this is where teacher need to play a very important role. Because what I believe is, forget about government. Government is going to do their own job. But it is our responsibility to see that the quality publications are being produced by respective teachers. And therefore, my friend, whenever you will be getting opportunity, don't publish your data in substandard journals. Because don't be part of that flooding. Because there is a over flooding of substandard journals these days. आमच्या विद्यापीठाच्या गेटवर सुद्धा खूप जर्नल्स आहेत, त्याला लिहितात 10 इम्पॅक्ट फॅक्टर, 15 इम्पॅक्ट फॅक्टर. डोंट पब्लिश युअर आर्टिकल because you could be a genuine person. Because unless you publish your data in reputed journal of international reputation, nobody is going to recognize you. In spite of having talent, because this is what I mentioned right in the beginning also, our teachers are very, very hardworking. अरे यार, आपल्याकडे इतकी प्रतिकूल परिस्थिती आहे. Because I always say that whenever you are leaving home in the morning, you never know whether you are going to return back to your home alive. तुम्ही आल्यानंतर जिवंत घरी पोहोचाल की नाही माहित नाही. We have a lot of issues and challenges. In spite of that, colleges मध्ये, because we have very few colleges where you will get infrastructure, very few colleges. Because on one hand, we have said global benchmarking in R&D, like for example ISRO. ISRO is one of the leading institutions next to US. NASA nantar ISRO is the only institution across the globe who has, even in some aspect, ISRO is well ahead of NASA as well. NASA is taking advice from ISRO scientists. IT, we are ahead. We have got IISc, ISRS, IITs, many institutions. But unfortunately, these institutions, looking into the 140 crore, looking into those 140 crore number, these institutions are less in number. Because most of our students, they are taking their education in the colleges and in universities wherein we are struggling like anything for infrastructure. And therefore, there would be really challenge for us to publish data in quality journal. But in spite of that, I would recommend you, whenever you will be having your research output in your hand, please don't publish your data in substandard journal. Identify journal of repute and publish your data there, number 1. Number 2, not only publication, our main purpose is teaching. Our students are for government has given us NEP. NEP is wonderful document for multidisciplinary, interdisciplinary research, skill-based education, overall development. But now when it comes to the implementation, forget about government, forget about university, forget about colleges. It is the responsibility of teachers who should spend their time, enrich yourself with skills, extra skill set, so that you will be skilling our student and you will be ensuring that student would be earning those credit which will help them to stand in the world. And this is what our responsibility is. And third one is, whatever research we will be doing, making sure that somewhere that research is going to be useful for the society. That is very, very important. Because at the end of the day, I'm having some problem with throat, that is why I'm watering. When it comes to the actual societal impact, unless you initiate the R&D activities which based on societal aspect, India is not the whatever wealth we have. मी जे तुम्हाला अगोदर म्हटलंय की somehow our wealth is not being converted to prosperity. To some extent, we teachers are also responsible for that. We need to initiate the projects, the research activities based on the societal issues. Like for example, the teachers who are working in Khandelwal College, they should identify the societal issues in and around Akola with reference to their area of expertise and see whether you will be able to address those. If you could do this, definitely whatever schemes the government of India is coming up, those schemes can be in true form, we will be able to implement. आणि मग मी तुम्हाला जे म्हटलंय ना, I am doubtful about the integrity of the people who are implementing. I am not talking about any officer or any government person. I am talking about the common people. I am talking about the teachers. We should be honest enough to utilize the resources what we have. Like fortunately, you have got enough grant, for example. Now the question is how you are going to utilize the grant. Whether that grant, whatever the infrastructure you will be procuring, whether that infrastructure is going to be useful for the welfare of the student, for the welfare of the society. If you could do this, I'm sure as of now, we are global leader in IT. In due course of time, we will be global leader in every aspect of life. And I do hope that those days are going to come very soon, and we will be able to reduce the index of happiness. Reduce means we will be able to at least first, if not first 10, let us be ensure that we will be in first 50 in terms of the happiness index. I once again express my sincere gratitude to the organizer for giving me opportunity to express my views about this. Thank you very much.
Thank you so much, sir. Through your words, you have explored the research and development status of our country. Thank you once again. Now, I request the President of this inaugural ceremony, Honorable Dr. Taratai Hatwalne, to kindly deliver the presidential address.
आदरणीय मंच आणि उपस्थित पीएम उषा अंतर्गत मिळणाऱ्या अनुदानातून विद्यार्थ्यांना जास्तीत जास्त माहिती प्रत्येक विषयाची अभ्यासक्रमाव्यतिरिक्त अधिक ज्ञान विद्यार्थ्यांना मिळावं म्हणून आपलं कॉलेज ह्या अनुदानाचा उपयोग विद्यार्थ्यांच्या ज्ञान वाढवण्याच्या कामात अनेक अशा कॉन्फरन्स आपल्या झालेल्या आहेत. आजची केमिस्ट्री या विषयाची, फिजिक्स या विषयाची तुम्हाला मिळणाऱ्या ज्या वक्त्यांकडून तुम्हाला ज्ञान मिळणार आहे, अधिक माहिती मिळणार आहे, ते त्याच्यात मध्ये येऊ नये म्हणून काहीच बोलणार नाही. मी फक्त एवढंच सांगेन की ह्या ज्या निरनिराळ्या कॉन्फरन्स आपल्याकडे विद्यार्थ्यांच्या कल्याणासाठी, विद्यार्थ्यांच्या ज्ञानासाठी घेतल्या जातात, त्याचा पुरेपूर उपयोग तुम्ही सगळ्यांनी करावा, जेणेकरून तुमच्यामध्ये अधिक आत्मविश्वास, अधिक सकारात्मकता निर्माण होईल, इच्छाशक्तीमध्ये वाढ होईल, क्रियाशीलता वाढेल आणि महत्वाकांक्षा सुद्धा तुमची वाढेल, जेणेकरून तुम्ही आज जे आपल्याकडे अतिथी आलेले आहेत त्यांच्या इतकंच तुम्हीही यश तुमच्या भविष्यात मिळवाल अशी मला सगळ्यांना मी आशीर्वाद देते आणि माझं अध्यक्षीय भाषण.
Thank you, madam. As usual, your few words go a long way. Thank you so much. Any endeavor of this scale requires teamwork and cooperation from everyone. To express gratitude towards them, I request Professor Rohan Shirsat sir, the organizing secretary of this conference, to propose the vote of thanks of this inaugural session. And immediately we are going to have the keynote session right away.
Thank you, madam. Good morning to one and all. Thank you. It's such a prayer that cannot be touched or seen, but it must be felt by the heart. So I feel honored and privileged to get this opportunity to introduce, to propose my vote of thanks on this special occasion of International Conference on Emerging Trend in Physical Sciences. So on the behalf of organizing committee, I would like to express my countless gratitude to the Honorable President of this inaugural function, respected Dr. Taratai Hathwadne, who always motivate us and engage her precious time with this conference. I convey deep regards and hearty thanks to our guest of honor, respected Professor Dr. M.D. Shirsat sir, Dean of Faculty of Science and Technology from Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, for his gracious presence. Sir epitomize the real fact of the research in the world of atom to AI. Sir, we will ever remain grateful to you and we thank you for being with us today. I extend my deepest gratitude to our esteemed Chief of Guest and Keynote Speaker, Honorable Dr. E. Seng Tan from Sunway University, Kuala Lumpur, Malaysia, for inaugurating this session. Thank you so much, sir. I would like to thank all the honorable delegates, resource person, chairman, who beyond the intellectual brilliance, who hold a special place in our heart. My sincere thanks to the respected officiating principal, Honorable Dr. P.S. Pandey sir, for his guidance and support at various stages. I would also like to thank the convener, Dr. S.K. Devde sir, and treasurer, Dr. H.J. Harat sir, for their flawless efforts. I am very much thankful to the National Sponsoring Agency, that is PM OSHA Grant, to the college, because without their support, it would be impossible to organize such conference in very smooth way. I am also thankful to all the committee members, all my faculty colleagues, non-teaching staff member who always stand with us and motivate us. Special mention to all the participants who bless us with their presence. To the technical team, thank you for ensuring that all our sessions are running very smoothly. Your expertise and dedication are greatly appreciated. Thank you all once again. Now, with the permission of chair, this inaugural session is now over. Thank you.
Thank you so much, sir. After this inaugural session, we are immediately going to have the keynote session. We shall move towards the keynote session. I request Honorable Dr. Yi Seng Chan sir to kindly deliver his keynote on the topic Chemical Molecular Dynamics, Structural Transformations. Honorable Chang sir is going to deliver his keynote on the topic Chemical Molecular Dynamics, Structural Transformations.
Okay, without further ado, let me just introduce myself. I'm Yi Seng. I come from Malaysia, Kuala Lumpur, so working in Sunway University in the research center, Sunway Biofunctional Molecular Discovery Centers. And first of all, I would like to appreciate the organizing committees, organize this wonderful event, and then giving a precious time slot for me to share my research interest. One of it for the crystallography, which is a structural transformations. So without further ado, I just giving some revision regarding what is structural transformation. Actually, is a kind of solid state science where applying the crystallography technique to determine the structure in the solid state, and upon the stimulation, it will transform from one form to another form, which basically is a fundamental science, but we can link with the functionality later. I will show some example, and then normally involved is the conformation change, or the bond breaking or reformations. So, okay, in the past, when researcher finding that is a transformation happen is very exciting, and then doing some fundamental science, we can publish in a good paper. Like just now, the dean of mentioned that nowadays, if we only publish in the fundamental science, it's very difficult to publish. There's no one interested. So must link with some functionality. Otherwise, just like my PhD supervisor always talk to me, if you want to do a structural science, a transformation science, it's very luxury research. So you must link with some functionality only is a practical research. So however, I want to highlight is the structural transformation phenomena is getting attention. So one of the famous material science researcher from Kyoto University actually is one of the pioneer for coordination polymer, or another word is metal organic framework. It's a type of porous material. He tried to define the PCP into the few generations that include the third generation I want to highlight here. He's talking about using the structural transformation concept to link with the functionality. So the structural transformation is something happening now. So I want to bring you, for today's presentation, I divided into the three parts. I will talk about some example for the stimulation, the challenges for this research, and then the benefit for this research. So everyone can persuade the funder or superior to conduct this kind of research. So the first example is using the temperature induce the transformation. Actually, I make it to another view. So actually, I synthesis the compound is very easy. Just use a cadmium dithiaphosphate, react with the 4-pyridine arazine. And I managed to get 4 structures upon the temperature stimulation. And let me arrange in the scheme. So room temperature is an alpha form, only 1 structures. But as you can see at 100 Kelvin, there are 3 structures. This is upon the treatment of the samples. If I'm ramping it with the rate 10 degrees Celsius per minute, it will form this beta phase. But if I just place the crystal from room temperature into the cryostream with set to the 100 Kelvin, so it is possible to form this delta and gamma. But honestly tell you, if even using the quench cold method, that is a high percentage it will form beta form. 95% will go to a beta form. By the way, there are 5% that possibility go to these two. I have a number of trial, but the result outcome is this way. But once they form the delta and the gamma form, it actually will turn to the beta, hit until 140 Kelvin and 120 Kelvin respectively, and eventually back to the alpha. This example just to tell you that same stimulation, if you're using different treatment, you will obtain different structures. So end out is 4 structure I can have. So the next one is talking about the solvent-induced transformation. Actually, it's divided into 2 parts. This is my PhD program project. So initially, I published is from the alpha turn to the beta. So the second part, I discovered actually having another 2 structure and eventually form this very complex transformation system. So this is irreversible. It's due to the moisture from environment that absorb into the mother liquid and eventually induce a transformation to form this dimeric structure. Okay. Okay. What I want to highlight is this image. Actually, the reason I found the transformation is because the change in the crystal nature. As we can see, initially I have this crystal and I obtained the structure already for block-shaped crystal. So I regrow the compound in a bulk material so I can do the characterizations. I found that it's a needle crystal. I bring this crystal to the operator. Actually, he refused to run my sample. Again, he said, this compound already run. I have the structure already. Why you need to repeat? So I learned how to operate the machine and do it myself. Eventually, I proved to him. I say the needle crystal is different structure from that one. So that is the story why I found that transformation. Well, another part why I have the idea to do to discover the other two structure is because I recall that when my supervisors proposed this project to me, is showing me one coordination polymers with the ethanol solvate, but this project without ethanol, so I performed the ethanol regrow. The block-shaped crystal is very boring. It's dimeric and easily to obtain. But this part, when I regrow, I see the material turn into the fluffy forms. My senior told me, don't waste time. That is impossible to have crystal, but I don't believe him. So I put in under the microscope, I think part of his speech, he thought is his advice is correct because mostly it's not suitable for the single crystal diffraction. But if you observe properly, there are some crystals grow in the size suitable for the single crystal diffraction. So end out, I have the structure and complete the story. So this example is to tell you the change in the crystal physical appearance will tell you something regarding the crystal transformation. So the next one, we're talking about how pressure will induce a transformation. That is one group having the morph coordination polymers, and they put into the pressure device that is a cell and with filling with the DMF and increase the pressure from the ambient is this structure and then turn into this structure with 0.33 gigapascal. So you can see the coordination geometry is not in the uniform pattern and it is remain the same. But if you look carefully, there are some changes. This is to accompany change in the pressure. So this compound can remain as the compound even in the harsh condition, in the high pressure. So in the unit cell parameter, we can see the Brownian system remain the same, is still tetragonal, but you can see the space group is from the I system turned to the P system already. For sure, the LBC also the different. But this research group not only stopped at the moment at the stage, he also used another solvent to transfer the pressure in the attachment. So this time using the ethanol. You can see the coordination geometry is different from the previous one. This is uniform. And after the pressure increased out to the higher pressure, 1.19 gigapascal, as we can see, the whole framework is tuned already. From the square pattern, turn to the diamond shape pattern. And the units are also telling us they actually doing the graduate increase the pressure study, found that they are tetragonal turn into the monoclinic eventually. So this is different from the previous example. The Brownian system remain the same, but this one is obviously totally different. So again, another example telling that the structural transformation can ensure the compound still remain intact in the harsh condition. Well, this is another example that performed by the Japanese group. It's very interesting. You have a gold compound, and then the crystal initially is a very low emission, like a blue one. And then he just used a needle, just pop one area, as you can see, it turned to the yellow already. But just leave it for some time, it will grow until the whole crystal become the yellowish emissions materials. So this is the compound. The orange ball actually is a gold. Initially is 5.7 angstrom distant, so there is no go-go interactions. After they give the mechanical stimulations, they turn to the 3.2 angstrom. It have the go-go bonding already. So for easy visualization, I have this plot. As you can see, there is no go-go interaction, there is a go-go interaction. Besides that, you can observe that the aromatic ring is rotating and become a flat in the planar form eventually and enhance the better packing of the crystal. So the unit cell telling us from triclinic to tetragonal, and I want to highlight is the density. It increased as having the better packing of molecules. So from 2.17 to be 2.24 gram per cm cube. So they proposed the hypothesis where the force applied and then will cause some of the molecule having a new arrangement. And the new arrangement not only staying there doing nothing, it will bring the signal to the neighbor molecule to have arranged in a new form. So eventually the whole crystal will transform from one form to the other form. And this hypothesis just can be tested and tested successfully correct by placing two crystals together, just touching each other. One is transformed crystal, one is original crystal, as we can see blue and yellowish. And after 15 hours, we can see the whole crystal turn into another stimulated form. So this is proven that, this example proven that if using a slightly mechanical force will cause a transformation. And the transformation also can spread throughout the crystal by using this seeding, or another word we say touching the method. So I have another collaborator send me the sample. He proposed this compound. And then actually he sent me 2 bottles. He said, one bottle, if the sample not good, take from another one. At the time I say, yes, I will follow whatever you say. But actually, I'm doing analysis for both bottle samples. And end up is I having 2 structures. One is alpha and beta. For the alpha, having 4 molecules in the asymmetric unit. And while the beta, only 1 molecule. So you will say they are the same. But if you overlay them together, the 5 molecules, actually, they are not superimposed. So you can see they are different. So while I was asking him what you did differently for these 2 bottles, before he replied me, doing the quick interaction study and found that basically the network is very similar, but with some of the primary interaction NH bondings is over there to holding the 2 molecules together. But if you see properly, there are some interaction missing after the transformation. So the CHO interaction is missing, and some small circle, you see the conformation, they are changing. Well, after I doing on time, after I doing this analysis, he just tell me, actually the first bottle is recently grown samples. Another bottle is growing for some time already. So what I interpret is that is a time scale transformation. I dissolve his compound, everything in the ethanol, and then filter it, leave it at the room temperature. I start to using the PXRD as my monitoring method. The red and blue is the stimulation pattern for the alpha phase and beta phase. For the day I regrow the sample, the crystal form already, and I take out some and do the analysis. On the day 0 is 100% alpha. Day 1 start to have a small signal, means that they start to transform to beta. And then until day 9, almost all the sample turn into the beta with slight % of the alpha form present, and day 12 completely finished. So throughout this process, I do not apply any stimulation, but I still curious why the structure will transform. So I sent to my colleague who performed the chemical calculation and found that the energy for the beta form is much lower than the alpha form. Means that this compound actually is forming the alpha form first by the kinetically stable methods, where the molecule come together. They think this is a very stable form, it form a crystal first. But end up the molecule feel that after some conformation change, it will go to the better stability. So it turns to the beta forms. Okay, the next one I will talk about the gas-induced transformation. So normally it's applied for the porous material. This group from South Africa, Len Barber, is very famous for doing these morph things. And he found that there is structures with the DMF solvated, and he performed the activation, removed the DMF. It ends up is turned to this non-porous triple interpenetrated structure. With the gentle activation with 80 degrees Celsius, it remained double interpenetrated, but remove all the DMF. It can back to the original form by immersed in the DMF for 24 hours, or it can go to another form by heating up to 120 degrees Celsius for 12 hours. And then he is not stopping that. I just turned into another topology view, easier to understanding. So he used these 2 activated compound to perform the gas option. And interestingly, only this having the positive result can see that the ethane, propane, and butane having the gas uptake, but not methane. So he just decided putting the crystal inside this gas environment to see what is happening. And That is a structural transform, and then to accommodate the inclusion of the gas, so end up having these three structural transform data. But just now I say the gas induced normally apply for the porous material, but how about non-porous? I found there is one example very interesting. This Chinese group, they developed a new compound, organic compound. Not surprised if you grow in the crystal, it is non-porous at all. But I don't know what is the rationale they put the crystal inside different gases. I don't know. But one day if I meet them, I will ask them in person. So they put into a ethane gas, acetylene, propane, and propene. So the molecule automatically will tune in the way to form a 1D channels that is a void that allow the gas to fill it accordingly. And every structure is actually different, especially you compare this and this compound. So the tuning the way is different. And then not only the hydrocarbon, you also put in the environment, the CO2 environment, and it can use for CO2 capture also. This is very interesting. But again, I still don't know what is the rationale. Compared with the previous one, at least the researcher will do some gas option, know that is uptake. But this one, without anything, they just proceed with this. Okay, the next stimulation is the light stimulation. Normally is used for the 2+2 cycle addition. That is one of my research interests also. And I found one literature reported data. It's very interesting because normally this is an irreversible transformation. But this case is reversible. Let me zoom into the area. Okay, this compound having the olefin pair is closely packed and parallelly aligned to each other. So if you irradiate with the UV light 360 nanometer around that, it will form the cyclobutane. And this compound, again, if using higher energy, it will back to the original form. This is good for molecular switch study. Let's say this compound is functioning at this stage. You just irradiate the compound with the 360 nanometers. If you don't want the functionality happens, you just irradiate with another wavelength. So it can use for the molecular switch purpose. So another example is this compound actually is another coordination polymers, where having this part red and the green part actually is a disordered part, where the complex one, the green having the higher occupancy more than 50%, and the red one is less than 50%. After the irradiation is turned around, so the red one higher occupancy while the red one. You might say still disordered, the structure still the same. But if you look carefully, the aromatic here, they are different. And the researcher, they think this is not strong enough, so he linked with the functionality where doing the CO2 capture at room temperature as they performed 3 experiments. So first one is the black trace, where the sample without any UV light irradiation, having the outtake, CO2 outtake. And after the red trace is with the, throughout the gas option process, with the presence of the UV light and having the higher uptakes. So the third experiment is on and off of the UV light, as we can see here. When it is off, it follows the black trace profile, and it is on, it follows the red trace profile. So it is proven that this light stimulation will cause the structural transform, and it will bring the effect to the application, which is the CO2 capture. So now already, I already showing you some example already. Move to the challenges for this research. So okay, this is the diffractometer developed by the Bragg's father and sons. That is a Nobel Prize that is very famous in crystallography. So it's developed in Cambridge University. So when they're doing the first structure is sodium chloride, 2 atoms, right? They spend for months to develop, to obtain the structures. So the second thing, in the old day, there is no polymorph concept. So people will say, if same compounds only having the, a dedicated compound only have one structure in the solid state. So they will say, I will not spend time to remeasure the same, the same sample. So there is no structural transformation in the past. Besides that, also due to the limitation of the technology and invention, like nowadays we have this pressurized device attachment and this cryostream device that can doing the tuning on the environment. So this solves the problem, the technology. The second thing is, if we synthesize compound and crystallize, we normally having the structure already, we deposit into the CCDC, which is a Cambridge Crystallography Database Centrals. And that is a software, we can draw something and then ask the software to see whether someone published a similar structure or not. If you having some hit and you bring the sample to the researcher, you know what will happen? They're very angry. They'll say, no, don't waste my time. Don't send the sample to me because already have the structure. Just like what I told you during my PhD time, I sending the needle crystal, the operator say no. So how to solve this problem? You have to find a researcher who really have the interest in the structural transformation or the polymorph, then this can be solved. The next problem is the crystal quality. This is the example just now I showed already. So I pick up one crystal at 298 Kelvin. The crystal looks very nice. It's a single crystal. When cooling down, the crystal crack. Typical operator will say, I will not run this sample. Because the textbook telling us if you want a good diffraction data, it's single crystal. In multiple crystal, the crack crystal means it's a multiple crystal already. They normally say, no, I will not run for you. By the way, as the knowledge get, the very developed very well, there is one technique called twin strategy. So actually, I using the twin strategy and finally I resolve the data and it is publication level. So nowadays, the software development help us to solve this problem. For sure, if you don't do the 100 Kelvin, no 209 Kelvin, heat back the sample analysis will be performed. Again, this can be solved with the right crystallographer to help you. I will show one of the unpublished data. This is halfway, and then actually this is a DSC curve. It involves 4 structure actually. You can see 3 transformation. There are 3 peaks there. I encountered one problem actually. When cooling the crystal to a given temperature, the crystal will break and explode. So part of the crystal will disappear. So it will affect the diffraction collection. By the way, I do not giving up. I tried more than 50 times and eventually I have this data set. I spent a lot of time, especially the last one. You know what I do? I using the lowest, the slowest rate for the cooling, which is 1 degree per hour. So you try to imagine the problematic part will be negative 58 to negative 108 degrees Celsius. I spent days to cooling down it and eventually the crystal do not break. It's just elongated and the diffraction quality is still very good. So luckily I have this data and complete this part of the study. So again, this problem can be solved if you engage with the right crystallographer or you turn yourself to be the right crystallographer. Just now I'm saying solving the problem based on the crystallographer, but actually the technology also helping us. If you have a cracked crystal, small pieces, but good diffraction, you can go for this. The center one is the electron diffraction, but this instrument is very expensive. If you have a cracked crystal and poor diffraction sample, you should go to the synchrotron facility. So it means that this problem can be solved either is a crystallographer or also the technology that are available now. This is very serious problem. If we want to have a sample that can undergo the structural transformation, we must make sure it have the flexibility. So, but until today, there is no strong strategy for us to design a compound that 100% it will undergo the structural transformation. What we can do is we have to make sure include some flexibilities, moiety in the samples. For example, I'm giving 3 of here. This 2 is guaranteed it is working because just now I having the temperature in this structure is based on this and bond transfer rotation. But the second one is very famous, CH2 is very highly flexible. But the third one is famous, also flexible. If you irradiate with the UV light, it will undergo the tautomerization from the cis form to the transform to the cis form and cis form back to the transform. But you have to remain how do I bear in mind with the logical thinking? You have your hand put on top of the floor. You can flip it easily. You try to imagine there is 100 of people step on your hand, 100 people. That is a very big force, right? You cannot flip your hand. So this compound also in the crystal, there is a lot of molecules that sandwich it. Even though the UV light provides the energy enough for it to undergo a tautomerization, but it cannot happen because all the forces hinder it to happen the transformation. So we have to apply the logic to design the compound. Second thing is more trial to synthesize more compounds, you are having a high chance to get the compounds. So I keep on synthesizing compounds so I can claim myself as a synthetic chemist also because I tried all the method. And then also diffraction experiment, don't miss anything. If the parameter tuning is easy, like variable temperature, just do the simple one, room temperature and low temperature 100 Kelvin to see whether it has some different or not. If yes, you further investigate it. Now, move to the last part, will be very short part, is talking about the benefit of this kind of phenomena. First is, just now I mentioned already, molecular switch. The stimulation is a switch. So you can ask the compound transform in this form and another form. So some of the compound, let's say alpha form is functioning, beta form is not functioning, and you don't want the process, throughout the process is non-continuous, non-continuous functioning, I mean the process, you can suddenly ask the compound turn into the form that is not functioning. So that is an application. Nowadays we are talking about this. And secondly, just like myself, I encountered a problem. To having this compound, for these two compounds in crystal, no problem. For bulk material preparation, for this compound is good. This is actually a DMF solvated coordination polymer, while this one is anhydrous. But the problem is this anhydrous always come together with impurity. No matter what synthesis method that I apply, that is not working. Until one day I found that actually they are transferred, they can undergo the structural transformation. So I using this high purity 2 gram of this compound to perform a similar process and end out I can obtain 100% pure of the compound that I cannot obtain through the normal way. So this is one of the benefit for the structural transformation. And the third one, you see the creature will change the color, right? So means that in the different, to surviving, it will having changing in the, its appearance to keep himself to hide, right? So do the chemicals. If chemical in the harsh condition, sometimes it will decompose. If decompose already means it is no function at all. So if you want to make sure your sample having a longer, a wide range of the environment parameters to survive, remain in as it is. So transformation maybe is another way. If let's say in the high pressure, it will slightly tune their way in to accommodate with the pressure, but the compound still remain intact. Now I move to the conclusion part. I just want to say structural transformation actually is a very fascinating research where you can see the compound transform to one to another. By the way, this is a luxury research if you do not link with the functionality. While engaged with the right crystallographer and using the right technology, you will solve most of the problem. And this type of research actually in the past is growing very slowly, but nowadays it's getting more and more people looking at, the attention and then working on it. And that is a huge space for us to expand. For example, we can find out more applications that direct or indirectly link with the structural transformation. For myself, I recently have one project is working on it, is tackling the global warming, but I'm not yet complete, I cannot disclose much. That is directly can use this phenomena to help to tackle the global warming. So if you find something new, then you will be like a benchmark for the field. Okay. Thank you for your time and attention for my talks. If you have any question, I think the time is not enough for question, is it? Okay, so if you have anything, you can email me. I will try to explain as much I can. Thank you very much.
Thank you, sir. Through your talk, you have explored the topic chemical molecular dynamics, structural transformation at length. I express our deep felt gratitude towards you for sharing your knowledge and expertise. Thank you so much.
Thank you.
We are moving towards the first technical session, writing.
Hello, can you hear my voice?
Hello. Professor Sai, good morning.
Good morning. Can you hear my voice?
Hear me? Hello.
Hello, can you hear my
Professor Sai, are
voice?
you able to hear me?
Yes, I can hear you.
Hello.
Hello, can you hear me?
Professor Sai, are you able to hear me?
Yes, I can hear you.
Hello. Hello.
Hello?
Professor, are you able to hear me?
Yes. Yes, I can hear you.
Yeah, you can hear?
Can you hear my voice?
Okay.
Yes.
Okay. Now say, I will request station coordinator to start the. Hello, please.
Hello. Okay, great.
Maybe announcement. Okay. Okay, Professor. Thank you.
Thank you.
I request Dr. Moe sir to please take his seat on the dais. Good morning, distinguished dignitaries and dear participants. I welcome you all in the first technical session of International Conference Emerging Trends in Physical Science. In this session, we have Professor Dr. Gajanan Mure sir, Department of Physics, Santa Gadge Baba Amravati University Amravati as the chairperson. And we have Professor Meng Lin Sai, Department of Material Science and Engineering, National University of Science and Technology, Taipei, Taiwan, as a resource person for this session. I have immense pleasure to introduce our resource persons. First of all, our chairman for this session is Professor Dr. Gajanan Mure sir. Presently, he is professor and ex-head Department of Physics, Santa Gadge Baba Amravati University Amravati. After completing his MSc in Physics in 2002, he joined University Department in March 2003. He completed his PhD in 2009 from Santa Gadge Baba Amravati University Amravati, and presently he is CNET member in Board of Studies, Humanities and Applied Sciences, and chairman of Board of Study Physics in Santa Gadge Baba Amravati University Amravati. He is the coordinator of postgraduate teaching department of Dr. Babasaheb Ambedkar Thoughts and ex-coordinator of Buddhist Studies, HGBAU Amravati. His research areas are non-linear optical properties of material nanoparticles to bulk crystal, optical biosensors, and upconversion phosphors. 7 students had successfully completed their PhD research in his guidance, and 6 students are pursuing their PhD work under his guidance. His 144 research papers are published in international journals, and he contributed 30 papers in international conferences and 71 in national conferences. He organized 6 conferences till the date and delivered 14 invited talks in various conferences. He is the editorial board member in International Journal of Applied Physics, editorial board member, Science and Technology, Scientific and Academic Publishing USA from 2011 to 2013. Is a member the Mineral, Metal and Material Society and Indian Physical Society also. I request Rohan Shirsat sir to welcome and felicitate him. Thank you, sir. Thank you, sir. Now I take this opportunity to introduce our esteemed and renowned resource person, Dr. Meng Li Sai. Is currently an associate professor in NTUST. He joined this university since August 2018 as an assistant professor. He received his BS degree in 2008 from National Tsinghua University, Hsinchu, Taiwan. During his PhD career, he studied the fabrication of single atom tips, designing, maintaining ultra high vacuum system, development of 2D devices, SI organic hybrid solar cells, SI-based water splitting devices, 3-fifth based harsh electronics, and low dimensional photo detectors. He visited King Abdullah University of Science and Technology as a visiting student and received PhD degree in 2016. He then worked as a postdoctoral research fellow at National Tsinghua University from April 2016 to April 2017. He worked in AU Optronics as a senior engineer in the liquid crystal display, that is LCD, array and cell design platform unit from April 2017 to June 2018. After joining NTUST, his main research interests are low temperature and large scale growth of 2D materials and synthesis of air stable inorganic perovskite quantum dots for display application. And his many papers are published in the journals of repute. His topic of the session is functional films for the next generation display technology. He has joined us virtually. I welcome you, sir. And now I request Professor Meng Lisai, sir, to deliver his lecture. Sir?
Okay. Okay. Thank you for the introduction. Can you hear my voice?
Yes, you're audible, sir.
Okay. Let me share my screen first.
Hello?
Yes. Let me share my screen. Okay. Can you see my screen now?
Yes, sir. Yes, sir.
Okay.
Visible.
So let me start my talk, okay? Good morning, everyone, and it's my honor to be invited to join this conference. And the topic that I would like to share today is the functional films for the next generation display technology. And as introduced by the chairman, I am currently an associate professor in the Department of Material Science and Engineering in National Taiwan University of Science and Technology. Okay, so this is a brief introduction of what I have done over the years, both when I did in some part of the research I carried out in during my PhD career, and some during my postdoc career, and then some in the industry, and then some of the studies what I am currently focusing on. Okay, so basically I mainly work on the synthesis of perovskite quantum dot lead halide perovskite quantum dot for the light conversion behavior, and later on I will introduce briefly why we can use this kind of material to improve the color performance of our functional films. And then another part of my research focus right now is the growth of two-dimensional, especially semiconductor materials such as molybdenum disulfide or the molybdenum diselenide. Okay, and these are more related to the electronic devices such as field effect transistor. I'm not. I think I would not have the time to share with you today. But later on, if you have any question, if you need some sample, you are welcome to contact me personally. Okay. And then since I work on the device fabrication of nanomaterials, so I also spent some time in doing the electron beam lithography technology to fabricate some nano devices. For example, you can see here is some two-dimensional material, and we try to come up with some PN junction contact and use the e-beam lithography to define the pattern we use for the electronic device fabrication. Okay, and then I also spent some time to do some microstructuring and the nanostructuring on the silicon wave substrate, and then to incorporate it with some organic material, conductive organic material, to come up with organic and inorganic hybrid solar cell. And then recently, after I joined the industry for 1 year, I become more interested in the display applications. Okay, so that's the main topic I would like to share with you today. Okay, so this is the brief CV as introduced previously. I spent 1 year and 2 months as a senior engineer in the liquid crystal technology department in AU Electronics before I joined NTUSD. So some part of the study that I share with you today was based on the technology we did before in the industry. Okay, and then after I joined NTUSD, I still have some collaboration with some of the members there. So I started to work on the color performance enhancement and also the viewing angle enhancement of the functional film. Okay, so my research here, you can see today I will focus on the functional films development and using the especially quantum dot and the structure on top of the functional film to adjust the viewing angle performance of the display. Okay, so this is the outline for the two main topics that I want to share with you today. The first one is the light diffusion films for improving the viewing angle performance, and the second one will be the high performance perovskite quantum data what we fabricated in our lab, and then we mix them with cellulose nanocrystals to become some paper-like films with improved stability. Okay, so just a basic concept of the displays. Okay, so currently there are mainly three different kinds of display. One of them is the TFT LCD. For the TFT LCD, we first come up with a backlight unit. Usually we have like a white emitting LED for the backlight unit, but later on I will show you that for some high-end models we will use like a blue light. And then try to incorporate it with one backlight enhancement film, quantum dot enhancement film to convert to the high purity green emitting and red emitting light. Okay, so after you add the quantum dot film, the overall you will also see the white light, but the white light will consist of very pure emitting blue red and the green emitting light. Okay, so that can make your after the light pass through the color filter, the color performance will be largely enhanced. Okay. And then for the LCD, one of the properties that we have two polarizer for controlling the electric field after passing through the polarizer, right? And then we have a liquid crystal layer. By adjusting the electric field across your liquid crystal, you can actually change the orientation of the liquid crystal to interact with the light passing through. Okay, so after you interact with the light passing through, the electric field of the light may possibly change depending on the orientation of the liquid crystal. And then after, so you can see the liquid crystal here can act as a switch to actually tune the transmittance of light passing through the color filter. So by changing this, the transmittance ratio for different pixel region, you can come up with different color at different region for your display. Okay. And then for the OLED device, you can see it's something somewhat different. Okay, you have two electrode, and then for those of you working on the LED, you know that for organic LED, you need to have some carrier transport layers or the carrier blocking layers. Okay, so you can see one side will be covered with an electron transport layer, and one side will be covered with hole transporting layer. Okay, so by injecting the electron and hole, they tend to recombine in the active region. Okay, so you can have light emitting coming out, and then by putting different type of organic material, you expect to see the color difference at this different pixel area. Okay, and then one thing that I want to mention is for the OLED device, you still have a polarizer. Okay, but the polarizer usually is not for controlling the emission light. Okay, usually this polarizer is designed to suppress the reflection of your display under ambient light. Okay, because as you can see here, OLED sometimes there are a lot of metal circuit electrode. So the metal circuit electrode will induce a significant reflection. Okay, so that under the ambient light, if the ambient light is very strong, okay, you will have your display will be look like a mirror. Okay, so the polarizer will be placed on top in order to suppress the reflection effect from your display. Okay, and then recently people try to come up with some micro LED. Before we only place the LED at the backlight unit, right? And we try to use some prism or the diffuser to improve the uniformity of the light at the backlight unit, right? Okay, but replacing with the micro LED, we can remove the light liquid crystal layer. We can remove the color filter layer. Okay, so you can expect the efficiency can be boosted significantly. Okay, but one thing challenging for this type of display is the transfer procedure. Usually for the inorganic LED, we try to grow it on top of sapphire substrate. Okay, but eventually your product may be on the glass substrate. Okay, and so that you need to come up with some transfer technique, and then sometimes you will fail. Okay, so the fail will require additional repairing process, and the repairing process will increase the overall cost for the micro LED. So now the challenging part for the micro LED display is not in the technology, instead it's in the mass production cost. Okay, so you can see that a micro LED at all kinds of conference or demos, okay, over the world, okay, but for each micro LED, maybe the cost itself is like a 10 million, no, not 10 million, 100,000 million US dollar. Okay, so it's not affordable for most of the household. Okay, so still currently the mainstream are still LCD display and the OLED display. Okay, and my research back when I was in the industry was focused on the liquid crystal display in order to improve the viewing angle behavior. So what's the viewing angle behavior? As you can see, there are actually two modes for the VA for the liquid crystal display. One mode is called the vertically aligned liquid crystal display, and the other mode is called the in-plane switching IPS liquid crystal display. Okay, the main difference in these two type of display is mainly originated from the orientation of your liquid crystal at the off state and at the on state. Okay, so you can see here, for the vertically aligned, it means that the orientation of the liquid crystal is perpendicular to your panel surface. Okay, so when you have a orientation like this, the short axis of the liquid crystal usually don't interact with your electric field of the light. Okay, so it does not change the electric field. That means because you have two polarizers perpendicular with each other, so if you don't change the electric field, you will have black image coming out from the vertically aligned LCD at the off state. Okay, so if you try to turn it on, what will happen? Okay, your liquid crystal will first tends to rotate to parallel your panel surface. Okay, and then based on the electric field you applied, okay, it will adjust to a certain angle parallel with your panel surface. Okay, so the angle you change, okay, actually can interact with the electric field of the emission light, right? Oh, so that the transmittance of the light can be adjusted, okay, that way. Okay, but as you can see here, that means that your short axis, if you light coming to the short axis of your liquid crystal, there's no interaction. But if you your light entering the long axis of your liquid crystal, something will change. The electric field of the light will change, right? Okay, and for in-plane switching, even in the off state, okay, it can be arranged at a certain angle. So after light passing through, it will change 180 degree or no change. Okay, so that means that you are trying to for in-plane switch, after it enters the liquid crystal layer, it will change to one cycle, okay, but still be blocked by the top polarizer. Okay, so this is something happened. The main difference between IPS and the VA liquid crystal. Okay, so based on the orientation of a liquid crystal, you may expect something to happen. Okay, what to happen if your liquid crystal is misaligned, light leakage problem will be coming out. For example, if you need to adjust to 0 degree, but it's not aligned accurately. For example, if it goes to 1 degree, then maybe there will be some light leakage problem coming out in plane switching. Okay, so usually we will consider the leakage in the normal direction for VA will be smaller, for the IPS will be larger. Why? Because for VA, you have two different axes for the rotation. Okay, so for the off state, since it's oriented parallel to your panel surface, okay, so you can ensure the interaction between your light and the liquid crystal to the minimum. But in plane switching only rotate in one axis. That means if you have a misaligned liquid crystal, it will cause leakage in the normal direction. So usually we will expect the contrast ratio for the IPS mode LCD to be lower compared with the vertically aligned LCD. Okay, but for the vertically aligned LCD, there's another problem. Another problem is the angle problem. Okay, the viewing angle problem. As you can see, if the if the liquid crystal is aligned this way, if you stand normal to your TV or your display, okay, you will see the short axis. Okay, but if you stand at the larger angle, what happens? If you stand at a larger angle, you see the long axis. Okay, so you will expect some light leakage problem to be coming out in the large angle direction. Okay, so this will cause a problem. We usually call it the color washout problem. Okay, that means, as you can see on the right figure, okay, the x-axis is the gray level all the way from 0 to 255. Okay, and the transmittance in the y-axis also indicates the intensity you see in front of your display. Okay, so usually we will tune the on-axis gamma to be what we call the gamma 2.2. It means that you have an exponential increase with the gray level with the power of around 2.2. Okay, but after you tune the on-axis gamma for the vertically aligned display, what happens? Okay, if you try to measure the large angle gamma, something will happen. You can see here, the curve here is no longer gamma 2.2. It becomes closer and close to 1, to linear increase in the intensity of light. Okay, this will cause something to happen. This will cause at the mid-gray level, such as like from 30 to 192, okay, you will have a light leakage problem. Okay, so this will induce, you can see here, the color washout. It will make the performance of your viewing experience to be largely affected. Okay, but for the IPS, since it is only rotated along one axis, okay, so you can see even you have a leakage problem after you tune the on-axis gamma to gamma 2.2, you also have an off-axis gamma to gamma around close to gamma 2.2. So even though you have a light leakage problem, but the leakage problem is in the all directions. Okay, so you will have more uniform viewing experience for different angle. Okay, so however, for high-end models, usually we try to have a higher contrast ratio as high as possible. Okay, so for in-plane switching, usually we expect to see on cell phones or notebook. Okay, but for large-scale TV, usually we still expect to use a VA LCD, but we try to improve the light leakage problem. Okay, so the following I will show you how we can what kind of approach we can use to improve the viewing angle performance. Okay. So one of the technique we can use is to use the multiple domain, okay, vertically aligned liquid crystal in order to improve the viewing performance at different angle. Okay. Supposedly we have one domain, but VA LCD. What happens if you watch from this direction? You will see the long axis, right? So you can see if there is light leakage problem, you see white screen. Okay, and if you watch from this direction, you see the show axis, so you can see black screen. If you watch normal, in the normal direction from the display, you see gray image, right? So you can see there are large different, okay, for different direction, okay? But if you try to make two different domain, you try to separate one pixel into two pixel, and half of the domain is the liquid crystal is oriented in this direction, and the other half oriented in another direction. What happens? Okay, you will see half black and half white from large angle, and you will see gray image from the normal direction. Okay, so for this, you can see if your pixel is small enough, your eyes will automatically average this two half. Okay, so for all the direction, you can see gray image. Okay, gray image. So this has been widely adopted to improve the color the viewing angle performance in the display. However, there's a problem. Okay, we can try to separate it in, for example, if two domain is not enough, we can use four domain, A domain, and also use like if you have neighboring pixel, you can use pixel based or subpixel based design. Okay, this is more complicated, so I will not go into the detail. Okay, the concept is just try to separate your domain. Okay, but by separating your domain, one problem is created. As we know that the light in the liquid crystal display was originally from the backlight unit. Okay, so typically the transmittance, the actual transmittance for your liquid crystal cell is around like 3% to 4%. Okay, and by adopting this technique, if you try to separate the domain, large amount of additional circuit is required in order to control the orientation of the liquid crystal, right? Okay, so for this, you will continually decrease the transmittance of your liquid crystal cell. Okay, so so if you try to like improve the performance, you will sacrifice the transmittance. That means you will waste more power. Okay, if you reduce from 4% to 2%, that's a 50% loss in the overall power, right? Okay, so people try to come up, is there any other technology can be used to improve this kind of problem without doing the multiple domain design? Okay, so back in the industry, we try to design some films. It's like the films you attach, it's like the protective film you attach to your display, okay, to protect the surface of your glass, right? But additionally, we try to come up with um, a refractive index difference design using different structures. Okay, using different structure, we can choose to design some diffraction structure, or we can try to use some refraction structure. So it's like applying a lens on top of your display in order to change the direction of light coming out of your display. Okay, and these are the software you can use to do some simulation. And after you do some simulation, you can like ask a vendor to try to come up with the final film product and then attach to your display for the further demonstration. Okay, so this for the underlying concept, we can go back to the basic physics. Okay, for diffraction, for example, you have a diffraction equation, right? So we try to use, because the display consists of three different color filters. Okay, each provide different wavelengths for the light coming out of the display, right? So in order to evaluate the overall effect, we need to first separate it into three different colors, and then we design certain structure. For example, we can design a certain structure with a specific periodicity. Okay, sometimes we say pitch. The pitch of the structure will affect the overall light diffusion properties. Okay, so as you can see here, for blue light, since the diffraction is a wavelength dependent behavior, so you will be diffused to like a 31 degree, right? And for red light, will tends to diffuse to larger angle. Okay, this sometimes you can see for your cell phone. Okay, if you place your cell phone under a strong light, okay, sometimes you will see this rainbow pattern coming out, okay? So you can see the blue light usually at a small angle, but the red light usually at larger angle. And where does this come from? This come from that you have a pixel aligned within your display, right? So the pixel itself can also become a diffraction structure. Okay, so that's why sometimes you will see this kind of a rainbow pattern coming out from your display under strong light. Okay, and on the right side you can see there's if you come up with a specific structure with a different refractive index, you can see the side wall of this structure will contribute to the light diffusion property. Okay, due to the Snell's law, you can try to do some mathematical calculation, and then due to the angle of the side wall, you can like adjust the angle for the normal light passing through your film. Okay, so you can see in this case, there's something quite interesting is for blue light, it actually diffused to a larger angle. And for red light, it diffuse to a smaller angle. So this is more like a prism. If you place a white light and you place a prism, and then for the exit, for the light, passing through the prism, you can see the blue light tends to diffuse to larger angle, and the red light tends to diffuse to smaller angle. So based on this kind of underlying concept, we can try to change the refractive index or the structure of your film in order to adjust the overall performance for the light diffusion behavior. Okay, so based on this type of design, we can try to do further simulation if we have a 0-degree light, and then the light usually we will expect to have like a Gaussian distribution, okay, near the 0-degree. So for if you have a 0-degree light coming out, and then after passing through a specific structure, we will expect some part of the light will be diffracted to a different angle. Okay, so you can see if you have 10-degree light, okay, passing through the structure, you will be diffused to other angle, okay, based on this adjustment in the diffraction equation, right? Okay, but in this case, one thing that we need to consider is we try to diffuse the normal light to large angle, but we try to prevent large angle light from coming back to the normal position. Why? Because based on what we talked about earlier, okay, for VA, the main problem is in the large angle direction. If your structure make the large angle leakage light back to the normal direction, your VA will directly become IPS because it has leakage in almost all the direction. Okay, that's something we don't want. We want to be able to maintain the contrast in the normal direction, but improve the large angle contrast or viewing quality. Okay, so you can see there's one specific behavior for the refraction structure. Okay, one specific property we usually call it the selective light diffusion property. That means if we have a normal light, okay, it will be diffused to the large angle, right? But if we have a large angle light, okay, you can see based on your structure, more portion of the light will be diffused to even higher angle, even larger angle. Okay, only a small portion due to the total internal reflection will be reflected back to small angle. So this is something we like. Okay, we try to for example, if your design target is at a 60-degree, we try to make those leakage light to go to even higher angle. Okay, but we try to prevent it from reflecting back to smaller angle. Okay, so this is called the selective light diffusion properties. Okay, so based on the simulation, we can start from the reference. Reference means without any structure. Okay, so we can evaluate the contrast ratio using some measurement system. Okay, we can measure the contrast ratio at 0 degree and 60 degree. Okay, you can see from at 0 degree the contrast ratio is over 3000, but at large angle it dropped to like below 200. Okay, so we come up with different structures, including the refraction structure with different combination of refractive index, and also the diffraction structure. Okay, but as we said that the refraction structure tends to have selective diffusion properties. Okay, so that's what we expect, that the contrast ratio at 0 degree for this structure doesn't drop too much. Okay, usually we can like accept a drop from like 3000 to 2800, but like below 2000 it means like the normal direction the contrast ratio drop too much. Okay, and then as you can see, we try to improve the contrast ratio at a large angle. For example, for this structure, we can improve from 160 to over 300. Okay, and under the large angle direction, actually your light will be your eyes will be quite sensitive to the improvement in the contrast ratio. For example, for 3000, if you drop to like 2800, your eyes are less sensitive to that. Okay, but if you improve from 100 to 300, your eyes will feel relatively significant performance improvement at that level. Okay, so that's what our goal is, try to like build a model, right, and then place a film on top of it, and then we try to observe side by side, one display without the film, another display with the film, and we try to observe the large angle quality to see the difference. Okay, so this is our designing concept. We try to increase the large angle contrast ratio without sacrificing too much normal angle contrast ratio. Mathematical calculation, but usually since my previous company are like the sale provider okay, so they require some design target. For example, they require the transmittance to drop less than 10%. You don't want the transmittance to drop too much. Otherwise, they can use the multi-domain design instead of your film, right? And then they don't want the contrast ratio to drop too much. So we are required. This one will diffuse the light to large angle, right? This part will actually introduce the transmittance drop. We can do some mathematical calculation in order to meet the target. What's the ratio we require? Okay, so we can come up with some calculation. For example, the 2H cotangent theta over the pitch. The pitch is the periodicity of your structure. Okay, should be less than 0.1 in order to meet the requirement that the transmittance drop less than 10%. Okay, so we can come up with different design. Okay, and each design corresponds to angle the range for our design. Okay, but actually it's almost impossible to design a 90-degree angle. Okay, because in order to come up with this structure, you need to come up with a mold. Okay, but for 90-degree angle, it will be very, very difficult to design that kind of mold because this is a very small structure. This is in the micrometer range. Okay, so the knife you use to create a mold will be broken. Okay, if the angle is too high, too close to 90%. So usually we will expect like 84% or 85% to be the maximum. Okay, so that's one thing you also need to consider in the R&D team of the industry. Okay, you not only need to consider the mathematical or the underlying physical properties, you also need to consider whether we are able to come up with this kind of product. Okay, so after applying the film, the proposed design, you can see here, we sacrifice a little portion of the normal angle contrast ratio, but we try to improve the large angle contrast ratio. Okay, and we try to simply also adjust the brightness. Okay, this is the luminance. Okay, luminance at different angle direction, you can see will look like this. Okay, but sometimes if you do some extreme design, okay, the luminance at high angle will be even larger than some luminance at a smaller angle, this will cause a problem. It will be like a reflective sticker you see when you are kids, right? Sometimes you see that at certain angle you see very bright, okay, but you don't want your display to look like that. So our design goal is to make this change, the smoother the better, okay? So that's one thing we need to consider. Okay, so overall you can see that this is actually the 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 design project, okay, by my team when I was in AU Optronics. Okay, this is the real product measurement. Okay, so you can see the contrast ratio compared with the competitor's design, it can be improved from like 100 to over 200. Okay, and the gamma average here is a method to evaluate the gamma value. As I said, for the normal direction, we try to tune in to gamma 2.2. So this one is the more close to gamma 2.2, the better. Okay, so you can see compare with those competitors. The normal one is the one without any film. Okay, so we can successfully improve the gamma average value at mid-grade level from 1.1 to like around 1.5, okay, and even better than two of the competitors. Okay, so the conclusion for this is that by proper design, we are able to achieve high transmittance diffusion films with excellent oblique picture quality. Okay, but there are actually some side effects. For example, if you come up with this kind of structure, there will be some image blurring problem, especially for the words or captions. Okay, so you can see this originated from some total internal reflection and neighboring structure. Okay, neighboring structure, so you can see some light coming out near the edge of your lines here. Okay, and then due to the refraction phenomenon, you can see that there's maybe some color dispersion problem. The color dispersion means that you have three different light, right? And three different light, blue, green, and red. They tend to diffract into different angle. Okay, so at a specific angle, you will see some like a rainbow mura, okay, coming out from your display. Okay, so these can be like suppressed by designing, for example, the multiple angle or concave structure with not only one specific angle. You can like try to use some rounded structure at the sidewall, okay, to solve this kind of issue. Okay, so this is the first part for my talk, and the second part is related to the color performance structure using the perovskite quantum dot. Okay, so the quantum dot based on the physics is due to the quantum confinement effect. Some of the material, if you try to reduce the size, it tends to have light emission under short wavelength light excitation. Okay, and one this is the physics of the quantum well. Okay, you can find out that due to the energy quantization, the specific state. Okay, so the energy becomes not discontinuous. Okay, so the difference in the energy at different state will give rise to the light emission properties. Okay, but one thing special compared with the typical phosphor. Okay, we know that phosphor also have some PL behavior, right? Photoluminance behavior, right? But compared with the typical phosphor, quantum dot has one unique property, is that some of the quantum dot has very narrow emission width. Okay, the narrow emission width can provide what? If you see the color gamut diagram here, the outside edge is the single wavelength. Okay, if you come out with a laser, different wavelengths of laser with a very, very narrow emission width can give you what? Give you the outside corner emission color gamut. Okay, and as we know, the TV has three original color. Okay, red, green, and blue, right? So if your light is composed of a very pure color emission, okay, you can form a triangle in your color gamut diagram. The larger the triangle, that means roughly the larger color can be displayed in your TV. Okay, the larger number of color you can display for your TV. So this will largely, the larger the triangle will largely improve your color performance of the TV. So you can see by using quantum dot compared with OLED usually still use some like a functional group to do the light emission behavior. So the emission width is a little bit wider compared with quantum dot. And then OLED has some other problems. For example, the degradation problem over the time, right? And QLED still use the liquid crystal display. They simply change the backlight unit from white backlight LED to blue light LED and add a quantum dot film. Okay, so some portion of the light is converted by the quantum dot to the green emitting and red emitting light. Okay, so you can see if you place them side by side, the quantum dot LED TV can provide a better color performance compared with OLED TV. Okay, and this is a manufacturing process for the quantum dot enhancement film placed at the backlight unit. So originally you have blue LED, and after entering the quantum dot layer, some portion of light is converted to green and
Professor Sai,
yes.
it's 5 minutes left.
Okay, no problem. I will finish in 5 minutes. Okay, so as you can see, we are still in the first stage, okay? And then the later on, people will try to incorporate with glass and then also try to come up with QD pixels and then the QD-EL. But this is actually very challenging because apart from the color conversion, you also need to consider the electrical behavior for your material, okay? And currently, in our lab, we try to use the perovskite material. Okay, we simply use the lab procedure. Okay, first we try to prepare the precursor, and then we use some capping ligands in the solvent, and then after that we mix them uniformly and then place in the bed solvent. Okay, bed solvent is for precipitation, and under precipitation, your capping ligand will attach to the edge to prevent your crystal from growing large. Okay, and these are some of the instability issues in the perovskite quantum dot. Okay, so you can try to do some compositional engineering, surface engineering, and encapsulation method in order to improve the stability issues. Okay, and then under light excitation, if you have an perovskite quantum dot close with each other, they tend to grow bigger. Okay, so after the aggregation into bulk, it will not have light emission, so your quantum EO will be reduced. Okay, so what we do in our lab is try to incorporate with cellulose nanocrystals, come up with by tuning the quantum dot size. Okay, how to tune the quantum dot size? We can tune the concentration of cellulose nanocrystal and perovskite precursors in order to tune the quantum dot size or tune the halide composition. We can come up with a blue, green, and red emission perovskite quantum dot paper. Okay, because this is a paper-like film, so we call it the paper. Okay, paper. Okay, and we did some TEM characterization, and then we also try to adopt the quasi 2D. As you can see, by mixing with CNC, sometimes we come up with the large crystals. Okay, for large crystals, the quantum EO will be dropped because it becomes large, right? And so what we do is for the precursor, we try to adopt confinement effect to improve the overall quantum EO. So you can see the paper light emitting light conversion film. The quantum EO of the paper light emitting paper can be improved from like 20% to almost 70% for the halide perovskite paper. Okay, for the green emitting halide perovskite paper. So if we come up, and this is the excitation independent emission property. It means that it doesn't really matter your excitation wavelength is, the emission wavelength is consistent. And then this is the optimization procedure. Okay, that's for specific ratio we can achieve the highest quantum yield. So if we come up with red emitting and green emitting, okay, we place on top of a blue LED chip, and then we can place like one paper, one green paper, two red paper to tune the color performance of our white LED. Okay, so by placing the papers on top of blue LED chip, we can come up with the white light LED at a different color temperature. Okay, and these, I think I will skip these because due to the light imitation, okay, this when we increase the concentration instead of the light conversion film, we can come up with some photo detectors. Okay, but I will skip this due to time issue. Okay, so this is a brief summary for today's talk. Okay, for the first talk, we talked about the functional films to increase the viewing angle properties of the liquid crystal display. And then for the second part, we try to incorporate the perovskite quantum dot with the CNC serial snail crystals mixed under a specific type of solvent in order to come up with different color emitting papers. Okay, so these two are the functional film currently we try to investigate in our lab, and then hopefully later on we can come out with a more stable or the more higher quantum yield light conversion papers. Okay, so I think that's it for now. Okay, so thank you for your time, and then I will be happy to take any question. Thank you.
New topic to our audience. You have talked about 2D in films for the next generation the technology, in which you have given introduction to TFT, LCD, OLED, micro LED, and vertically aligned LCD, and advantages of vertically aligned LCD over IPS. And so I will collect two, three questions from the audience. So this session is open for discussion. If you have any question, you can ask. So I think there is no any question from the audience.
Okay.
This I am layman in this topic, but I have curiosity to ask one thing: whether this mono domain or multi-domain VA aligned LCD, vertical aligned LCD are which one is useful, or which one is good for the display technology, whether this is mono domain or multi-domain?
Okay. For this part, let me go back. Okay, so for mono domain, you always have the viewing angle problem because at different angle you see the different contrast. Okay, due to the light leakage from the liquid crystal, because for long axis and short axis, it interact with your light differently. Okay, so you will see difference. Okay, by adopting multi-domain, okay, you can improve the viewing angle problem. Okay, so you usually in the industry, okay, if they want to come up with a vertically aligned LCD, they always try to use at least two domain. Okay, but if you want to go further for two domain, maybe there's still a difference. Okay, this is just a schematic illustration. Okay, so you can see this seems very ideal, but in reality it's not. There's still some difference. Okay, because sometimes you cannot tune these two parts very accurately. So you will see like for this part maybe it's whiter than what's illustrated, and this part maybe is not as dark. Okay, so you will still see some difference. Okay, and in order to further improve that, you need to move to 4-domain or 8-domain. 4-domain or 8-domain, I think 4-domain is also used, but 8-domain is rarely used. Okay, because for 8-domain, you need to sacrifice the transmittance, because for more domain, you need to use additional circuit design. And additional circuit design means that you need to have some borders. The borders will will absorb your backlight, okay? Or you need to have some metals, okay? The metals will reflect your backlight, okay? So you will sacrifice the transmitters, okay? So unless you have very high model, very large model, okay? If you have very large model, maybe 2 domain is not enough. If you have like a 75-inch, you can go to 8 domain, okay? But for small, like a 55-inch, okay, people use like only 2 domain or 4 domain for the design.
Okay, thank
Okay, yeah,
you. Okay, thank you. Thank you, Professor Sai.
you're welcome.
So I thank you on the behalf of the organizing committee of this international conference, and I also thank on the behalf of the audience present over here. I thank the organizing committee giving me this honor to be chairman of this session. Thank you. Thank you.
Thank you. See you. See you.
Thank you, sir. Third session. I request Honorable Professor Waghule sir and Honorable Professor M.D. Shirsat sir kindly be seated on the dais, please. I welcome one and all in the second in the second technical session of the conference. In these sessions, we have Dr. Waghule sir, coordinator IQAC, SGBU Amravati University as a chairman, and Honorable Professor M.D. Shirsat sir, Dean Faculty of Science and Technology, Dr. Babasaheb Ambedkar Marathwada University, Chhatrapati Sambhajinagar, as a resource person. Our chairperson for the session is Professor Dr. S.A. Waghule sir, received a doctorate in physics from Sant Gadge Baba Amravati University, Amravati in 2008. He is a professor and head Department of Physics and Director Internal Quality Assurance Cell IQAC, Sant Gadge Baba Amravati University, Amravati. He has been actively engaged in research since 2002 and he is a nodal officer for NEP 2020 in the university. He is a member of many national and international professional bodies and he has an administrative experience as a coordinator of the fabrication laboratory during 2012 and 16, coordinator of patent sale during 2018 to 20, and coordinator of Rajiv Gandhi Science and Technology Scheme of the same university during 2018 to 21. Dr. Sandeep Waghule sir has authored more than 172 journal publications with 2,290 plus citation and H index of 23, followed with I-10 of 51. Under his supervision, 6 students have been awarded PhD and 7 students are pursuing their PhD under his guidance. Also, he has guided 6 MPhil students. 1 patent is granted to his invention and 2 patents are filed. He has completed individual and group research projects. His work has been reported by Journal of Electronic Material, Sensors and Actuators, B, Material and Design, Optical Material, Ceramic International, Material Sciences in Semiconductor Processing, Material Letters. He has received prestigious awards as follows: Fellow of Maharashtra Academy of Sciences, Outstanding Academic Excellence Award in 2021, Best Researcher Award of Sci-Fax Company in 2020, and Education Export TV, Utkrishta Seva Gaurav Puraskar of SGBAU Amravati University in 2017, Distinguished Researcher Award in 2017, and also he received number of awards like including FISCA Award in 2012, Elsewhere Award, Reviewer Status Award in 2014, Best Research Paper Presentation Award in 2011 and 2015. His research interest covers nanocomposites, conducting polymers, sensor, sensors, conducting glasses, thin films, quantum dots, carbon-based materials, graphene, nanofluids, photovoltaic. He have delivered more than 79 expert talk as a resource person. In the recent few years, Professor Dr. Wagure's group has been developed practical CO2 gas and LPG sensing material, highly conducting glasses, efficient photovoltaic material. The work has been published in high impact journals and been cited by number of researchers. I request Professor Dr. Devde sir to welcome and felicitate Honorable Dr. S.A. Wagure sir. The resource person for this session, Honorable Professor M.D. Shirsat sir, is a very well-known personality in the field of physics. I request Devde sir to welcome him. Devde sir.
So thank you, madam. Yes, now this session, now the Sirsat sir for this session. So I little bit because it is he has a huge biodata, but actually he's a man behind the technology. So that my duty, Dr. Sir, sir has a senior professor and director of Rusa Center and head of the Department of Electronics and dean of the faculties. And most important thing is that Dr. Babasaheb Ambedkar Marathwada University achieved the A++ grade in the NAC accreditation. And in that case, Dr. Shirsat sir plays a pivotal role actually as a dean. Sir, congratulations.
Thank you very much.
On behalf of
Yes, thank you.
So, sir publishes the huge number of the papers and patents are there, and all the papers are in a proper cited journals. And most thing is that sir establishes the Center for the Advanced Sensor Technology. This type of the eminent personality here, I request Sirsat sir to start this.
Thank you very much, sir. In fact, as per schedule, the lunch is scheduled at 1 o'clock. It is 12:45. I have very limited time now. And then I was just following you during first earlier two sessions. Very happy to see that most of you were listening the session. That is very okay. Anyway, in fact, truly speaking, 30-40 minutes are not going to be enough to introduce anybody to any technological relevant topic. So I'm not going to be here to teach you anything, but I will be giving you a brief introduction of what kind of research we are doing in RUSA Center for Advanced Sensor Technology. Dear friend, I know in most of the affiliated colleges, which I have already mentioned during inaugural function, that we working in affiliated colleges and the state universities, most of the universities are struggling for the state-of-the-art infrastructure in India. And therefore, this is one of the reasons why the teachers are not able to publish the data in good journal. Right? And therefore, what we did is, like, once I returned back from US in 2009, I wrote many projects to many funding agencies, and we got substantial funding. And we have created state-of-the-art facilities in the area of material science, synthesis of materials for various technological applications, characterization of those materials, and device fabrication. And since this center, because this is going to be outline of my talk today, to begin with, I will be introducing RUSA Center. The purpose of introducing RUSA Center is to tell you what kind of facilities we have created, so that you can come there and you can make use of those facilities, as most of us don't have access. Because I still remember when I was doing PhD, we used to go to IITs even for reference work. Forget about the access of the equipment. So we hardly used to see XRD because I have never seen XRD during my PhD. I have seen only XRD graph, but I have never seen XRD during PhD. So that was the pathetic part of the story that we most of us are facing. And therefore, what we are doing is whatever infrastructure we have created, we made it open for everybody. Like whenever somebody is coming to our center for making characterization of their samples, we are it's not mandatory, but like if you are interested, you can sit next to a research scholar and see how the equipment is being operated, how the sample is being treated, and that first on like hands-on experience you can have if you are visiting oftenly to the center. And therefore, I will be introducing my center to begin with, and then some fundamental sensor fundamental, because I could see there are master students sitting in the audience. So I will not be giving you only R&D aspect, but I will be giving you some fundamental aspect as well, and then what kind of research we are doing in sensors. In fact, if you look at now this is my center. We got, as I mentioned earlier, it was established in 2016. Problem again, and then this is the state of that facility center. It's kind of common facility center in the university, but it is being housed in separate building, which we call it the Rusa Center, which you must have seen in the beginning. This is the entrance view of my research center. Let me mention one more thing, that whatever facilities which I have experienced in the United States of America, in the University of California during my postdoc and visiting scientist tenure, all those facilities I have created in back to my university, all those facilities. And my collaborators, most of my collaborators, they have visited my laboratories, and they are very happy to see that all those facilities we have created under single roof. As far as the vision is concerned, mainly we are focusing on material synthesis, and our prime aim has been sensor technologies. But like semiconductor devices can also be done. I have a couple of collaborators from my own universities. They are working on semiconductor devices, but I am working on sensors, chemical sensors in particular. I'm not going to read all the mission statement, but let me tell you what are the theme sectors which we are working on. As I mentioned earlier, material synthesis, characterization of those materials, and application of those materials for sensors, particularly detection of environmental pollutants and detection of water pollutants. So those two areas has been the area of concern in our lab. Now, it's not only R&D activity, but we are focusing on mentoring student as well, capacity building. So the fundamental research is being carried out by master student, because in my university we have created the culture of research right from first year of MSc. So usually when student register, attend the classes, in first semester we are teaching them research methodology, not conventional research methodology, particularly how the literature reviews should be done, how the topic can be formulated, and how hypothesis can be formulated. All those aspects like hypothesis, objectives, methodology, experimental plan, literature review. So this everything is being taught in the first semester, and right from second semester onwards, students work on the project. And by the time they will be graduating, by that time most of them are having one or two Scopus index papers, and most of them have been placed in overseas universities for PhD. As I mentioned earlier, like fundamental research my master students are doing, and as far as applied research are concerned, because unless you do applied research, you will not be able to publish your data in good journal of international repute. So that application is being taken care by the PhD student. Unfortunately, since we don't have postdoc schemes as of now in India, very popular, we don't have any postdoc, but in between, like few postdoc, they joined my laboratory in between UGC Kothari and other postdoc schemes, and they did very substantial work when they were associated with the center. Regarding capacity building, we are inviting undergraduate students, and I still remember 1 year or 2 years back, the student from this college also visited my center, and they were there for a couple of hours. I delivered a talk, we showed them facilities, what kind of facilities we have. But apart from that, regularly we are organizing ideation camps for undergraduate students. Ideation means like we are inviting them, telling them what facilities we have, what kind of research student can do, and how to utilize those facilities. That kind of familiarization workshop we are conducting regularly in the center for bachelor student, master student, and research scholars in the beginning phase of their life, their career. Regarding research impedance, as I mentioned earlier, material synthesis has been the first prime area, and this is the list of facilities we have. Material characterization, this is the list of facilities we have. We'll show you the picture. And device fabrication, we have these facilities. So this is the list of facilities which we have in the center. Now, regarding processing of the material, मित्र तुम्हाला माहित असेल की कुठल्याही विद्यापीठामध्ये तुम्ही जा किंवा कॉलेजेसमध्ये जा, डिपार्टमेंट ऑफ केमिस्ट्री तुम्हाला सांगण्याची गरज पडत नाही. You just smell it and they follow the smell, you will reach your destination, right? Unfortunately, आपल्याकडे काय होतं माहिती आहे का, मास्टर्स आणि इव्हन पीएचडीच्या विद्यार्थ्यांना सुद्धा लॅबमध्ये काम करत असताना MSDS डेटा शीट बघायची असते हे बरेचदा माहीत नसतं बऱ्याच विद्यार्थ्यांना, पर्टिक्युलरली मास्टर्स. बरेचसे गॅसेस एवढे कार्सिनोजेनिक असतात की वी नेवर नो व्हॉट इज गोइंग टू हॅपन लेटर ऑन. कारण आपण लॅबमध्ये गेल्यानंतर जेवढे तिथे फ्युम्स असतात, इव्हन आपण कुठे हजार्डस केमिकल्स असतात ते आपण फ्युमूडमध्ये ठेवत नाही, कारण बऱ्याच लॅबमध्ये फ्युमूड नसते, एक्झॉस्ट त्याला नसतो. आम्ही तसंच आपण ओपन एन्व्हायरमेंटमध्ये बॉटल ओपन करतो आणि ते फ्युम्स आपण इनहेल करतो आणि पुढे आपलं काय होतं आपल्याला माहीत सुद्धा कळत सुद्धा नाही. आणि म्हणून आम्ही, तुम्ही जर बघितलं असेल अतिशय उत्कृष्ट प्रोसेस लॅब आहे, त्यामध्ये तुम्ही जर एंट्री जर केली, मोठी लॅब आहे, जवळपास 30 बाय 40 ची लॅब आहे. ॲट अ टाइम 30 to 40 स्टुडंट कॅन वर्क सायमल्टेनियसली अलॉंग विथ मास्टर स्टुडंट्स अँड पीएचडी स्टुडंट. आणि तुम्हाला तिथे कुठेही स्मेल, कुठल्याच केमिकलचा स्मेल जाणवणार नाही. बट इन्स्पाइट ऑफ दॅट आम्ही विद्यार्थ्यांना एक प्रोटोकॉल फॉलो करतोय, कारण विद्यार्थी केमिकल लॅबमध्ये जात असताना, हे मी तुम्हाला काय सांगतो, हे लेक्चर पूर्ण अर्ध्या तासात होणार नाही. इथे मी सरांकडे बघत आहे, 1 वाजून 2 वाजता इंटरनॅशनल माझे कोलॅबरेटर आहेत त्यांचं लेक्चर आहे, आणि फॉरेनर्सना डिलेड सेशन फारसं आवडत नाही. त्यामुळे मी 1 वाजून 10 मिनिटांनी जिथे संपेल तिथं आपण थांबूया. घाईघाईत अर्धवट स्लाईड संपवल्यापेक्षा जेवढ्या संपवायचे ते व्यवस्थित संपूया आपण, आणि 1 वाजून 10 मिनिटांनी आपण थांबूया, छानपैकी आरामात जेवण करून 2 वाजता आपण रेडी राहूया. तर मला हे सांगायचं की आपण जेव्हा लॅबमध्ये जातो, बरेचदा असं होतं की मास्क वापरत नाहीत विद्यार्थी, हँड ग्लोव्ज वापरत नाहीत, शील्ड वापरत नाहीत. आम्ही आमच्या लॅबमध्ये कुठलाही मास्टर्स किंवा पीएचडीचा विद्यार्थी विदाऊट हे प्रोटेक्शन्स आम्ही लॅबमध्ये एंट्री करू देत नाही. तुम्ही जर ओव्हरसीज युनिव्हर्सिटीजमध्ये गेला मित्र हो, तर पहिल्यांदा जोपर्यंत तुम्हाला या लॅबमध्ये काम करण्याचं ट्रेनिंग मिळत नाही तोपर्यंत लॅबमध्ये एंट्री नसते. एक्झॅक्टली सेम सिस्टीम, कारण मी तुम्हाला सांगितलं की मी बऱ्याच कोर्सेस युनिव्हर्सिटीजमध्ये सबस्टॅन्शियल ड्युरेशनला काम केलेलं आहे, आणि सर्व बेस्ट प्रॅक्टिसेस मी आमच्या विद्यापीठामध्ये आम्ही फॉलो करतोय. तर विद्यार्थी जेव्हा येतो तेव्हा त्याला कंप्लीट ट्रेनिंग झाल्याशिवाय तो मध्ये येत नाही. कुठल्या केमिकलचे काय हॅझार्ड्स, काय थ्रेट्स आहेत, काय डेंजर्स आहेत, काय चॅलेंजेस आहेत, त्याला माहीत असणं गरजेचं आहे. जसं उदाहरणार्थ आमच्याकडे सीबीडी मशीन आहे. सीबीडी मशीनमध्ये कार्बन नॅनोट्यूब ग्रो आम्ही करतोय. In order to grow carbon nanotubes by using CVD, you need hydrogen as a catalyst gas. हायड्रोजन तुम्हाला माहित आहे की इव्हन रूम टेम्परेचरला सुद्धा ब्लास्ट होऊ शकतो. आम्ही जवळपास 1200 डिग्री सेल्सिअसला जर हायड्रोजन वापरत असू आणि विद्यार्थ्यांचं मायनर जर चूक झाली तर एकटा विद्यार्थी जाणार नाही, पूर्ण बिल्डिंग उडून जाईल. अशा वेळेस विद्यार्थ्यांना कंप्लीट ट्रेनिंग जोपर्यंत मिळत नाही तोपर्यंत आम्ही विद्यार्थ्यांना मध्ये कुठेही एंट्री देत नाही. तर हे त्या लॅबचं वैशिष्ट्य आहे. हे सांगण्याचं कारणच आहे विद्यार्थी मित्रांनो, विशेषतः आणि जे प्राध्यापक जे अर्ली करिअरमध्ये रिसर्चमध्ये असतील, तुम्ही सुद्धा तुमच्या विद्यार्थ्यांना या सर्व गोष्टीचा अवेअरनेस करून देणं अतिशय गरजेचं आहे. पुढे जाऊया. ही लॅब आहे, लॅब प्रोसेस लॅबोरेटरी आहे, विद्यार्थ्यांना बसायला क्युबिकल्स आहेत. देन दिस इज फॅब्रिकेशन लॅबोरेटरी. फॅब्रिकेशन लॅबोरेटरीमध्ये इफ यू सी, दिस इज सीबीडी मशीन विच वी हॅव इंडिजियसली डेव्हलप्ड. This machine was developed by masters and PhD students together. If you look at CVD machine in international market, it will cost around 30 to 50 lakhs. It depends on what kind of facilities you have with that CVD. Under CSIR project, long back in 2006, 7, 8, I guess, we designed this equipment for the worth of rupees 8 lakhs only. And since then, we have been using this. And one of the beauty of this machine has been like we can make modification, alteration at your choice, कारण ही आपण होममेड मशीन असल्यामुळे. देन अनदर इंडिजियसली डेव्हलप इक्विपमेंट इज गॅस सेन्सिंग सेटअप, डायनामिक गॅस सेन्सिंग सेटअप जो आहे इथे सध्या तो या पिक्चरमध्ये नाही आहे. कारण गॅस सेन्सिंग मध्ये स्टॅटिक मेजरमेंट खूप लोक करतायत. स्टॅटिक मेजरमेंट म्हणजे काय, असा एक डोम असतो, त्या डोम मध्ये आपण इंजेक्शननी गॅस इनलेट करायचा आणि आपण कॉन्सन्ट्रेशन हे फार व्हर्च्युअल आहे, पण ऍक्च्युअल कॉन्सन्ट्रेशन तिथं काढू शकत नाही आणि नंतर रिस्पॉन्स आल्यानंतर डोम काढायचा. आता जेव्हा तुम्ही मटेरियलला एक्सपोज करता तेव्हा जे एन्व्हायरमेंट आहे तेच एन्व्हायरमेंट जेव्हा तुम्ही डोम काढता, रिकव्हरीच्या वेळेस सुद्धा आवश्यक असतं. स्टॅटिक मेजरमेंटमध्ये ते शक्य होत नाही आणि म्हणून अशा प्रकारचे मटेरियल जर तुम्ही सेन्सरसाठी लॅबमध्ये जर टेस्ट केलेत तर रिअल एन्व्हायरमेंटमध्ये ते मटेरियल काम करत नाहीत. therefore you need dynamic setup. So we have created dynamic setup again. Ketli 4200 is a semiconductor parameter analyzer. तो आम्ही रुसाच्या फंडिंग मध्ये विकत घेतला and rest of the thing we have integrated that. All 12 I'm going to show you later on 16 channel we can simultaneously 16 devices can be monitored and those performance of those 16 devices can be studied. And we have another like BET surface area analyzer, wire bonder machine, CVD as I mentioned earlier, probe station, because if you are working on the micro devices, micron level devices, you need probe station also. You can see this facilities. And this is the facility which I was talking about, Ketli 4200 semiconductor parameter analyzer. यामध्ये तुम्ही FET फीड इफेक्ट ट्रान्झिस्टर बनवू शकता, म्हणजे टेस्ट करू शकता, बनवू शकत नाही टेस्ट करू शकतात. आमच्याकडे क्लीन रूम फॅसिलिटी आहे जिथं आम्ही FET बनवतो. Then this is the dynamic gas sensing setup which indigenously we have designed and fabricated in our laboratory. This is another view, and this is hyperspectral imaging spectrophotometer. One group from computer science, they are working on this. So as I am not working on this particular equipment, I am not going to tell you anything about that. This is a clean room of 10,000 class. Clean room facility जे आहे ओव्हरऑल युनिव्हर्सिटी सिस्टीम मध्ये फार रेअरली असतात. IITs मध्ये तुम्ही क्लीन रूम बघताय, त्याचं कारण असं आहे 10,000 क्लासचा अर्थ असा होतो की पर क्युबिक मीटर ऑफ एअर देयर वोंट बी मोर दॅन 10,000 डस्ट पार्टिकल हुज साईज वुड बी अराउंड 15 मायक्रॉन. आता आपण जर इथे जर बघितलं तर जवळपास इथे करोडो पार्टिकल्स असतात. ते पार्टिकल 10,000 वर आणण्यासाठी जवळपास आम्हाला 30 ते 40 लाख रुपये लागले ही लॅब बनवण्यासाठी. जवळपास 40 बाय 40 ची ती लॅब आहे, 30 बाय किंवा 40 बाय 40 ची लॅब आहे. ती लॅब बनवण्यासाठी जवळपास 30 ते 40 लाख रुपये आम्हाला खर्च करावा लागले. याचं कारण असं आहे की मी नंतर तुम्हाला डिझाईन सांगेल. ती जे डिझाईन आहे त्यामध्ये 3 मायक्रॉनचा गॅप आहे, ज्यामध्ये आम्ही CNT ब्रीच करतो, CNT टाकतोय आणि देन वी आर डेव्हलपिंग द डिव्हायसेस. आता 3 मायक्रॉनचा गॅप जर असेल, त्या गॅपवर जर 50 मायक्रॉनचा डस्ट पार्टिकल जाऊन जर बसला तर तुम्हाला डिव्हाइस परफॉर्मन्स एक्सपेक्टेड मिळणारच नाही. Therefore you need clean environment. So for that purpose we have this clean room facility. You can see this is mask aligner. Mask aligner itself is costing around 1 crore. It's very costly equipment. We are using this because using this mask aligner you can work on MEMS devices also, electromechanical devices. And we are not working on MEMS devices, but we are using this for developing semiconductor devices and the facilities. I mean, the pattern which I'm going to show you what kind of patterns we are using for FETs. Then we have XRD. This is a Bruker XRD costing around 1.5 crore. All the facilities like single crystal XRD you can do, powder XRD, micro diffraction, liquid sample, all those sample can be done. And you are most welcome to utilize this facility. We have AFM also. This is Park AFM with scanning tunneling microscope. Atomic force microscope along with scanning tunneling microscope. इथे सुद्धा तुम्हाला ह्या सर्व फॅसिलिटी जी मी तुम्हाला दाखवतो तुम्ही येऊन त्या वापरू शकतात, अर्थात हँड्स ऑन एक्सपेरिमेंट घेतल्यानंतर. देन कन्व्हेन्शनली वी हॅव FTR UV विजिबल स्पेक्ट्रोफोटोमीटर ॲज वेल. देन यामध्ये काही फॅसिलिटीज मी दिसत यामध्ये काही स्लाइड नाही. रामन वी हॅव एक्सप्लोरा रामन ॲज वेल. And then BET surface area मला वाटतं मी सांगितलंय अगोदर. So this is the list of facilities we have. And this is our university website. I mean RUSA center. You will see here RUSA center. And the RUSA center click केल्यानंतर तुम्हाला details माहिती मिळेल. And this is the tariff charges. आता तुम्ही म्हणाल सर याची ऍडव्हर्टाइजमेंट करण्यासाठी तुम्ही सांगितलं का? नाही, absolutely नाही. Because we are earning enough revenue पर इयर. जवळपास 10 ते 15 लाख रुपये आम्ही इंडस्ट्रीकडून कमावतो. तर वी हॅव टाय अप विथ मेनी इंडस्ट्रीज इन औरंगाबाद, छत्रपती संभाजीनगर, आय एम सॉरी. And we are earning enough revenue from industry. As far as the academics is concerned, we have very subsidized rate for academics, and those who are doing collaboration with us, in fact, we are giving this facility free of charge. Those who are in collaboration. But if you don't have collaboration, then you can come down there and make use of the facilities by paying the charges. हे सर्व चार्जेस आहेत. त्याच्या प्रेझेंटेशनची कॉपी ऑलरेडी या सरांनी कॉपी केली असेल आणि ती कॉपी PDF बनवून सर्वांना द्यावं असे मी त्यांना विनंती करेन. दिस इज द रिसर्च टीम. आता टीम फार मोठी आहे. जवळपास 27 विद्यार्थ्यांनी PhD कंप्लीट केलेलं आहे. आज जे तुम्ही इन्फ्रास्ट्रक्चर बघितलं हे फक्त या 8 विद्यार्थ्यांचं कॉन्ट्रीब्युशन नाही आहे. त्या सर्व 27 विद्यार्थ्यांचं कॉन्ट्रीब्युशन आहे. प्रत्येक विद्यार्थी तिथे माझ्यापेक्षा जास्त नॉलेजेबल आहे. तुम्हाला खरं सांगतो. म्हणजे मला जर समजा 10% असेल तर माझ्या विद्यार्थ्यांना 100% नॉलेज आहे या सर्व इक्विपमेंटचं. हँड्स ऑन विद्यार्थी रिगरस करतात. कुठल्याही इक्विपमेंटवर मी स्वतः काम करत नाही. सर्व इक्विपमेंटवर माझे रिसर्च स्कॉलर काम करतात. ट्रेनिंग सुद्धा रिसर्च स्कॉलर देतात. मी फक्त लेक्चर्स देतो आणि मी फक्त रिव्ह्यू त्यांचा घेतो. रिगार्डिंग कोलॅबरेशन, इंटरनॅशनल कोलॅबरेशनचा पर्पज हा आहे की बाहेर काय चाललंय आपण अभ्यास करायचा, त्या प्रॅक्टिसेस आपण इथे इम्प्लिमेंट करायच्या. सो दॅट इज द पर्पज ऑफ हॅव्हिंग इंटरनॅशनल कोलॅबरेशन. द कंट्री वेअर आय स्पेंड लाईक US, then the substantial time, Australia, Japan, South Korea, Taiwan. He is a professor तुम्ही बघितले, Professor Mengling Sai. He is one of my collaborators, and another collaborator is in Europe. He will be delivering talk in the afternoon session, Professor Tibur Heinik. यांचं काम आम्ही कोलॅबरेशन कशासाठी करतो, त्यांच्याकडून शिकायचं, तिथं जायचंय. म्हणजे त्या एक्सचेंजमध्ये माझे विद्यार्थी सुद्धा गेलेले आहेत या सर्व देशांमध्ये. मी तर बरेचदा गेलोय. आम्ही जाऊन तिथं काही वेळ घालवतो, शिकतो काय त्यांच्याकडे आहे, अँड देन वी ट्राय टू इम्प्लिमेंट दोज बेस्ट प्रॅक्टिसेस बॅक टू माय युनिव्हर्सिटी. पर्पज ऑफ हॅव्हिंग नॅशनल कोलॅबरेशन इज मेंटरिंग. तुम्ही जर बघाल कॉलेजेसचे नाव मी फार मोजकेच कॉलेजेस टाकलेत. IUSC, कारण आमचे काही प्रोजेक्ट्स आहेत म्हणून IUSC तिथं आहे, इंटर युनिव्हर्सिटी ॲक्सेलरेटर सेंटर. अदरवाईज मोस्ट ऑफ द तुम्ही जर बघितलं तर कॉलेजेस आहेत. त्याचं कारण असं आहे की आपण जे शिकतोय ते कॉलेजेसच्या प्राध्यापकांना त्या फॅसिलिटीज मिळाल्या हव्यात. म्हणून आम्ही जवळपास 50 ते 60 कॉलेजेस आमच्यासोबत कनेक्टेड आहेत. ते आमच्यासोबत MOU त्यांचं झालेलं आहे, आमच्यासोबत येऊन काम करतात जॉईंट कोलॅबरेशनमध्ये. आणि मग त्यांचे विद्यार्थी जेव्हा आमच्याकडे येतात तेव्हा आम्ही त्यांना कुठलेही चार्ज करत नाही. दे आर युझिंग दिस फॅसिलिटीज फ्री ऑफ चार्ज, and the students will be spending time with the research whenever you will be having collaboration. So although I have only 1 year left now for my superannuation, but still there is a scope for at least 1 more year to come down and see the facilities, and you can tie up with our university. So this was the introduction. Regarding census, like आता तुम्हाला मी briefly, माझ्या समोर घड्याळ तो मला वाटतं मागे आहे, माझ्या समोर घड्याळ आहे, 10 मिनिट आहेत. 10 मिनिटामध्ये क्विक मी तुम्हाला काय काय करतो सांगतो. मित्र हे बघा, दिज आर नॅचरल. आपल्याला 5 नॅचरल सेन्सर्स आहेत. परंतु आर्टिफिशियल सेन्सर जेव्हा आपण म्हणतो, whenever you will be converting these physical parameters into electrical signal, that is what the sensor is all about. Basically, what are those physical signals? Like this is the examples, like heat, light, sound. These are some of the examples of physical signals which can be converted to electrical signal. Now, accordingly, as far as transducer is concerned, fundamental concept विद्यार्थ्यांना माहित असेल. Transducer is a device which will convert one form of energy into another. So transducer can be sensor or actuator. Whenever you will be converting physical parameter into electrical one, it is sensor, and other way around it is going to be actuator. We are not working on actuator, we are working on sensor only. This is example of chemical sensor which we are talking about. Like chemical sensor मध्ये होतं काय, you have a material, right? So whenever that material is exposed to any gaseous analyte, one of the properties of that material is going to be tailored, going to be modified, which need to be quantified in terms of electrical signal. And this as a whole nothing but a chemical sensor. आता हे जे पिक्चर जर तुम्ही बघितलं, या पिक्चर मध्ये सर्वात क्रिटिकल पार्ट जो आहे तो आहे सेन्सर मटेरियल्स. बिकॉज अलीकडे मित्र तुम्हाला सांगतो, इफ यू सी द रिसर्च पेपर every day, thousands of papers are coming in sensor area, thousands of paper. तुम्ही Google Scholar ला जा, सर्च करा chemical sensor, कुठे NO2 sensor or H2S sensor, you will see many papers. Does it mean that this is absolute? No. Does it mean that you cannot have the novelty in the word? No, it is still there. The reason for that is, this is the issue which we are, okay, let me finish this. So प्रॉपर्टीज कशा बदलतात, केमिस्ट्रीचे विद्यार्थी असेल त्यांना माहित आहे. इट इज बेसिकली प्रोटोनेशन अँड डिप्रोटोनेशन, एक्सचेंज, इलेक्ट्रॉन एक्सचेंज mechanism is happening, and then you need electronic circuit to tap those mechanism so that electrical signal can be modified and it can be strengthened. These are the ideal sensor requisite. Ideal sensor requisite काय असतो बेसिकली केमिकल्स. व्हेनेवर वी टॉक्ड अबाउट केमिकल सेन्सर, सर्वात महत्वाचं त्याचा रिस्पॉन्स टाइम. जसं समजा उदाहरणार्थ मला कोणी जर चिमटा घेतला इथे, चिमटा घेऊन 10 मिनिटांनी जर मी त्याला शिव्या देत असेल तर उपयोग काय त्याचा. तो चिमटा घेते, रक्त निघेपर्यंत चिमटा घेत राहील. इमिडिएटली जर तुम्ही रिस्पॉन्ड जर केला तरच त्याला काहीतरी अर्थ आहे. किंवा या लॅबमध्ये फॉर एक्झाम्पल S2S एक सिलेंडर आहे, फॉर एक्झाम्पल S2S, आणि ते लीक झालंय आणि 2-4 माणसं खाली पडलेपर्यंत आपल्याला कळालं नाही की S2S लीक झालंय, अशा सेन्सरचा काही उपयोग नाही. आणि म्हणून सेन्सर मटेरियल असं असणं आवश्यक आहे की ज्याचा रिस्पॉन्स टाइम हा फार क्विक असेल, सेव्हरल सेकंद, अँड सिमिलरली त्याचा रिकव्हरी सुद्धा सेव्हरल सेकंद मध्ये असणं गरजेचं आहे. तो आयडियल पॅरामीटर मध्ये ह्या 2 गोष्टी अतिशय महत्वाच्या आहेत. रिस्पॉन्स टाइम, रिकव्हरी टाइम, स्टॅबिलिटी त्या मटेरियलची कशी आहे, कारण ते सुद्धा फार महत्वाचं आहे. मटेरियल बनवलंय आपण, परंतु 2 दिवसात संपतंय. जसं उदाहरणार्थ आता अलीकडे तुम्हाला माहित आहे की मोबाईल्स, चायनीज मोबाईल्स आलेत बरेचसे, परंतु त्याच्या बॅटरी लाईफ कमी आहे. आणि म्हणून अलीकडे आयफोनची किंमत लाखो रुपये असून सुद्धा लोक आयफोनकडे का जातात? बिकॉज आयफोन इज वन ऑफ द फोन विच हॅज गॉट हायली स्टेबल बॅटरी, राईट. म्हणजे अलीकडे तुम्ही लाखो रुपये कशासाठी मोजताय? कारण स्टेबिलिटी चांगली आहे म्हणून. आणि मी जर तुम्हाला म्हटलंय चला 1000 रुपयात तुम्हाला मोबाईल देतोय, परंतु त्याचे बॅटरीचा लाईफ टाइम फक्त 1 तास आहे, nobody is going to turn up. On the other hand, if I am giving you 10,000 rupees mobile cell phone whose stability of that battery is like 24 hours, most of you will be going for that. याचा अर्थ आहे स्टॅबिलिटी इज गोइंग टू बी व्हेरी व्हेरी क्रिटिकल. हे सुद्धा अतिशय महत्वाचं आहे. त्या मटेरियलची स्टॅबिलिटी खूप जास्त असणं गरजेचं आहे. देन लोअर डिटेक्शन लिमिट, बिकॉज यू सी पेल परमिएबल एक्सपोजर लेवल, म्हणजे ओशा नावाची एक ऑर्गनायझेशन आहे जगामध्ये, US आहे. ओशा काय करते, हे जे हजार्डस गॅसेस जे आहे एन्व्हायरमेंट मध्ये जे गॅसेस जनरेट होतात, कुठले गॅसेस आहेत? S2S, NO2. आपल्या व्हेकल मधून कार्बन मोनॉक्साईड इतका भयानक गॅस येतोय, आपल्या सर्वांना माहित आहे. पण तरी सुद्धा आपण सिटीमध्ये चालत असताना मोटरसायकल लावत असतो, म्हणजे मोटर बाईकवर जर असू आपण, व्हेरी फ्यू ऑफ अस युझिंग मास्क, फारच कमी. किंवा आपण रुमाल सुद्धा बांधत नाही. रुमाल कधी बांधतो? जेव्हा ऊन पडते तेव्हा. आणि मग ते जे त्या व्हेकल मधून तुम्ही अलीकडे आपले जे व्हेकल्स आहेत त्याची सर्व्हिसिंग आपण रेग्युलर करत नाहीत, आणि तो काळा काळा धूर जो दिसतो आपल्याला, बरेचदा काळा काळा धूर हा कार्बन सूट असतो, परंतु खऱ्या अर्थाने कार्बन मोनॉक्साईड हा कलरलेस आहे. कार्बन मोनॉक्साईड तुम्हाला दिसणार नाही. तुम्ही जर बाहेर जर गेला अलीकडे एन्व्हायरमेंट, आजच मी लोकमत वाचत होतो, लोकमत मध्ये तुमच्यापैकी कोणी जर आजचा लोकमत जर चालला असेल तर जगामधल्या 20 शहरांमध्ये मोस्ट पोल्युटेड सिटी जे आहेत त्यापैकी 13 शहर हे भारतामध्ये आहेत. आता विचार करा, मला आठवते जेव्हा मी 2009ला जेव्हा अमेरिकेत होतो, अमेरिकेचा एक प्रोफेसर दिल्लीमध्ये येऊन पोल्युशनवर काम करत होते, आणि ते म्हटले की जेव्हा मी इंडियात जातो तेव्हा ते माझा डेटाच घेत नाही. ते म्हणतात की नो 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 नो, वी डोंट वॉन्ट टू ऍक्सेप्ट युअर डेटा. कारण मी जर माझा डेटा जर ऍक्सेप्ट केला तर भारत जे सांगतंय की आमची दिल्ली फार पोल्युशन फ्री आहे, तसं नाही आहे. दिल्ली इज वन ऑफ द मोस्ट पोल्युटेड कॅपिटल्स अमंग्स द ऑल कंट्री. म्हणजे जेवढे देश आहेत त्या देशामध्ये सर्वात जास्त पोल्युटेड राजधानी जर असेल कुठल्या शहराची, कुठल्या देशाची, तर दिल्ली आहे. पण तुम्ही मित्र, तुम्हाला सांगतो, तुम्ही आता जर तुमच्यापैकी प्राध्यापक निश्चित गेले असतील, प्राध्यापक 10 वर्षापूर्वी दिल्लीत गेले असतील, आता गेले असतील, यामध्ये जमीन आसमानाचा फरक जाणवतोय. तरी सुद्धा म्हणजे पूर्वी तर असायचं, आम्ही जेव्हा दिल्लीत जायचो तेव्हा पहाडगंज एरियामध्ये आम्ही राहायचो, बाहेर पडल्यानंतर त्या रिक्षामधून एवढा भयानक धूर यायचा, रेल्वे स्टेशन पासून गावात त्या हॉटेल पण जाईपर्यंत गोरा सुद्धा माणूस काळा व्हायचा. आमच्यासारखं जर मग काही प्रश्न येत नाही. तर अशी अवस्था त्या काळात होती. आजही दिल्ली हे जर मोस्ट पोल्युटेड सिटी जर असेल तर आज सर्व बहुतांशी व्हेकल CNG ने रिप्लेस झालेत, तरी सुद्धा ही अवस्था आहे. याचा अर्थ असा आहे की वी आर नॉट अवेअर की जे सोर्सेस आहेत या सर्व पोल्युटंटचे, ते सोर्सेस आपण स्टॉप करत नाहीये. त्यासाठी जे सेन्सर्स आहेत त्याचं लोअर डिटेक्शन लिमिट हे पेल जे आहे, परमिजेबल एक्सपोजर लेवल, ओशानी प्रत्येक गॅसेसच्या लेवल दिलेले आहेत. त्या लेवलच्या आसपास जर तुमचा लोअर डिटेक्शन लिमिट जर नसेल तर तो सेन्सर काहीही उपयोगाचा नाही. अँड देअरफॉर whenever you will be designing sensor, whenever you will be working on sensor, you need to know what are the ideal parameters. So this is the purpose of showing this slide. Once you know the ideal, आता हे सर्व जास्त कॉम्प्रिहेन्सिव्ह स्लाइड आहे ज्यामध्ये हायली सेन्सिटिव्ह अँड सेलेक्टिव्ह तुमचा सेन्सर असणं गरजेचं आहे. इट नीड टू बी व्हेरी प्रिसाइज अँड ॲक्युरेट. लो कन्झम्पशन सुद्धा कमी असलं पाहिजे, सो दॅट whenever you are talking about handheld sensing gadget, I mean to say, ड्युरेबिलिटी मटेरियलची चांगली असणं गरजेचं आहे. ते मटेरियल जे तुम्ही डिव्हाइस करणार किंवा डिझाईन करणार, इट शुड बी गुड फॉर मास फॅब्रिकेशन, लो डिटेक्शन लिमिट, लो रिकव्हरी आणि पोर्टेबिलिटी. ह्या सर्व गोष्टी अतिशय महत्त्वाच्या आहेत. आता ह्या सर्व जर फीचर्स आयडियल फीचर असतील, हे का गरजेचं आहे मित्र हो? बरेचदा असं होतं की आपण काय करतो, रिसर्च करत असताना आपलं टार्गेट काय हेच माहित नसतं आपल्याला. आपण सिनॉप्सिस लिहितो, बरेचदा कोणीतरी लिहिला म्हणून आपण लिहितो, किंवा गाईड सांगतो म्हणून लिहितो, किंवा कुठून तरी कॉपी आपण करतोय. करत 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 पुढे जातो. जेव्हा आपण पीएचडीच्या वायवाला जातो तेव्हा हायपोथेसिस सुद्धा माहित नसतं आपल्याला. हे वास्तव आहे मित्रांनो. मी तुम्हाला सांगतो, डीन म्हणून मी इंजिनिअरिंगच्या जवळपास 15 ते 20 वायवा अटेंड केल्या, आणि इंजिनिअरिंगच्या प्राध्यापकांना मी विचारले की बाबा तुझं हायपोथेसिस काय आहे, तर हायपोथेसिस त्यांना सांगता आलं नाही पीएचडी थेसिस सबमिशन व्हायवाच्या वेळेस. ही जर अवस्था जर प्राध्यापकाची असेल तर विद्यार्थ्यांची काय अवस्था असेल? आणि म्हणून मित्र हो, बरेचदा जोपर्यंत तुम्हाला टार्गेट माहित नाही तोपर्यंत रिसर्च करण्यात काहीच उपयोग नाही. सो यू नीड टू नो, लाईक इफ यू आर वर्किंग ऑन सेन्सर्स, what are the idealist sensor requirement, so that you will be thinking of choosing material. Once you know, आता जर तुम्ही idealist sensor requirement जर काढल्या तर तुमच्या लक्षात येईल की बल्क मटेरियल वर त्या प्रॉपर्टीज तुम्ही अचीव करू शकत नाही. and therefore this is one of the example of importance of one dimensional material. आता हे दोन एक्झाम्पल आहे. वन इज नॅनोवायर बेस्ड फीड इफेक्ट ट्रान्झिस्टर, अदर इज थिन फिल्म बेस्ड फीड इफेक्ट ट्रान्झिस्टर. आता उदाहरण काय मित्र बघा, एक साधं उदाहरण देतो तुम्हाला. हा हात आहे तुमचा, या हाताला कुत्र्याने चावा घेतला, ओके, आणि या हाताला मॉस्किटोने चावा घेतला. मला सांगा की इंटेन्सिटी कशाची जास्त असेल? कुत्र्याची. व्हॉट इज द रिझन? रिझन इज द साइज ऑफ द माउथ ऑफ द द कुत्र्याचं जे साईज आहे जबडा त्याचा, ते आणि हा हात हा कंपॅरेबल आहे. व्हेअर मॉस्किटो जो आहे तो सरफेसवर आहे. Exactly same thing is going to happen with nanostructured material. Now in case of nanostructured material, the molecular dimension of the VOCs or hazardous gas which is being sensed is going to be comparable with the dimension of the material which is being used for the sensing, and therefore the area of depletion or addition will cover almost entire cross section area of that material, and therefore minor change in the input parameter will lead to the substantial change in the output parameter. On other hand, इथे जर थिन फिल्म जो आहे तर हत्तीच्या पाठीवरून जी मुंगी चालेल सोंडीत न जाता, तशी परिस्थिती होईल. आणि म्हणून थिन फिल्म बेस्ड ट्रान्झिस्टर जे आहेत दे आर नो मोर गुड फॉर द हायली सेन्सिटिव्ह डिव्हायसेस. आता हे डिव्हायसेस कुठले सांगतो मी? इट इज नॉट ओनली फॉर पेपर पब्लिकेशन. इफ यू लुक ॲट द पेपर पब्लिकेशन तुम्ही थिन फिल्मवर सुद्धा करू शकता, बट यू कॅनॉट गो फॉर द डिव्हायसेस. डिव्हायसेससाठी जर तुम्हाला जायचं असेल तर नॅनोस्ट्रक्चर मटेरियल अतिशय आवश्यक आहे. त्याचं आता इतकं डिटेल मला तुम्हाला इथं सांगता येणार नाही, वेळ नाही इतका, कारण वेळ फारच कमी आहे. तर आपण जर बघितलं नॅनोस्ट्रक्चर मटेरियल जर बघितलं त्यावर तुमच्या लक्षात येईल की बिकॉज ऑफ नॅनोस्ट्रक्चर मटेरियल. आता फक्त एक एक्झाम्पल देतो, ही स्लाइड मी नंतर सांगेल तुम्हाला. दिस इज द सबस्टेट विच वी आर युझिंग. यू कॅन सी ऑन दिस सबस्टेट वी हॅव 16 डिव्हायसेस. दिस इज 1 centimeter square chip, 1 centimeter square chip. I was working on the same chip when I was in US during my postdoc and visiting scientist. And then when I returned back to India, याची डिझाईन आम्ही चेंज केली. 16च्या ऐवजी 8 इलेक्ट्रोडची डिझाईन आम्ही केली. आपण जर इथे बघितला, हा जो टीप आहे इथे आहे 3 मायक्रॉनचा गॅप. दॅट गॅप वी आर ब्रिजिंग विथ द कार्बन नॅनो ट्यूब, बिकॉज यू नो लाईक ॲज फार एज द कार्बन नॅनो ट्यूब इज कन्सर्न, द लेंथ ऑफ कार्बन नॅनो ट्यूब इज अराउंड 5 to 6 मायक्रॉन लेंथ, आणि डायमेन्शन जे आहे डायमीटर इट इज कपल ऑफ नॅनोमीटर. जर लेंथ जर हा 5 ते 6 मायक्रॉन जर लेंथ असेल तर मला जो गॅप क्रिएट करायचा तो 5 मायक्रॉन पेक्षा कमी गॅप असणं अतिशय आवश्यक आहे. अँड दॅट इज वाय व्हॉट वी डीड इज वी आर क्रिएटिंग गॅप at this tip of the electrode. The gap is around 3 micron which we are bridging with CNT. अशा पद्धतीने किती डिव्हाइसेस आहेत? 1 2 3 4 like this 16 devices on single 1 centimeter square chip. आता हे जे तुम्ही जर याचा क्रॉस सेक्शन व्ह्यू जर बघितला तुमच्या लक्षात येईल, दिस इज SI. ऑन द टॉप ऑफ दॅट वी हॅव SiO2 अँड देन क्रोमियम फॉर अडेसिव्हिटी. कारण गोल्ड जर आपण डायरेक्टली जर डिपॉझिट केलं तर तो अडेसिव्ह राहत नाही, म्हणून क्रोमियम हा 20 नॅनोमीटरचा क्रोमियम आम्ही ग्रो करतो. याच्यासाठी आम्ही थिन हाय व्हॅक्यूमची ई-बीम अँड थर्मल इव्हॅपोरेटर बँगलोरला जाऊन स्वतः आम्ही डिझाईन करून घेतला आमच्या लॅबमध्ये. माय रिसर्चर वेर देअर इन द कंपनी फॉर ऑलमोस्ट 6 months अँड वी गॉट द सिस्टीम डिझाईन and fabricated for our purpose, and we bought their system long back in somewhere in 2010-12. आणि मग हे हा डिव्हाइस तयार झाल्यानंतर तुम्ही जर बघितलं इथे 16 डिव्हाइसेस असतील. 16 डिव्हाइसेसचा बॅकबोन कार्बन नॅनोट्यूब असेल आणि मग कार्बन नॅनोट्यूबला आम्ही वेगवेगळ्या मटेरियलने मॉडिफाय करतो. बिकॉज in case of all 16 devices, backbone is going to be carbon nanotube. But in order to inculcate selectivity, I will be modifying CNTs with different nanostructure material. आता ते कसं मॉडिफाय करतो ते तुम्हाला मी एक्झाम्पल पुढे सांगेल. बापरे, 1:15 वाजला, थांबावं लागेल. ओके, थांबावं लागेल, काहीच पर्याय नाही. बरं, क्विकली काय करतो, 5 मिनिटात समराईज करतो. आता मी फक्त काय करतो, तुम्हाला हा डॉमिनंट हर्डल मी तुम्हाला सांगितलं होतं की सेलेक्टिव्हिटी आजही तुम्हाला सांगतो खूप रिसर्च पेपर पब्लिश होत आहेत. मोस्ट ऑफ द रिसर्चर इन्क्लुडिंग मी, मोस्ट ऑफ द रिसर्च पेपर आम्ही काय सेलेक्टिव्हिटी कशी क्लेम करतोय की ओके फाईन, वी हॅव डेव्हलप वन मटेरियल, वी एक्सपोज दॅट मटेरियल टू लेट से 10 डिफरंट गॅस अनालाइट. त्या 10 पैकी एक दाखवतो मला 80%, बाकीचे 10-12 दाखवतात. आम्ही काय सांगतो 80%, this 10-12% is negligible as compared to 80%. That is why material is selective. As of now, still we are struggling. We, a scientific fraternity across the globe, it's not only in India, across the globe, because I have collaboration outside the India as well, across the globe, struggling to get one material which will be selective only for one gas analyte. It is very, very challenging. Therefore, इथे काम करणं आजही चॅलेंजिंग आहे. आजही तुम्हाला नॉवेल्टी इन्कल्केट करता येऊ शकतं. आता हे काही मटेरियल्स आहेत आम्ही वापरतोय, त्यामध्ये खूप मटेरियल्स आहेत. कार्बन नॅनोट्यूब, ग्राफीन. फक्त डिव्हाइस कसा बनवतो तेवढंच सांगतो. तुम्हाला सांगतोय एक स्ट्रॅटेजी सांगतोय. फॉर एक्झाम्पल रिसर्चरसाठी अतिशय महत्वाची आहे. उदाहरणार्थ तुमच्यासमोर एक हे जे मटेरियल मी सांगितले, फॉर एक्झाम्पल एवढे मटेरियल जवळपास 8 मटेरियल्स आहेत. फॉर एक्झाम्पल यू हॅव a range of, let us say, 10 to 15 material in front of you. What you need to do, you need to screen out those material and select 1 or 2 material for your desired application. For that purpose, what kind of strategies need to be adopted? First of all, understand what that material is all about, fundamental aspect. What are the advantages aspect of that material for your application, and what are the shortcomings, what are the challenging aspect of that material for your application. Whether you will be, and see whether you will be able to address those challenges. If you are able to address the challenges, go ahead. No, get rid of that material. Search on another material. So अशा पद्धतीने पुढे जाणं गरजेचं आहे. या स्लाइड मध्ये मी तेच सांगण्याचा माझा प्रयत्न होता. कार्बन नॅनोट्यूब काय आहे, त्याच्या प्रॉपर्टीज काय आहेत, ॲडव्हान्टेजेस काय आहेत, डिसएडव्हान्टेजेस काय आहेत, आम्ही ते डिसएडव्हान्टेजेस या चॅलेंजेस आहे कसे ॲड्रेस करतो, अँड हाऊ वी आर युझिंग दॅट इन द सेन्सर ॲप्लिकेशन. सिमिलरली ऑर्गॅनिक 3 मटेरियल मी इथे घेतले होते. ऑर्गॅनिक कंडक्टिंग पॉलिमरचे ॲडव्हान्टेज, डिसएडव्हान्टेज काय आहेत, ते डिसएडव्हान्टेज कसे आपण ॲड्रेस करू शकतो. बिकॉज वन ऑफ द व्हेरी पिक्युलर प्रॉपर्टी ऑफ कार्बन नॅनोट्यूब इज बॅलिस्टिक कंडक्शन. लेट मी टेल यू. कारण जनरली व्हेन वी इन्क्रीज द लेंथ ऑफ एनी वायर, resistance going to change. But as far as carbon nanotube is concerned, irrespective of the length, resistance remains constant. This is what we call as ballistic conduction, one of the very peculiar electrical properties of carbon nanotube. Similarly, organic conducting polymer, they are not at all stable in environment if you are growing in bulk. But if you grow the CNTs in nanostructure form, they are excellent material. You can grow single nanowire. We have developed even single nanowire devices as well. Using template, we have grown nanowires and we come up with single nanowire devices as well. We are using CNTs, sensors in 2 different modalities, chemiresistive and chemfact. Chemfact म्हणजे फीड इफेक्ट ट्रान्झिस्टर. फीड इफेक्ट ट्रान्झिस्टर मध्ये तुम्हाला हे जे पॅरामीटर मी आयडियल पॅरामीटर सांगितले त्याची अतिशय छान पद्धती तुम्ही करू शकता. आता क्विकली फक्त मी एक शेवटी तुम्हाला 2-3 स्लाइड दाखवतो आणि थांबतो. हे मटेरियल ते आहेत हे बघा. सो हाऊ वी आर डेव्हलपिंग डिव्हाइसेस, chemiresistive and chemfact devices. So what we are doing, हा सबस्ट्रेट आहे. सो वी आर टेकिंग सीएनटी ला आपल्याला सस्पेन्शन तयार करायचं आहे. सस्पेन्शन तयार सीएनटी ला डिझॉल्व करायचं नाही आहे. वी नीड टू प्रिपेअर द सस्पेन्शन ऑफ सीएनटी. सो यू नीड टू select solvent in such a way that CNTs are not going to dissolve, फक्त सस्पेंड होतील. मग त्याला सेंट्रिफिकेशन, सोनिकेशन यासाठी डिबंडलिंग करायचं, सर्टिफिकेट यासाठी की त्याचं कार्बन सूट काढायचं आहे, अँड देन यू विल एंड अप विथ वंडरफुल फाईन सस्पेन्शन ऑफ CNTs. आणि मग ते CNTs तुम्ही या इथे ड्रॉप कराल. बाय युझिंग dielectrophoretic alignment you can bridge the gap. So like that you will be having CNT bridging the gap in case of all 16 devices. These are the equipments which we are following that for characterization, TAM, AFM. We have these facilities with us. with us, and then functionalization. Functionalization is like organic conducting polymer, charge control potential static deposition. Charge control potential static deposition chemistry चे जर प्राध्यापक इथं असतील त्यांना माहित आहे. Basically, potential static deposition will not allow you to deposit on CNT. लक्षात घ्या, मायक्रॉन लेवलचा डिव्हाइस आहे जिथे आम्ही CNT ने ब्रीच केलेला आहे आणि फक्त CNT ज्याची लेंथ 5 मायक्रॉन आहे, डायमीटर काही नॅनोमीटर आहे. हा माझ्या डोक्याच्या केसची थिकनेस आहे 50 मायक्रोमीटर, याची थिकनेस असते सेव्हरल नॅनोमीटर. त्या सेव्हरल नॅनोमीटरच्या CNT वर तुम्हाला कार्बन दुसरे मटेरियल कोड करायचे सेलेक्टिव्हली. सो ओनली चार्ज कंट्रोल पोटेन्शियल स्टडी डिपोजिशन कॅन बी द ओनली ऑप्शन फॉर दॅट. दिस इज लाईक पॉसिबल ओनली विथ इलेक्ट्रोकेमिकल वर्क स्टेशन विच वी हॅव विथ अस. आणि ते अशा पद्धतीने मग तो डिव्हाइस हे ते फोटोग्राफ्स आहेत आणि मग अशा पद्धतीने हे तुम्ही बघा, हा तो कोडेड CNT आहे, हा FESM इमेजेस आहेत. हे नंतर त्याचे वेगवेगळे कॅरेक्टरायझेशन तुम्हाला करावं लागेल. CNT ला कोड केल्यानंतर इलेक्ट्रोकेमिकल कॅरेक्टरायझेशन, मॉर्फॉलॉजिकल कॅरेक्टरायझेशन, स्पेक्ट्रोस्कोपिक कॅरेक्टरायझेशन नीड टू बी डन, अँड देन फायनली यू कॅन टेस्ट युअर. हे पॉर्फिरिनला तुम्हाला इलेक्ट्रोकेमिकलची गरज नाही. यू प्रिपेअर द सोल्युशन, इन्क्युबेट द डिव्हाइस, and then just with several seconds you will end up with a wonderful coverage, and then you can do chemistry and chem measurement. And I am going to show you, let me have a feeling of that I have completed my talk. You can see this is the wire bonded device, 16 devices. A closed chip आहे, हा तो wire bonded machine आहे ज्याने आम्ही wire bonding करतो. हा तो स्कीमॅटिक आहे, डायनेमिक गॅसेसिंग साठीचा स्कीमॅटिक आहे. हे त्याचे ऍक्च्युअल इमेजेस आहेत. टेडल बॅग ज्यामध्ये गॅस अनालाइट जे आहे, सिलेंडर आपण अफोर्ड करू शकत नाही म्हणून ड्रायर साठी सिलेंडर वापरतो आणि गॅस अनालाइट साठी आम्ही ते डायल्यूट करून ह्या टेडल बॅग्स वापरतो या छोट्या छोट्या. आणि हे ते सेटअप आहे, तुम्ही बघा हे कनेक्टेड आहे केतलीला. आणि अशा प्रकारचे हे मेजरमेंट आहेत. हे केम्फेट मेजरमेंट्स आहेत. FET मेजरमेंट, FET इट सेल्फ इज वन ऑफ द बिग इश्यू. कारण FET वरच आपल्याला 40-45 मिनिट आपण विद्यार्थ्यांना शिकवतो, त्यामुळे आता एवढ्या कमी वेळात ते सांगणं अशक्य आहे. तर हा तो शेवटचा फ्लो चार्ट आहे. तिथे काय होतं, हे ते डिव्हाइस, हा चिप आहे. त्या प्रत्येक चिपवर आम्ही CNT, प्रत्येक इलेक्ट्रोडवर वी आर डुईंग, वी आर ब्रीजिंग each pair of electrode with CNT in case of all 16. Then we are modifying with different material, testing for each and every material, and then simultaneously we are testing 16 devices together for one material, rigorous testing, reproducibility, repeatability, and then one after other for screening the different materials. So this is what we have done, and I'm happy that I could complete my talk. Thank you very much. And I'm extremely sorry because there was
no sir,
there was
very
no,
interesting,
there was no
very
any other
interesting
option.
sir, because there are the so new students are there, and a new researcher is also there. So that's why it is a very nice talk delivered by the Irsat sir. And actual data you have put up sir.
Yes.
Actual data, कारण most of the students are from the physics background, and yes, we have also done the research with the chemistry. So also some difficulties or do's and don'ts in our laboratories. तर सरांनी काही केमिस्ट्रीच्या बाबतीतले सांगितलेले आहे की प्रत्येकाने त्या प्रिकॉशन घ्याव्या, आणि सरांना जर काही क्वेश्चन्स असेल तर तुम्ही विचारला. क्वेश्चन्स म्हणजे असा अराईज करून नका विचारू, तुमच्या काही डिफिकल्टी जरी असल्या तरी विचारा.
एखाद दुसरा प्रश्न आपण घ्यावा.
Yes, विचारा.
येस. Yeah. You said it is premature statement? Okay. That is the okay. Finish your talk. Finish your question first. You don't have facilities. That is the problem in India. That's why I said we are 5th largest economy in the world, but somehow we are not able to convert that wealth into prosperity because we have isolated islands. IIC Bangalore छान आहे, आयझर छान आहे, IIT चांगला आहे, परंतु तिथे किती विद्यार्थी जात आहेत? आपले जर आपण क्रॉस सेक्शन जर बघितला तर ओनली 2 to 3% students are going there. 90% students are going to the colleges and universities where we are having an extensive dearth of the infrastructure. severe dearth of the infrastructure. And this is one of the reason why India is not progressing. This is one of the reason. Otherwise आपल्याकडे खूप पैसा आहे. आणि दुसरं तुम्हाला सांगतोय, तुम्ही प्रश्न फार छान रेज केलाय. दुर्दैवाने आपले जे पॉलिटिशियन आहेत इतके हरामखोर आहेत. तुम्हाला खरं सांगतो, या आपल्याकडे इतका पैसा आहे हे खोटं बोलतायत. मी बघितलंय. अहो तुम्हाला सांगतो, यांची कंट्री बघा मलेशिया, आपल्यापेक्षा पुअर आहे इन टर्म्स ऑफ मराठी असं बोलतो त्यांना कळायला नको. आपल्यापेक्षा पुअर आहे, परंतु तरी सुद्धा तुम्ही कोलालंपूरला जा, तुम्हाला वाटत नाही देयर इज अ ह्यूज डिफरन्स. तुम्हाला वाटतं कुठे स्वर्गात आलो काय मी. साऊथ कोरियाला जा, तैवानला जा, ट्रिमेंडस डेव्हलपमेंट आहे. इकॉनॉमी तेवढी स्ट्रॉंग नाही आहे. आपल्याकडे इकॉनॉमी स्ट्रॉंग आहे, परंतु तो सर्व पैसा आपले हे नेते खातात, रामखोर नेते. आणि दुर्दैवाने आपल्यापर्यंत तो पैसा येत नाही. दिस इज अनफॉर्च्युनेट. आता इथे व्यासपीठ नाही आहे, हे अकॅडमिक व्यासपीठ आहे. तुम्ही टीचर आहात, विद्यार्थी आहेत, आपल्याला बोललं पाहिजे. प्रत्येकाने बोलायला शिकलं पाहिजे. जोपर्यंत बोलणार नाही तोपर्यंत ते खाणं थांबवणार नाहीत. तुम्हाला गंमत सांगतो, नाही, केवळ एक्सपोजर नाही, म्हणून आपण मागे पडतोय. आणि त्यामुळे काय होतं, मग आपण फ्रस्ट्रेट होतोय. आणि म्हणून आता जे काही चाललंय याच्या अंगेच बोला सर्वांनी. असं करू नका. जोपर्यंत आपण बोलणार नाही तोपर्यंत हे थांबणार नाही. अदरवाईज तुम्हाला सांगतो मी, प्रत्येक कॉलेजेसमध्ये सुद्धा स्टेट ऑफ द आर्ट इन्फ्रास्ट्रक्चर येऊ शकते, एवढे रिसोर्सेस आपल्याकडे आहेत. आपण गरीब नाही आहेत. दिस इज मोस्ट अनफॉर्च्युनेट की आपल्याकडे ट्रान्सफॉर्मेशन होत नाही दुर्दैवाने. आणि त्यामुळे बेटा रिसर्च चांगलं होत नाही. त्यामुळे म्हणून मी जनरली आमचं कोलॅबरेशन जे कॉलेजेस सोबत आहे त्याचा पर्पज तो आहे. मला माझ्या विद्यापीठातून विरोध झाला, सांगत नाही कुठल्या कुलगुरूंनी केला. याच्या अगोदरचे कुलगुरू विदर्भाचेच होते, मी सुद्धा विदर्भाचे आहे. त्यांनी बंद करायला लावलं होतं मला. ते म्हटले नथिंग डुईंग, हे जनसेवा बंद करा. मी गेल्या 5 वर्षामध्ये, त्याच्या अगोदर 2016 ते कुलगुरू येईपर्यंत फुकट मुलांना फ्री द्यायचो. जे कोलॅबरेशन यायचे ना त्यांना बसवायचो, बसा शिका, पैसे चार्ज करत नव्हतो. कारण हे फॅसिलिटी आहे कोणासाठी, प्रत्येकाकडून पैसा घ्यायचा का नाही. परंतु हे महाशय आलेत, महाशय येऊन ते बंद करून टाकलंय आणि फॅसिलिटीज बंद झाल्यात. आता पुन्हा नवीन कुलगुरू आले, पुन्हा मी सुरू केलंय, पण आता वेळ कमी आहे माझ्याकडे. ही अवस्था आहे. असे महाहुशार माणसं मोठ्या पदावर जातात, पट्ट्याबोळ करतात विद्यापीठांचा. दुर्दैव आहे आपल्या विद्यापीठात.
Thank you, sir. And for the rest of the questions, we will discuss on the during lunch break. Thank you. And also, I am very much thankful to organizer for giving the opportunity as a chairman of this.
And I'm extremely sorry being harsh. And yeah, this is
No, sir, because it is also a point. Thank you.
Time for lunch. The conference will resume with third technical session sharp at 2 p.m. पोस्टर्स प्रेझेंटेशन मध्ये भाग घेतलेल्या सगळ्यांना विनंती आहे की सेकंड फ्लोअर वरती ही सगळी व्यवस्था केलेली आहे. तिथे तुमचे पोस्टर्स तुम्ही डिस्प्ले करा. लंच नंतर त्याचं इव्हॅल्युएशन होणार आहे.
Hello.
Yes,
Hello.
hello.
Professor Tibur,
Good afternoon, sir.
good afternoon.
Yes, good
Yes,
afternoon.
sir. You
I'm
are
sorry, I
audible.
had problem with
Uh,
connection, but hope
yeah,
now it is okay.
yeah. Are you able to hear us?
Yes, yes, sir.
Yes, I
Okay.
hear you.
Yeah, yeah.
So, should I start or
Just wait for a.
Yes, sir.
I
yes?
just will initiate the
I
session.
just invite all the chairman
Madam,
for
go
this
ahead.
technical session 3. Good afternoon to everyone, esteemed dignitaries, respected speakers, distinguished guests, and dear participants. It is with great pleasure that I welcome you all to technical session 3. We are honored to have with us two esteemed scholars who are pioneers in their respective fields. Let us extend a warm welcome to our session chairman, Professor Dr. Abhay Deshmukh from Rashtrasan Tukdoji Maharaj University, Nagpur, and our distinguished resource person, Professor Dr. Timber Heinig from University, Bratislava, Europe, in virtual mode with us. It's my pleasure to introduce the chairman of this session, Professor Dr. Abhay Deshmukh sir. Professor Dr. Abhay Deshmukh sir is a renowned academician and research with vast expertise. He is currently assistant professor in Rashtrasan Tukdoji Maharaj Nagpur University, Nagpur, Maharashtra State, India. Additionally, he is playing role as an director, incubation foundation, business incubation center. He has research experience of 14 years and teaching experience of 8 years. He has administrative experience of 3 years, and in academic and research contribution, he has completed total 6 projects with worth 5.7 crore. In publications, 49 journal articles and 10 conference proceedings are published, and 5 are under review. He has done he has done 4 patents, from which 2 are granted and 1 applied and 1 published. He has published books and chapters. Total number of books are 10, and 4 book chapters also he has published. He has guided 5 students for the PhD, and 2 students are taking guidance under them. He has guided MSc students, total 45 students for their project works, as well as MTech 3 students and BTech 2 students for their project work. He has research expertise area in advanced material synthesis and fabrication, energy storage, photovoltaics, quantum dots for solar cells, flexible energy storage devices, optical molecular, optical material for bioimaging and white LEDs, functional material for water desalination, etc. And he has acquired fellowship and award for CSIR Senior Research Fellowship, National Science Council NSC, Postdoctoral Fellowship from Taiwan, Dr. D.S. Kothari Postdoctoral Fellowship, IISc Bangalore, and in collaboration with IIT Bombay, IIT Madras, IISc Bangalore, NPL Delhi, Taiwan Normal University, he has acquired so many collaborative functions with them. As well as he carry university responsibilities like Director of RTMNU Incubation Center, member of various academic and research committees, organize multiple international and national workshops and conferences. This summary highlights his extensive contribution in academic research and innovation in nanomaterials and energy storage. Under his guidance, we look forward to an insightful and engaging discussion in today's session. Sir, we are honored to have you with us. With this, I would like to invite Dr. Tevde sir, convener of this conference, to facilitate the chairman of this session by offering them memento and bouquet. Thank you, sir. Now, I invite our chairman to give introduction of our today's resource person, Dr. Timber Heinig. It's over to you, sir, now.
Thank you so much. First of all, very good afternoon to all of you, and very good afternoon to Professor Tibor Hanik. Let me introduce Professor Tibor Hanik. So, Professor is a Professor of Biophysics at the Faculty of Mathematics, Physics, and Informatics of Comenius University in Slovakia. Currently, he is also a head of the Biophysics Laboratory of the Department of Nuclear Physics and Biophysics. His research interest includes the development of electrochemical and acoustic biosensors based on DNA aptamers and nanomaterials. He is also an expert of biophysics and biomembranes of model membranes. He is a member of editorial board of bioelectrochemistry elsewhere and sensors and biosensor MPDL. He had also published more than 60 articles in reputed international journals in Scopus and all, with more than 7,500 citations. So with this, let me welcome Professor Tibor, and I'll request him to initiate his talk on technical session 3, which is on a biosensors-based DNA aptamers for monitoring food safety. Let me tell you, Professor, that you have a time from for 45 minutes, and after that we have a session, question and answer session for 10 minutes. So thank you so much, and welcome to you, and over to you, Professor.
Yes, thank you very much, Professor Petkara, and good afternoon in the India. And I also would like to thank you very much to Professor Divade for kind invitation to present this talk, as well as to Professor Mahendra Shirzad for your kind invitation. Thank you very much for introduction, and allow me please to share my presentation. So please confirm whether you see the presentation. So do you see my presentation, please?
No, sir.
So I'll try to share again. And now?
No, sir.
No yet. Maybe now it.
No, sir.
No yet. I don't know what happens. Just a moment. And now?
No, sir.
So how it is possible? I don't know what happens, but Maybe I will send you my presentation and you will share this. I will try again.
Sir, can you please share your difficulty, what you, because of that you are not able to connect with us or share your PPT?
Yes, I will try to share again. So just a moment. And please confirm if now it is possible.
No, sir.
So I don't know what happens because it seems to me that I sharing the screen. So how we can proceed? So maybe I will send you quickly, or who can manage this? I can send to.
On their WhatsApp. On
Yes.
mail ID.
So okay. So I will send my presentation to Dr. Divade.
Sanjay Devde. Dr. Sanjay Devde.
Yes. Okay. So I am sending. So I just sent my presentation to Professor Sanjay Divade.
Yes, sir. We got your PPT.
Yes.
And it's request you, sir, to please complete your session in 30 minutes.
Yes, yes, yes. I will do my best.
Yes, sir.
You can start now, sir.
Can start now, sir.
Yes, but only I do not see the presentation at the screen. So anyway, I will start with the first slide. The first slide is just the title, biosensor based on DNA aptamers for monitoring of food safety. The second slide, main food contaminations. I will speak about development of biosensors for detection of some important food contaminations. It's like mycotoxin, which are toxic metabolites produced by several fungi. This can be like Aspergillus, Penicillium fusarium, and most dangerous are aflatoxin B1, M1, and ochratoxin A. They are usually polluted in several foods like this can be crops, etc. Then there is antibiotics like penicillin, tetracycline, and kanamycin, which can be polluted or can be contaminated by milk or foods due to extensive application of these antibiotics in the treatment of especially agricultural animal. And there are bacterial pathogens like Escherichia coli, Salmonella, and Listeria. So the next slide is a report about contamination, about conventional method for detection of mycotoxin and antibiotics. Among conventional methods for detection, there are quantitative methods and qualitative methods. So qualitative methods are consisting in mostly microbiological. So there is, for example, growing the bacteria and effect of antibiotics on this grow of bacteria. Then there is quantitative methods, which is most used chromatography. Among chromatography, it is high performance liquid chromatography, gas chromatography, mass spectroscopy, and combination of these methods. Alternative methods is based on antibodies. This can be very popular and widely used enzyme-linked immunosorbent assay, which can be direct. This means that analyte, which we would like to detect, for example, here it is the antibodies, or this can be protein or antibiotics, is on the surfaces. Then addition of antibody, which is modified by enzyme, cause degradation of substrate, which results in product which can be detected by, for example, optical methods in the case if the substrate is optically active, or by electrochemical methods in the case of the substrate is electroactive. There is also indirect assay. In this case, two antibodies should be used. For example, in this case, the antibody selective to this analyte, for example, to antibiotics, is immobilized at the surface. After addition of the analyte, for example, antibiotics, the second antibody modified by enzyme is added. And again, we have degradation of the substrate and the detection of the reaction. So typical electrochemical ELISA is based, for example, in application of hydroquinone, which is oxidase to benzoquinone at presence of horseradish peroxidase. And this reaction can be detected by typical electrochemical methods. Among conventional method for monitoring of bacterial contamination is, for example, microbiological methods, which is most common and consisting in addition of the sample of bacteria on agar plate, then spreading over the surface, incubation of this bacteria and colony growth then happens, and this colony growth is monitored by spectroscopy, by simple light spectroscopy. Among more advanced methods are gene detection, which is including polymerase chain reaction, or this can be ELISA. In this case, the detection method is about 1 hour, but there is some limitations. So in this slide, this is slide number 5, there is comparison of advantage and disadvantage of conventional methods. So advantage of conventional method is sufficient sensitivity, good selectivity, good reproducibility, but disadvantage is high cost, expensive instruments and antibodies. Then this method needs qualified technicians and specialized microbiological laboratories because, for example, most of the bacteria are dangerous and infectious. Then chromatographic method like HPLC use organic solvent, which is additional pollution for environment. Then also sample pretreatment is necessary, and usually these methods are impossible to use on site. Next slide, number 6, is just table in which demonstrate the maximum residual limit for selected food contaminants according to European regulations. As you can see, there is different concentration for aflatoxin, ochratoxin, penicillin, tetracycline, and Escherichia coli, Salmonella, etc. So typically it is about, for low molecular compounds, around microgram per kilogram. For bacteria, it is also different from 100 of colony forming units until much lower, about 1 and 1 colony forming units. Next slide, slide number 7, display the biosensor technology which can replace the conventional method. The biosensor consisting of several important parts. The most important is sensing layer, which consists of receptor, which can be antibodies or, for example, aptamers, then transducer, which transduce the chemical signal into measurable electrical, optical, or acoustic signal. Then there is electronic devices and computer for analysis the data. So, so far, mostly aptamers, so mostly antibodies has been used in so-called affinity biosensors, but now the trends is in application of DNA aptamer for sensing technology. So the next slide, slide number 8, it is some characterization of aptamers. Aptamers, DNA or RNA, are also known as chemical antibodies. And in definition, they are single-stranded oligonucleotides, then in solution fall into three-dimensional structure, forming binding site of some molecules. You can see different conformation of aptamers depending on the ionic strengths, on the pH, and of course on the nucleotide sequence. Aptamers has been discovered in 1990 by 3 laboratories in United States. Ellington and Shostak introduced then the aptamer, which consists on 2 parts. Aptus means to fit, and meros mean the part. Turek and Gold have had very important invention. They developed SELEX, the method of selection of DNA aptamer. So here on slide number 10, there is a scheme of SELEX, the method of synthesis of aptamers. So in contrast with antibodies, the SELEX is the method of development of aptamers in vitro. This means that they need not to use uh, animals for production of these aptamers. The principle is that first a random library of various sequences of DNA is produced. It is 10 in 13 to 10 in 15 various sentences of the same length. Addition of target resulted in binding of some sequences which are which has more affinity to this target. After washing and removing, not binding nucleic acid, there is the complex of tightly bonded nucleic acid to the target. After elution, there is removal of this nucleic acid from the target. Then there is amplification, regeneration, and this cycle is repeated several times, about 10 times. So finally, we obtain the aptamer with highest affinity to the target. Concerning bacteria, it is some modification of this selects, which is named by cell select. So in this case, instead of low molecular analyte, the target cells are used. So this is demonstrated on slide number 11. So if we can summarize, the aptamers has a high activity incomparable with antibodies in picomolar to nanomolar range of constant of distillation. Aptamers can distinguish protein isoforms, can be selected practically to any target, any molecules, cells, bacteria, or cancer cells. The advantage is also they have very fast tissue penetration due to small size, and can be immobilized on the surfaces and thus can serve as receptors in biosensors. So the next slide, it is slide number 13, summarize the properties of aptamers versus antibodies. So if we compare, the aptamers has high affinity
Sir, you are not audible.
in vitro chemical protocol extends antibody and have very limited storage time and also are much more expensive. Then at the next slide, and the next slide, slide number 14, it is just demonstration the reason of high specificity and stability of aptamers. So aptamers typically forms lobes or various motifs, but one interesting motif is so-called guanine quadruplex. The guanine quadruplex is characterized by higher charge of the higher density of surface. So this is very well for electrostatic interaction between molecules. So in the next slide, slide number 15, you can see the stoichiometry of binding cations to guanine quadruplex. For example, potassium stabilize guanine quadruplex while sodium destabilize. Up on the slide number 16, also allowing so-called molecular engineering. So it is possible to use the aptamers and use very simple limit of detection is not so sensitive. It's about 1,000 colony forming units per minute, but still it is enough for detection. Now, in the final part, I'm going to show you advantage of acoustic biosensor based on quartz crystal microbalance with dissipation.
Hello.
These acoustic sensors are based on using quartz crystals with electrodes from the gold, and the application of external electric field with frequency between 5 to 75 megahertz resulted in sharing oscillation of these crystals. So the sharing oscillation are characterized by changes in the resonant frequency and correlation between changes of the frequency and the mass, relation between changes of the frequency and the mass, and also between changes of so-called dissipation and so-called motion resistance, which both are in opposite directions. So, for example, addition of the analyte can result in decreasing of the frequency due to increasing of the mass, but decreasing of motion resistance or dissipation is due to viscosity effect. So here it is on slide 33 some examples of detection of pseudomonas using VC diopter sensors. You can see on this left side the immobilization of aptamers. Then also it is possible to use gold nanoparticles modified by aptamers for amplifications. And here is on slide 34 the detection of pseudomonas by this method. You can see that depending on the concentration of bacteria, there is a decreasing of the frequency. And this effect is strongest for addition of gold nanoparticles, which are simply used for amplification of detection. So also on the right side, you can see the comparison of detection of pseudomonas with another bacteria for which the aptamer is not selective, and you can see that the signal for pseudomonas is much larger. Another very interesting method, it is presented on the next slide, is EMPAS, or so-called electromagnetic piezoelectric acoustic sensors. In contrast with traditional QCM, the oscillation are induced by electromagnetic induction produced by spiral coil. So in this case, the advantage is that it's possible to work in very high frequency up to 1 gigahertz, and so as much as the frequency is, the sensitivity increasing. Also in detection and development of sensor, it is very important to prepare the surfaces with anti-fouling properties in order to directly use them in the not treated samples. So it is the example of the preparation of the layer with anti-fouling linker, which has been developed together with University in Toronto. And here you can see example of changes of the frequency following addition of the buffer for not covered crystals and for crystal covered with various linker. Also the same is in the milk on the right side. You can see that for bar crystals there is a strong response, but for various linkers there is practically negligible increasing, decreasing or increasing or changes of the frequency. Here is the example of applications is EMPAS for detection Escherichia coli. So here is the slide, next slide, the calibration curve. So it is possible to detect Escherichia coli with very high sensitivity of about 8 colony forming units per milliliter in milk and also in the buffer. And here on the slide number 4, you can see the determination of so-called constant of distillation using linear Borg approach. This detection is important in order to analyze the binding properties of the aptamers. So constant of distillation reflects the stability of the complex. As low as it is, the complex is much more stable. So here on this picture you can see the comparison of specificity of detection and role of anti-fouling surfaces. You can see on the left side there is the bar crystal without specific fouling linkers. On the right side you can see anti-fouling surfaces, and you can see that in this case the detection is much more clear and can be used in not treated sample. So in conclusion, we can say that DNA upturners are rather sensitive receptors for detection of mycotoxin, antibiotics, and bacterial pathogens. The polymerized surface with redox probes are advantageous for electrochemical detection of mycotoxins. Then acoustic methods are valuable tools for detection of various compounds, especially because they are lab-free, and antifolding linkers are preferable in application of biosensors. The current trends are in application of various nanomaterials. This can be carbon nanotubes, this can be metal organic frameworks, and another approach which also improve the detections. And finally, I would like to acknowledge my colleagues from Comenius University, from Hungarian Dairy Research Institute, from University of Toronto, from Kazan Federal University in Russia, and I also would like to thank you to Professor Mahendra Shirhat from Rusa Center for Advanced Sensor Technology from India, from which we started 2 years ago, very nice and very productive collaboration, also including the biosensor for development of detection system for antibiotics and also heavy metals. So thank you very much for your attention, and please, if you have any question, I will be happy to respond.
Hello.
Hello. So, thank you so much, sir.
So I'm not sure whether you hear me and whether you have any questions.
Yeah, if thank you so much, sir. If you have any questions, please, this session is open for the question and answer. So, I have one question, sir. Hello, Professor. Hello. Hello.
Sorry, do you hear me?
Yeah, now we can hear you. So, whatever the results you have shown, how we can conclude it that what is the accuracy of the things we have detected in your results? Like you have shown that in milk and yogurt you have identified the 110% of the antibodies and all, right? So does it is how much accuracy of these things? So thank you so much, Professor Tibo. I, 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 and for your very nice presentation, and I hope that students have enjoyed your session, and obviously they will look for the biosensors which can be useful for the detection of the pathogens and all. So thank you so much. Now I hand over these sessions to Anka. Thank you so much.
Thank you, sir. As we concluded this insightful session, I would like to extend my heartfelt gratitude to our esteemed session chairperson, Professor Dr. Abhay Deshmukh sir, for his valuable guidance and support. A special thanks to our distinguished speaker, Professor Dr. Timber Heinig, as his time and expertise. I also thanks to all the participants for their active engagement. With this, we formally conclude the technical session 3, wishing you all a great
continuation of conference. Thank you. Immediately after this, our next session will be started very soon. Thank you. I invite all the dignitaries to please come on the stage for next session. I request all the dignitaries to please come on the stage for our next technical session. Dr. Lad sir, Dr. Dobre sir, Swagatam, Swagatam, Shubha Swagatam. I welcome one and all to the fourth technical session of the one-day international conference on emerging trades in physical sciences, organized by Department of Physics, Shankarlal Khandelwal College, Akola, Maharashtra, India. It is an absolute honor to welcome you all to technical session 4. This session promises to be an enlightening discussion on the latest advancement, challenges, and future prospect of phosphorus in various fields. Before we begin, let us extend our warm greetings to all the distinguished guests, delegates, and participants who have joined us for this session. Today, for this session, we are very honored to have two very esteemed and renowned personalities, Professor Dr. Ajay Lad sir as the chairperson and Professor Dr. Sanjay Dobre sir as a resource person. We are privileged to have with us an eminent academician and researcher as the session chair, Professor Dr. Lad sir. It's my pleasure to introduce them. Dr. Lad sir is Director Innovation, Incubation and Linkages, Santa Gadge Baba Amravati University, Amravati's Director. He is a member, Senate member of Santa Gadge Baba Amravati University, as well as Academic Council, Santa Gadge Baba Amravati University. Member and Secretary of Board of Dean, Santa Gadge Baba Amravati University. Member Secretary, Board of Research, as well as Member Secretary of Board of Innovation, Incubation and Enterprises, Santa Gadge Baba Amravati University. He is also Member Secretary, Board of National, International and Linkages of Santa Gadge Baba Amravati University. Member Secretary, Crowd CSR Funding, SGBAU Amravati University. Chairman, IPR Cell, SGBAU Amravati University. Chairman of Avishkar Committee, Santa Gadge Baba Amravati University, as well as Director, Santa Gadge Baba Amravati University Research and Foundation Incubation Center. He is a coordinator of Avishkar, NSS, IQAC Research Centers, as well as he has 25 years of teaching and research experience. He has granted 1 patent. He published 60 research papers in international journals. He published 8 books and inside it internationally 2 books are published and nationally 6 books are published under their guidance, as well as he edited 12 number of books in national and international conferences.
He guided total 5 candidates for the PhD, and 3 candidates are ongoing registered under their guidance. Research projects undertaken by them are completed. One of it is of 5 lakhs RGSTC Mumbai's project he has completed, and 1,70,000 UGC New Delhi's project he has completed. He has given invited talk on in international conferences abroad, Singapore, Sri Lanka, Malaysia, Luxembourg, and etc. He has fellowship of International Center for Theoretical Physics, Scientist, Italy, and editorial board of member of International Journal of Advanced Engineering Science and Research Technology, ACES GBAU Amravati University. He has honored with awards like Young Scientist Award, Best National Service Scheme Award NSS, as well as Best Research Paper Poster Presentation Awards also he has acquired. He now he is President of IAPT Maharashtra, as well as Joint Secretary of STAMI New Delhi. So I welcome here, and sir, it's our honor to you have over here. We look forward for your guidance throughout this session. And with this, I would like to invite Dr. Devde sir, convener of this conference, to facilitate the chairperson of this session by offering them bouquet and memento. Thank you, sir. Now I invite our chairperson to give introduction of our resource person, Dr. Dhobde sir. And now I will hand over the session to our chairperson. It's over to you, sir, now.
May I introduce eminent personality, थोडं सरांबद्दल बोलताना म्हणजे भाग्य लागते किंवा त्यांच्याबद्दलचं इंट्रोडक्शन देताना आपल्यासारख्या माणसाला, म्हणजे आम्ही विद्यार्थी जीवनामध्ये जेव्हा काम करत होतो तर सर तेव्हा रिसर्च करत होते, तर म्हणजे अशा व्यक्तीचं, ज्या व्यक्तीचा स्कोपस इंडेक्स पासून तर सायटेशन नागपूर विद्यापीठामध्ये सरांनी 1984 to 2024 लेटेस्ट 2 दिवसा अगोदर पोस्ट केली होती. सरांचा दुसरा नंबर, म्हणजे कमल सिंग मॅडमचा नंबर 4था 5वा. त्यासाठी बिट्स कॅप. May I introduce Dr. Sanjay Dhobde sir. He is a senior professor, Department of Physics, Rashtrasant Tuकडोजी Maharaj, Nagpur University. He has about 32-year teaching experience at undergraduate, postgraduate level. He has 31-year research experience. He has delivered keynote address, invited talks, guest lecture, about 185. He has visited abroad, Italy, Egypt, Japan, Australia, Hong Kong, South Africa, South Korea,
Greece, UK, China, Sweden, Malaysia with me, Malaysia and Singapore with Dr. Doble sir. And Scopus publication, research paper publication is 1996, around the 1000. Citation is near about 15,000. 14,788 is a in, and H index is around 50. And citation on Google Scholar is 18,000. H index is 57 and I-10 index is 4, 5 is around. He has edited 31 international books. He has published 95 patents, and out of 56 are already granted. He has 78 students got PhD under his able guidance, and rupees 2.5 crore research grant received from DST, TRNS, CSIR, UGC, and ICU. Recently, Dr. Dobre name considered in top 0.05% in scholar GPS at world level in the year of 4. Top 20% scientists in the world in the year 20, 21, 22, 23 and 24 in the prestigious list published by the team of the scientists US Stanford University. As per the recently published data on base material science scientists in India on 24 April 23, Dr. Dobre is at third position in India in terms of total research public focus. Big hand for the Dr. Dobre sir. He has received Gandhi Social Teacher Award, rupees 1 lakh. Recently, he has received in February 25. Fellow of Luminescence Society, Fellow of Maharashtra Academy of Science, Best Research Award 2016 for the outstanding contribution in the field of research for the university, presented by ITM Nagpur University, Nagpur, India on 5th September 2016. Academic Council member of the Datta Meghe Institute of Higher Education Research, Team University, Medical University, Savangi Meghe, Varda, and there are so many. May I request Dr. Professor deliver your.
Hello. Sir, please welcome them. Dr. Devde sir. Dr. Devde sir, please, I invite you to welcome them by giving bouquet and memento. Thank you, sir.
Good afternoon to all.
Thank you, Devare sir, and principal of this college for inviting me for delivering the talk. Really happy. I'm second time present in Akola and for a conference first time. So, thank you, Chairman. You introduced me for very briefly and very nicely. So now I'm interested to deliver my talk, and this topic is the multidisciplinary application of phosphor and what are the challenges. Phosphor is the luminescence material, and any material emit the light by any process. So this material is called the phosphor. And intention of my talk, just for the new person, just recently joined the research as well as some of the students. So I'm discussing all disciplinary application of this one. First, I'm discuss the phosphor, and what is the phosphor? It is very important. So I'm just concentrating what is the luminescence. Luminescence is the one of the phenomena that it has this electron present in the ground state, and after excitation of its energy, this electron reach in the upper level, that is equal to 2. So excited electron is not possible to stay in the long side. That this electron again jump to the ground state, and during this process, this electron emits some energy in terms of the photon, and this emission of this photon is called the luminescence. So this electron jump to the ground state, and emission of this photon is called the luminescence. This is the very simple explanation of the luminescence. So what is the application of luminescence? Luminescence, so many applications, this lamp, laser, display, TLD, LED, ink, dating, so many type of applications. It is all application is not possible for in one lab. So some of the applications covered by me, and some of the application I am to consider here, and then what is the problem? This is also discussed with this. So just we are find out the some of the applications. The indoor plant cultivation is important, biomedical application, and this is the Li-Fi is also important. So all these applications are very easily, and just therefore I'm working on the following topics. My topic on the related to the phosphor. First is the LED application for the artificial lighting. This is the LED. After that, the solar cell epicenter enhancement, field radiation dosimetry, ion beam irradiation, plant cultivation. This light directly incident on the plant. Then plant growth is very nicely. Fingerprint for the forensic application, long-lasting and road traffic discuss, safety, biosensor, antimicrobial activity, phototherapy, mosquitoes repellent, machine learning on phosphor, geological material for the radiation dosimetry, and fabrication of the biomedical device, fabrication of the device for the Ayurveda, and all other subjects also. So if I'm concentrated on the application of phosphor, so all type of the subject we are covered, and engineering and technology as well as to the science, maximum subject covered with me by all this luminescence application. So experimental just we are trying to the preparation of this phosphor by solid state weight chemical and novel synthesis. So some of the technique I briefly discussed here and find out this one. Just you can see this is the one of the application is the combustion synthesis. This combustion synthesis crush and this material, this nitrate-based material, you can fire at the 550 degrees centigrade, and then again put in the higher temperature 550. So this flame is observed. The flame temperature is the 15 to 1600 degrees centigrade, and material prepared in this temperature, and this is the material. It is a very nanomaterial. Second method, and then you can change the morphology of this material. So different type of the fuel you can use, and you can change the morphology of the material, particles of the material also. So now, just in the sol-gel method, it has the nitrate material, and you can dissolve in the double distilled water. After that, this is the rare earth oxide, and you can dissolve the tetrahydroxysilicate and ethanol and ammonia. Then same is the combustion method. This method is completely devoted for the nanomaterial. So this is the important method for preparation of this material. Now, this is the solid state method. It is very important. All type of the starting material, you can use any one. Just you can double crush it. First is you can crush after cooling the 500 degrees centigrade. Again you can crush, and then fire at a long time at the higher temperature. So this material is prepared due to the strong diffusion process. Now next, it is the wet chemical method. It is a very simple way. All the nitrate material you can dissolve, double distilled water, and then this the rare earth element you can dissolve and fire at the 60 to 80 degrees centigrade, and this is the completely nanomaterial is prepared. So this is the, if you want to the waste material, then this is the eggshell. It is the source of the calcium oxide.
So this calcium-based material we can prepare with the help of the eggshell. Silicate-based material also you can possible to prepare with help of the rice husks. So this is all this method, and after preparation of this material, we can characterization by the spectrophotometer, thermoluminescence, UV visible, spin coater. All a device is not possible in the one laboratory, but some of the device possible. Some of the you can collaborate with the other laboratory, and then this facility is possible. Next is the high temperature furnace for the synthesis of material, different muffle temperature furnaces, centrifuge machine, and this is the LED solar cell simulator. And it is a full characterized by ACM, TAME, and this is the XRD as well as TJDT. So all these apparatus required for the characterization of this material. Now I'm concentrate one by one for the application of this material. So just you can see, this is the phosphor for LED application, and this is called the artificial lighting. So just you can see, this is our material in the LED, in the diode material, and all this phosphor you can prepare for this material, and then it is possible this material is emit the good light for the visible region. So just you can see here, LED, it is a lifetime of 1000 hours, and it is not contain any part of the mercury. So this is the eco-friendly lamp, as well as it is a very small in size, and it is the lifetime is much more, and it is the 90% for the electric power saving. So this material is called the eco-friendly device for the lighting purpose, and it is presently much more used for the application of the white light emission. So if you can prepare this LED, please require the blue LED, green LED, and red LED. After the mixing of this three color phosphor, it is possible you can emit the white color. So it is required that you can prepare this phosphor in our laboratory for the different route of synthesis. That is possible to prepare. Again, nowadays the two color LED material also available. Blue and yellow, you can mix in that white color emission is also possible. Now you can excited by the UV light and UV red, blue, green. It is the white color phosphor is also possible. So tricolor LED and its emission, just you can see the blue, green, and red. It is combinedly then it's possible to the white color, and this type of the LED already available in the market. So this material used in this LED with help of this one, it is also possible to the white LED material. So in our laboratory, we are preparing this type of the material, but under the UV light, this is the blue color, green color, and red color. This light of the emission is observed, and after mixing of this all this phosphor, white LED is possible. Now, for the preparation of this material in the mainly periodic table, all this the rarer lanthanide based material is possible to prepare the different color, but it is not possible to the all rarer fuse. So I have selected LED materials, rarer fuse, European C, DY, TB, and SF. This is called the down conversion phosphor, and it is useful for the material. And some of the host material is the aluminum borate, nitrate, oxide, phosphate, or any one phosphate you can dope with the rarer than possible to the white LED phosphor. Now just you can see this is the excitation source, indium gallium nitride. This is the one of the chips you can excite it by the different concentration of the indium. So different emission is possible. In 1996, this is the Indian gallium nitride. X value is the around to the 0.22. That blue emission is possible in the 460 nanometer, and they are received the Nobel laureate, Nobel Prize on this investigation of this blue LED. So this is the now source of excitation source for the LED material is required. So it is not required the mercury. So this LED it is the main the eco-friendly lamp. Now this is the very important. You can excite it by this indium gallium nitride, and one of the host material you dope with the europium then red emission, dope with the SM then orange emission, dope with the PR in the blue emission, and after this is the emission you can combinedly observe this is the white color. So this is called the graphical abstract. If you want to publish your paper in a high impact factor, so this type of the graphical abstract is required. So your result in the present, your research paper, and how to this result you can combine in the one figure. So this figure is good, then this is called the graphical abstract. And nowadays it is required, this graphical abstract for publication of your research paper at the high impact factor. So you can prepare your result in the particular type of the figure that easily. Now, next one is just we are prepared the one of the silicate phosphor is the European dope, and you can see cerium, aluminum, SiO17. So you can excitation observe 354 nanometer is the near UV. It is not the mercury is required. So emission observe the 486 nanometer in the blue region of the spectrum. Just you can see this is the blue color. But second is it is doped the European 3+ ion by prepared by the Solier technique. That 612 nanometer in the red region of the spectrum. This is the red color. Now, this is the phosphorus dope with the TB3+. TB3+ is the emission observed in the green color. So this is the green color is possible to the one of the phosphor, and combinedly all the red, blue, green is possible to the white emission. So this is the different phosphor is prepared by different activator. But nowadays you are interested to work in the LED material. So only one of the target in our laboratory, how to enhance the LED material intensity. Second thing, how to prepare your material, it is non-toxic or eco-friendly. And third one is the very low cost. So for this purpose, just you can change the combination of the excitation emission wavelength, just you can change the chemical root synthesis, starting material and heat treatment. But nowadays it is a very frontline work in the LED material, and this is the, you can change the host material. Host material you can change with help of the, just you can see your material, it has the content of VO4. VO4 you can replace by the BO3, MO4, WO4, PO4. So this is the host is completely changes. So one color emission you can shift to the other color emission. This is called the color tuning. In the one host material, the two type of the emission. So it is very important for the development of the LED phosphor for white emission. So just you can control the doping of the activator, varying the concentration and sensorizer activator, combination of the emission by molybdenum, vanadate, tungsten like this one in this row, and cation substitution also has this material, and very interesting results are observed by with help of this one. So this type of the new LED phosphor is prepared by a very simple technique, and then this is the material is the patentized. So now on the basis of the different phosphor, our student is work in this world and try to develop the different phosphor. Today, just you can find the science and technology where to publish the paper. So today, it is the UGC care is not allowed by the UGC. So only for your option is the peer review, Web of Science, Scopus, or Sci Journals. So you can publish your paper in the Scopus maximum. So if your paper is the impact factor is the 1, but this impact factor is the Thomson router impact factor. So it is good. कोई भी अगर PhD ज्वाइन करता है और आप उससे मिलते हो, आपका स्टूडेंट हो, आपका पहचान के 2 साल के बाद मिल रहे हैं और उसको पूछते हैं कि आपके कितने पेपर हुए, और वो बोलते हैं कि मेरे 2 पेपर हुए, तो आपका पहला क्वेश्चन रहता है इट इज स्कोपस और यूजीसी और पेयर रिव्यू. तो आपका अगर एक स्कोपस में भी पेपर रहा है तो आप बहुत अप्रिशिएट करते हैं, और इट इज अ वेरी गुड. इफ योर पेपर इज द 1 impact factor, this is the Thomson router. So my request to all sitting all these participants, you can publish your paper in the Scopus, and impact factor is the only Thomson router impact factor. This is the internationally standard impact factor. So this is my paper. I'm one of the author here, and the impact factor is the 1.62. This is the 1.393. ये ऊपर चला गया. And now this is the another paper again. It is the 2.613. This is the, again one of my paper on the biosensor. So if this paper you can publish in the Scopus, then it is very interesting work. Now next one is the one of my paper again is the published is 3.808. 3.808. And now next one again impact factor, it is the 3.8 impact factor, and this paper it is the Nature publication. It is published in the Nature with one of my students in the Karan Kumar Gupta, and this Karan Kumar Gupta presently working in the postdoc fellow in the Taiwan with my foreign collaborator Alexander Crispy. So if anyone student publish the more than 10 paper in the Scopus, so I guarantee, so this student get the postdoc fellow after the PhD. So this is till date 16 students get my postdoc fellowship in the different country with my foreign collaborator, and this paper is the Nature publication. Just you can see here the Nature. ऊपर में लिखा है वो screen पे नहीं आ रहा. It is some of the problem here. Another paper is also published the 4.03. This is the RSP group. You know that any chemistry people always interested to publish his or her paper in the RSC. RSC means Royal Society of Chemistry, or ACS, American Chemical Society. Physics वाले नहीं चाहते, इतना ज़्यादा इंटरेस्ट नहीं. केमिस्ट्री वाले उसमें अगर पब्लिश करो बहुत स्टैंडर्ड माना जाता है उसको. So our physics people also tried for this, and I published so many papers in the RSC as well as to the ACS. So this is the impact factor, the 4.03 with this my collaborator. Now next paper it is the by Govind Nair, it is the 4.712. It's a ऊपर जा रहा है. So Govind Nair is the one of my student. Now presently is the postdoc fellow in the South Africa, and now this is the very good publisher for. अब जब अपन एक impact factor के request करते हैं student को कि आप एक impact factor का paper minimum publish कीजिए और एक 4 impact factor का paper publish करेगा, तो this is the very easily you can get the postdoc fellowship or job also. So this is the very interesting. Now second is the Ashish Tiwari again published the paper in the Mr. Guru, this is the ACS publication. Here mentioned the ACS publication is the 4 point something impact factor of this one. Now, this is the Bhushan Kore. It is the impact factor is the 5.4360. Now, Bhushan Kore, it is also one of my PhD students. Is working with the Hendrik Swart, and now he is presently working in the Germany. First, this student is the get the postdoc fellowship in the South Africa. After that, he get the Kotari fellowship. Then he joined the ISC, Indian Institute of Science, Bangalore for 3 years. And after that, again the postdoc in Sweden, now Germany. Now presently he is working in the Germany. 3 postdoc fellowship after publishing the very good impact factor paper. So again, another paper also 5.43 by this Bhushan Kore, and this is a very interesting and good hard worker. This is the biological paper, antimicrobial activity by one of my students, Smriti Tawar, and its impact factor is 6.2. It is just you can see 6.2. इसको नीचे नहीं हो सकता क्या? हाँ, उसको रिंग घुमाने से हो जाएगा शायद. होत असेल कारण तुम्ही चालवत आहे, don't worry. Okay, so this is the 6.2 impact factor of this one. This is a very interesting paper about the antimicrobial activity. Now, next paper is the, again, just you can see it is a 6.317 by this Abhijit Kadam. This is the student is presently working in the Aurangabad, in the one of the degree college, and his payment is the 83,000 rupees. Why? He's published the 44 paper during his PhD and after 1 year. So this is the directly get the high amount of job salary. So this is very interesting. If you publish the very good paper, then it is not a problem of the job, and they are called by this person, and it's the good payment of this one, Abhijit Kadam, 6.3. Now next one is the again Toshita Dabodkar and Abhijit Kadam, 7.613. Now next again Abhijit Kadam again 7.7. This is the impact factor in the Thomson router. So just you can again 8.31 by this paper in the progress in solid state chemistry. Now 16.799 by this VB Powde, and this VB Powde presently working the Lakshminarayan Institute of Technology, University Nagpur. So if you have published a very good paper, then you can get the very good job anywhere in the world. So now next is the Tejo Kalyani. She is also working in the LIT University in the 16.799 impact factor published. Second paper also Tejo Kalyani the 16.7799. So day by day I improve my impact factor with my student, and they are getting the good job as well as to the postdoc fellowship. So I have success to publish one of the paper in the 13.6 impact factor. So 13, and after that it is the efficiency increased by the 43. That it is the 43 point impact factor. Any problem? तो हम जो भी मटेरियल बनाते हैं उसकी पर्टिकुलर टाइप की एप्लीकेशन देखते हैं, और ये मटेरियल हमारे जो एलईडी मटेरियल है इससे हमने 43% तक की एफिशिएंसी इंक्रीज की है. तो दैन सोलर सेल लाइफ इट इज आल्सो इंक्रीजिंग. So this is a very interesting material for the energy, save the energy material, and then it is very interesting work. What's the problem? स्क्रीन पे आ रहा है ना? यहाँ तो दिख रहा है ना? इधर डायरेक्टली होता है ना. याच्यावर राहू द्या आलं तर ठीक. स्क्रीनवर आहे पण आहे. चालेल चालेल. सांगू नाही शकत आता इकडे आलो आहे. माझा जो ऍक्च्युली सोशल इम्पॅक्ट वाटायला तो सांगितलं सोडणार नाही. सोशल इम्पॅक्ट सांगू ना तुम्ही अकोल्यात बोलवणार आहे तुम्ही मला. आता तू कम्प्युटर काम नाही करत. हो हो. बरोबर. काय सॉरी तुम्हाला मान थोडी टिल्ट करावी लागेल. So just you can see this is the solar material efficiency enhancement by 34%, and this material shows the efficiency of the solar cell material enhanced by 4%. So 20 plus 4 is the 24, that 43.33% solar cell efficiency enhancement. So that this paper is published also more than the 7 impact factor. So this is very interesting, and material also the patentized by Australian patent. Now phosphor for the display devices. So our LED material also useful for the display devices. Just you can see our material, it's the red, blue, green. It shows that for the display purpose also. So this our material is one of the application for the display devices. Just this is the display. You can have just mobile screen or just small flat panel TV like this one. And just you can the phosphor for the road traffic signal. So this is the one of the material paper, the SR2 MG SR207 and U-dome. So it is the blue emitting phosphor, but it is the decay up to the 120 second only. But this material, you can dope with the co-doping with the DY. So this decay time increases for 120 second to the 8 minutes. So this is the 8 minutes up to the decay time after the co-dope with the DY. So by different type of the process, we are trying to enhance the decay of material of this process. And this is the good application of the traffic signal image and other the road safety purpose. So this is also published by this one. Now phosphor for the radiation dosimetry. This is very interesting, useful for the cancer treatment or different type of this radiation laboratory. So this is the thermoluminescence, one of the technique. So it is the material, the high efficiency, the low fading and single peak. So this is the interesting, all these characteristics. I'm not explaining all these characteristics for this patient. And this is the K3NA supervoltage U, one of the material is prepared. So this material, just you can see the, this is the efficiency, XRD pattern is the well match of this, the evaporation method. But this material you can made, so it's a double two-phase material, and it is the efficiency is very high. And this you can compare with the CSO device with the Bhabha Atomic Research Center material. So our material is a 6 times more intense. So this is the quality of the research in the university level. So it is not necessary that all this research is possible in the national lab. It is also possible in the university and college level also. So just you can see this is the one of the good characteristics. To the BRC developed material, and this is our lab material. Our material is the 6 times higher to the CSO device. So this is a very good, interesting material, and I've published so many papers on this characteristic. And this is one of the technique is very useful for the TLD purpose. It's a decay study, and now this is the TLD batches. This is the direct applied work. This anybody working in the radiation laboratory, that these batches are very compulsory. Now, and this is the paper are published. So I'm just trying to the different subject. So I'm just going in the geology department with the Bandana Saman madam, the dinosaur eggshell, and this is a very small portion we can use over my study. So I observed this material is the useful for the high dose dosimeter. So dinosaur fossil, it is also show that the very good characteristic of the thermoluminescent dosimetry. After successful of this paper, I'm published. I'm just doing again this same laboratory with the Bandana Saman, the geology professor, and then I'll take the turtle shell, and this material also show the good high dose dosimetry material. So this is the very interesting. Now phosphor for the ion beam irradiation. If you want to the changes in your material, so you can expose your material in the different type of the irradiation, different type of the ions. So morphology of this material you can changes. So this is a carbon ion beam. It is useful for the cancer therapy. Cancer directly you can exposed by the gamma ray. This is the penetrated. So this normal shell it is also exposed. But carbon particle, heavy ion particle, it is reach at the particular one level, and then just you can see this is the reach up to cancer cell, and then cancer cell it is the dead. So this is the very useful for like this one. This is the only facility in the IUAC. My research collaboration in the IUAC like this one, and this is the very interesting. And this is the characterized by the bractic. So just you can see this is the bractics of this one. And this study, it is also vacuum chamber, and the sample you can put in this hole by a particular process. Just our material is indicated to here. And just I prepared this material by this one sheet in the New Delhi in the nuclear laboratory. And just put in this particular format, and then you can see this is the carbon particle incident, that is the green emission. It is called the ionoluminescence. This material shows the blue emission by U2 plus, then it is also, this is called the ionoluminescence. So this carbon 5 plus, it is useful for the cancer treatment. So our work it is also medical application. So it is a very interesting work. You can show that. This is the Nature publication, just already discussed with the Karan Kumar Gupta. And now, this is again, you can see the oxygen particle also useful for the bombardment of this material. And this very complicated material, it is the morphology is completely changes. Now, up conversion nanoparticle for cancer therapy. So this nanoparticle directly, it is a high range, 880 nanometer, collide to the cancer cell. So this is the directly up conversion material. So this directly is the killer rate, and reactive oxygen species are generated, and this ROS directly collide to the protein shell of the cancer cell. The protein, it is a totally damaged. So cancer cell also damaged in the same position. So this NIR light, it is also useful for the cancer treatment. So my work on the development of the nanoparticle with for the NIR range, and with the help of the pharmacy people, I'm working on this. And recently I submitted the 1 crore project, 1 crore rupees project on this topic. So this is the very interesting, just when mouse, as I find out that this is irradiation in the 980 nanometer. So localized in the liver because, and this is the blood from the particular position, and this is the, you can disappear after 24 hours. So this is a very good indication, and so many papers published on this nanomaterial for this application. So this is the, just you can see all these papers are published. Now this is the correlated corrected exposure of the treatment of the cancer. Yes, you can expose your body by the gamma ray in the cancer hospital. So your body, it is the up and down by the breathing purpose. So this is the physicist measure the dose with the help of this particular technology in the height, but your body, it is the up and down in the 1 incident, error is created. Error, it is also measured by my student with the collaboration with me, and this is the good result are observed, and this is also result published at a good place. So all this is the biological or medical application of this material, and it show that the very interesting work. Yes, you can see like this. So phosphor for antimicrobial activity. This is very important. Just you can prepare the copper nanoparticle with help of this the green synthesis route, and for एगल purpose the copper nanoparticle एगल purpose में this is the बेल पत्ती वाला पेड़ है ये, उसके बेल के पत्ते लेके अपन ने उसको बनाया. So just you can see this is the simple method. You can put the copper nitrate, and this is the solution color is the changes. And after that you can take the XRD, then XRD pattern is the completely for the nanomaterial, and just you can see this is the FTR for the bonding of these materials. You can show in here, and in the table show that 16 nanometer. This is a very fine particle possible, and this particle are more effective for the antimicrobial activity. So just you can see this is the antimicrobial activity for the different bacteria is colon and other one. So this indicate a good antimicrobial activity. So this is very useful for the biomedical application. So physics people also possible to multidisciplinary work of our material in the different subject. So this is the very good for the microbiology, biotechnology, or chemical or pharmacy people with the pharmacy people. So this is a very good paper is published in 3.2, and after that this is one of the good review paper published in 6.2 impact factor recently in the before 2 months. So this is the very interesting now. Illuminate nanoparticle also prepared by the green synthesis, and this particle is the 73 nanometer. So just you can see that this antimicrobial activity of the Al2O3. But after that, what it do with the rare earth and what is the changes in the antimicrobial activity? So good result observed with the Al2O3 with the U dope. So this material show the good activity. Now, phosphor for plant cultivation. Any plant you can expose by the particular far red region light. So this is the plant is copy increases as well as fertilization is also increases. So this is the far red region, the 630 to 750 nanometer light you can expose. Then this is the fertilization increases and growth is also increasing. And a blue color it is also called the photosynthesis. So this very interesting work, and then you can observe this type of the result. And this is the, again, you can see the 730 nanometer. So I'm also prepared this material for the different emission. And this is the only technology useful for the, you can decrease the suicide cases of the Vidarbha farmer. So for this purpose, just you can see one of the technique here, you can the UV light exposes, and just you can observe, this is the 14th floor. So just you can, after 1.5 feet, you can floor, very small space, you can produce so many type of the plant under this light, and then this one. तो मैंने अभी तक के ग्रीन हाउस देखा उसमें विदाउट ग्रीन शीट लगे रहते हैं 20 डिग्री तक के टेम्परेचर कम करता है या थोड़ा सा बट दिस इज यू कैन सम लाइट सो इट इज द वेरी इंटरेस्टिंग सो दिस इज द वन एस्ट्रोनॉट स्टेइंग इन द स्पेस इन द 229 डे 48 आवर्स तो मैंने इसको पूछा कि इतने दिन खाया क्या पिया क्या तो पॉसिबल है ना इतने दिन उस स्पेस रहा तो 5 मिनट अपने साथ रह सकता है ना ये रिसर्च है अपने अपन कहाँ तक जा सकते तो दिस पर्सन इन द सियाओ discussion with me. I am with this person in the Sydney, Australia. So बोले कि just we are developing the LED phosphor exposed material, and that's this plant for my food. So अंतर्विरासाठी आता शेती याच्यातून मी क्लिक झालो आणि हा प्रोजेक्ट मी केला. This is very useful. Our physics people work on the plant cultivation for the ISRO purpose. अपन बोलते कि ISRO में यार स्पेस उड़ा नहीं है, ऐसा नहीं है, जाना शटल जाना ही नहीं है, उसके लिए जो डाटा लगता है वो भी अपन फिजिक्स वाले कंट्रीब्यूट कर सकते हैं. So this is the very interesting work for this one, and this is the एक मैंने प्रोजेक्ट लिया है और उसको मैंने समुद्रपुर का विद्या विकास कॉलेज है उसमें हमने लो कॉस्ट ग्रीन हाउस बनाया और उसके साथ में हमने ये मैडम है बॉटनी की हेड ऑफ द डिपार्टमेंट उनके साथ कोलैबोरेशन करके मैंने प्रोजेक्ट को सबमिट किया. इसमें 2 पेटेंट बनाए, 4-5 पेपर बनाए, 2-3 रिव्यू बनाए और ये टेक्नोलॉजी हमने फार्मर को लास्ट ईयर हैंड ओवर किया एक वर्कशॉप लेके. तो सूर्याच्या नाही एलईडीच्या झगमगाट पिकल शेती. तो एक समुद्रपुर की मैडम है जो बॉटनी की हेड है उसकी अगर ऐसी न्यूज लोकमत जैसे पेपर में आती है उस कॉलेज का नाम कितना बड़ा होगा. ये मेरा काम है कि मेरे जो साथ में काम करते हैं उनको भी बड़ा करना. तो सर मुझे रोको मत, रोहित और कोहली जैसा हूँ, रोहित और कोहली रोको जैसा रोको मत. तो दिस इज द वेरी गुड इंटरनेशनल पेटेंट ऑन दिस वन. एंड नाउ आई एम वर्किंग ऑन द काउ. This cow can expose by the 16 hour by the LED light. So 8% milk is also increasing. So with the collaboration of the agriculture people, I find out which fuel is responsible for the increase of milk. So I'm working on this one with the collaboration of the agriculture people. So this is a very interesting work with the different, just you can see this is the work is going on with the agriculture university. And now in the phosphor for phototherapy. Phototherapy means on the skin, the 48 type of the disorder. So this order are so clear with help of the 312 nanometer light. 312 nanometer is possible for the GD3+ emission. So just you can see this is the phototherapy, or you can call the psoriasis. ये टाइप की जो डिसेस होती है, तो दिस टाइप ऑफ द सोरासिस इज द डिफरेंट टाइप ऑफ द सोरासिस. It is also possible you can cover about 311 to 315 nanometer. This is a UVB light कहलाएंगे इसको, and that this is useful. It is possible by the GD3 plus you can enhance the intensity by this type of the port open. So just this material also prepare in our laboratory, and just you can see the localized उतना ही portion आपको expose करना है. So it is not possible to be expose the whole body, and newborn may be also exposed to this light. So this type of the biological study also possible on the our material, and this is a good paper is published on this. So now password for the night vision lamp. If material emission in the NIR light, so this is the take the picture in the night also. So this is the particular type of the NR light IR. NR 1 is 750 to 1000, 1000 to 1500, 1500 to 1850. So this light also material also prepared in our laboratory, and this is the upconversion material. So you can catch the photograph in the dark in this person, just like to this one, and just you can see this is the night vision camera device. This is the wild photography. It is also possible. So this lamp is also possible. We have prepared this material for this phosphor screen here, and this work is also very interesting for the defense purpose. So this project I will submit in the defense industry. So prepare this material in the 1536 nanometer light, and then this is very interesting. So this is the daylight, this is the night light. So just this is the very useful for the night vision lab. Now phosphor for the mosquitoes repellent light. Mosquito is not attract to the yellow color. This is the I find out in my result mosquitoes repellent lab. So just we can see this is the yellow color is not dependent. So we are fabricated one of the unit, and just prepare the yellow color phosphor 574 nanometer light emission phosphor paper in our laboratory, and this paper is published in the very good in the 574 nanometer at the 74 nanometer at the 5.6 impact factor. और दिस लाइट इज वेरी यूजफुल फॉर द मॉस्किटोज रिपल्टेंट. जब मैंने ये देखा, मैंने एक डिजाइन किया एमएससी के बच्चों के साथ जो एमएससी फाइनल ईयर के स्टूडेंट थे, कि एक कलर में येलो कलर, उसमें में रेड, इसमें ब्लू, और मॉस्किटो रखे नीचे में, तो उसमें कितने मॉस्किटोज येलो कलर, तो येलो कलर में एक भी मॉस्किटोज टर्न नहीं हुआ, ब्लू और रेड में बहुत से मॉस्किटोज गए. देन वी आर कंक्लूड सो मॉस्किटो इज नॉट टर्न टू द येलो कलर, इट इज द रिपल्टेंट, एंड दिस इज द वेरी न्यूज ऑफ दिस पब्लिश्ड बाय माय एमएससी स्टूडेंट. So this is the MSc student also my department get the patent also. ये मेरे MSc student का patent है with me. तो LED की पीली रोशनी में भागेंगे. मैं यहाँ पे जो भी MSc के बच्चे बैठे होंगे या न्यू रिसर्चर बैठे होंगे, उनको रिक्वेस्ट है आपको जो भी मदद चाहिए मैं करूँगा. हमारे यहाँ के MSc बच्चे भी पेटेंट पब्लिश कर रहे हैं. मैं तो करता ही हूँ, MSc के बच्चे कर रहे हैं. तो जब इसके माँ ने बोला कि तेरा नाम पेपर में आया है, तो उसको उसकी वो बोलता है कि मेरा नाम का माँ का एड्रेस चेंज हो गया, मेरी माँ को मेरे नाम से जानने लगे. और ये होती है कुछ बात अच्छा काम करने की. तो ऑल दिस माय एमएससी बैच स्टूडेंट इज गुड. दिस इज द रिसर्च. डासांना पळवायचे असेल तर एलईडीचा पिवळा प्रकाश इम्पॉर्टंट. तो ऑल दिस जब मैं एक कॉलेज में एलईसी के लिए गया था, तो वहाँ के जो लोग रहते बहुत इंटरेस्ट से बताया, सर दिस इज द गुड प्लान, दिस इज द गुड प्लान. माइक्रोबायोलॉजी सर देशमुख सर, तो उन्होंने बताया कि एजोला प्लांट है, लेकिन सो मेनी एप्लीकेशन. एक एप्लीकेशन बताया कि दिस इज द मॉस्किटो रिपल्टेंट. मॉस्किटो को बताया भगाता क्योंकि ये कार्बन डाइऑक्साइड एब्सॉर्ब करता है और ऑक्सीजन इमिट करता है. कार्बन डाइऑक्साइड कॉन्सेंट्रेशन डिक्रीजिंग द मॉस्किटो. नागपूर तापाने फनफनलं, नागपुरात डेंगू मलेरिया एंड चिकनगुनिया. तो मैंने उनको फोन किया, सर अपन इसमें प्रोजेक्ट डालते, और हमको प्रोजेक्ट भी मिला, और हमने ये एजोला प्लांट को लोगों के सामने लाया. तो नागपुर के पत्रकारों ने उसको फ्रंट लाइन न्यूज बनाई. और ये मैं तो ठीक है, मैं तो आते रहता हूँ पेपर में, ये सर पहली बार अपने कॉलेज के नाम के साथ में न्यूज़पेपर में आया. तो अपना कॉलेज के नाम इंटरनेशनल लेवल पे ले जाने के लिए देशमुख सर ने बहुत अच्छा काम किया. 2 साल के बाद बेचारे रिटायर्ड होने वाले. तो दिस इज वेरी इंटरेस्टिंग वर्क. एजोला मॉस्किटो फॉर करल डासा और नियंत्रण लाइक दिस वन. तो जस्ट इन द लुमिनेसेंस द बायोसेंसर. जब मैंने इस पे देखा सोशल मीडिया पे लाइक दिस वन, तो ऑल दिस द ब्लू बैक्टीरिया आर वेरी इंटरेस्टिंग, एंड उसको मैंने गोवा से कलेक्ट किया, और 2 बैक्टीरिया इट इज रजिस्टर्ड बाय बायोटेक्नोलॉजी मैडम एंड माय नेम. So after that, just I sir, this is the one, and you can expose this way by the UV ray, beta ray, and different type of the radiation. So it will show that effect. Then I'm prepared the biosensor, और उसका बच्ची का नाम जो PhD कर रहे थे उसका पेपर में आरटी में जो रिसर्चर डेवलप द बायोसेंसर. उसके बाद इस बच्चे को तुरंत दूसरे दिन जॉब मिल गया पैथोलॉजी लेबोरेटरी में. तो ये हमारा कुछ कंट्रीब्यूशन स्टूडेंट के लिए होता है, वो हम करते रहे, तो मैं तो करता हूँ. तो मेरा सोशल इम्पैक्ट के लिए बहुत अच्छा है। इसके बाद मैं सोशल इम्पैक्ट के कुछ बोलूंगा। सर आज कितनी भी गाली मारेंगे मैं यहाँ से हटूंगा नहीं, मैं बच्चों के लिए तैयार रहूंगा। तो पासपोर्ट फॉर फिंगरप्रिंट, दिस इज वेरी यूजफुल फॉर द CID के लिए होता है। और जस्ट यू कैन सी वेरी गुड पेपर रिसेंटली पब्लिश विद द वन ऑफ द माय स्टूडेंट, दिस इज PDF द सुमेधा तांबड़ी, पब्लिश विद द वन ऑफ द माय स्टूडेंट, दिस इज PDF द सुमेधा तांबड़ी, ये भी पोस्ट डॉक कर रही है। एंड दिस इज माय नेम विद माय कोलैबोरेटर एस स्वाट, 2024 में मैंने ये पेपर पब्लिश किया। तो ऑल दिस मटेरियल में जो बता रहा हूँ मटेरियल मेरे लैब में बने हुए हैं, उसकी एप्लीकेशन है और दैट इट इज वेरी। नाउ आई एम आल्सो वर्किंग द मशीन लर्निंग वन। तो फास्पर का जो एस्टिमेशन है, एक्साइटेशन इमिशन है, आल्सो आई चेक इन द मशीन लर्निंग विद द वन साइड सॉफ्टवेयर इंजीनियर विजय एल बारे, प्रेडिक्शन एक्साइटेशन वैल्यूज ऑफ फास्पर आर यूजिंग द मशीन लर्निंग। मेरा कंप्यूटर साइंस में भी कोलैबोरेशन। So there is no any question. Recently, our group working the observation phosphor rock cancer therapy, जो भी मैंने बताया, synthesis of phosphor in the nanoscale and find the biological operation specially killed by the cancer cell. And now I'm also working on the Vedic mathematics. अभी मैंने 8 दिन पहले से start किया Vedic mathematics, especially working on the effective automatic breast cancer identification by using the Vedic mathematics. तो उसमें भी मेरा काम अभी शुरू किया है और I'm just identify the breast cancer identification. तो दिस इज ऑल माय वर्क। एंड मैं अभी आयुर्वेद की बात करूँ, मेरा कोलैबोरेशन आयुर्वेदिक है। हम जो एडजंक्ट प्रोफेसर आयुर्वेदिक दत्ता मेघे कॉलेज वर्धा। तो वहाँ के जो डॉक्टर ने मुझे बुलाया था, मैंने पेटेंट पे टॉक दिया, मैंने उस पर पेपर राइटिंग पे टॉक दिया। तो एक दिन उनका फोन आया, सर एक पेशेंट आया और आपकी मदद चाहिए। मैं सर मैं फिजिक्स वाला हूँ, मैं तुम्हारा आयुर्वेद का किसने बोला, हमारे पंच L1 L3 यहाँ पे जो रहती है उसको कुछ तो भी उसमें प्रॉब्लम है ना, पीठ के दर्द के लिए सिंगल हैंडेड कैसे बनाओ। तो भी हमने हिम्मत नहीं हार पाते और हमने तो उसके लिए हमने एक बनाया था जिसको हम अरे यार हाँ, ये पेटेंट आपका अभी इसमें एक्सेप्ट हो गया है, अभी ग्रांट आने का। और ये इसमें 2 डॉक्टर हैं और मैं तीसरा। और एक दूसरा जो इस पीठ दर्द के लिए कट्टी बस्ती बोलते हैं, उसके लिए मैंने बनाया, इसका डिजाइन मेरा है और इसको मैंने बनाया जस्ट लाइक दिस। ये सिंगल हैंडेड है सर, एक आदमी इसको ऑपरेट कर सकता है, इट इज नॉट रिक्वायर्ड एनी अदर पर्सन। और इसमें भी मैंने पेटेंट लिया और साउथ अफ्रीकन पेटेंट लिया उसको डिजाइन के ऊपर विद दिस इज द डॉक्टर। तो हम आयुर्वेदिक डॉक्टर के साथ भी काम करें। थर्ड पेटेंट लिया हृदय बस्ती के लिए, हृदय बस्ती के लिए भी मैंने ये डिवाइस बनाया और दिस डिवाइस आल्सो पेटेंटाइज विद दिस मैडम, या आयुर्वेदिक डिपार्टमेंट के हेड ऑफ डिपार्टमेंट। तो ऐसा चलता रहता है। फिर मैंने उन्होंने बोला कि एक सुना आप ही ले लो, कोगाइड बन जाओ। तो मैंने उसके साथ मैं मायना बस्ती काम कर रहा हूँ और पेटेंट अंडर प्रोसेस है, इसलिए मैं उसका डिजाइन नहीं बताया। दूसरा आपका हनु बस्ती का भी पेटेंट अंडर प्रोसेस है और तीसरा पेटेंट इसका वर्णा बस्ती का भी पेटेंट है और ये पेटेंट बनाया मैंने अंडर प्रोसेस है इन तीनों लोगों के साथ में। और ये जो पर्सन है ये वेद प्रकाश मिश्रा साहब का बेटा है, इट इज द प्रो वाइस चांसलर ऑफ द आयुर्वेदिक डिपार्टमेंट, नाउ प्रेजेंट इज माय कोलैबोरेटर। तो इसके साथ रेडियोलॉजी पे भी काम करता हूँ और ये वाला भी काम। तब मैंने देखा कि अलग अलग टाइप के ये डिवाइस बनाया, ये मैंने अमरावती से बनाया कि नागपुर में सभी डिवाइस वाले बिजली थे और इसमें यूवीसी लाइट लगाया 360 डिग्री से और 5 मिनट के लिए उसको क्लोज कर दिया। तो कोरोना वायरस यूवीसी में 30 सेकंड में मर जाता है। तो मैंने डेड बॉडी थी उसको सरफेस पे, तो उसको वायरस यूवीसी में 30 सेकंड में मर जाता है। तो मैंने डेड बॉडी थी उसको सरफेस पे, तो उसको 5 मिनट को कवर किया। लेकिन जब भी आप सोशल इम्पैक्ट का कुछ काम करते हैं, ऑल दिस आर कवर। So I am working this one. Today my paper is the 998 on the Scopus. 2 पेपर कम है 1000 के लिए। विराट कोहली के जैसे 14,000 रन बन गया तो मेरे भी 1000 रन पेपर 8 दिन के अंदर बन जाएंगे और मैं आपको सब सोशल मीडिया पे भेजूंगा। एच इंडेक्स इज 49 एंड साइटेशन द 14,857। गूगल स्कॉलर में मेरे 57 एच इंडेक्स है, 18,067 इज द साइटेशन है, 475 I10 इंडेक्स है। तो 2 पेपर रिक्वायर्ड फॉर द 1000 रिसर्च। This is the first person in the Nagpur University in the 100 year published more than 1000 paper on the Scopus. अभी हुए नहीं है। 48 पे 2 अलग अलग इम्पैक्ट फैक्टर में आपको पेपर दिए हैं, मैंने आपको कुछ बताया भी। 3 में 138, 2 में 254 डिफरेंट वन एंड जस्ट डायरेक्टली स्क्रीनशॉट ऑफ द स्कोपस का लिया है मैंने। और इसमें 2022 में जब कोरोना चल रहा था, एक ही साल में मेरे 101 पेपर पब्लिश किए थे। एक कोरोना के टाइम में जब लोग सब आराम करते थे, मैं और मेरा ग्रुप काम करता था, रात दिन काम। 101 पेपर मैंने पब्लिश किए थे और 2025 में 13 पेपर आज तक के 2 महीने में हो चुके। तो दिस इज द स्कोपस डेटा, जस्ट यू कैन सी एंड दिस इज द 992 पेपर आर रिक्वायर्ड। तो इसमें से आप हर साल देखिए 50 पेपर के ऊपर में 2022 में 101 पेपर है लाइक दिस वन, और 2025 में 13 पेपर हो चुके हैं। तो दिस इज तो एक ही सत्र में स्कोपस पर 100 पेपर पब्लिश, और दोनों में अच्छे पेपर मिले। उससे क्या इफेक्ट होता है, मेरे लैब पे ब्रांड नेम लग गया। बोले ढोबले सर अगर 100 पेपर एक साल में पब्लिश करते हैं, स्टूडेंट 3-4 तो पेपर करेंगे। इंजीनियरिंग कॉलेज को पेपर की बहुत जरूरत रहती है, साइंस वाले कर लेते हैं, इंजीनियरिंग कॉलेज में मुश्किल रहता है, एनआरएफ रैंकिंग और नैक के लिए। तो मेरा कोई भी स्टूडेंट खाली नहीं है। जब इंटरव्यू आता है तो बोलते हैं सर एक दो स्टूडेंट तो भेज दो, हम वैसे भी आपको स्टूडेंट को जाते थे। तो दिस इज द गुडनेस फॉर माई लेबोरेटरी। So all students are very engaged. So this is the very good point. And then after that you can see the Google Scholar में ये है, और this is the 18,000 इस क्रॉस कर ले साइटेशन को। और जब एक मटेरियल साइंस ने 21 दिसंबर 2022 को ये डाटा पब्लिश किया, तो फर्स्ट पोजीशन पे सीएनआर राव जो भारत रत्न है, सेकंड में साबू थॉमस है जो वाइस चांसलर है महात्मा गांधी यूनिवर्सिटी के थे, अभी XYZ है वाइस चांसलर है, और आई एम ऑन द थर्ड पोजीशन। पर ये दोनों अगर साउथ इंडिया के हैं तो मैं महाराष्ट्र में अकेला हूँ, आई एम टॉप पोजीशन इन द महाराष्ट्र इन द पेपर पब्लिकेशन। तो दिस इज द वेरी गुड थिंग, जस्ट दिस इज द सीएनआर राव, दिस साबू थॉमस एंड माई सेल्फ। तो ये मुझे और मैं टॉप 2% साइंटिस्ट हूँ 20, 21, 22, 23, 24, और मे बी 25 बाय स्टैनफोर्ड यूनिवर्सिटी। So just you can see, this is the top 2% news, all this one. And now I am now with the 0.05% scientist by scholar GPS, 0.5%. So यहाँ पे scholar GPS is the 0.05%. And just you can see here is the in the range of the FASPER में 17 लोगों के नाम है, 17 people in the FASPER. I am in the 5th position and I am only one Indian in this list. On this passport in the scholar GPS. So this is the very interesting, just you can see on the passport 0.01%. So this data is important, and all this news on this one. So this is the very helpful for my university, like this one. So now again I'll see some of the important India Faculty Top Research Award में भी मुझे मिला, Best Research by Nagpur University, और LED फास्फर, TLD फास्फर, या मेरे तीनों टॉप स्कोर है, और ये स्कोपस में आप चेक करेंगे तो टॉप पोजीशन इन द वर्ल्ड। इसमें LED फास्फर में और TLD फास्फर और फास्फर तीनों में टॉप पोजीशन है यहाँ पे, आप चेक करिए। सक्सेस स्टोरी ऑफ द माय स्टूडेंट रिसर्च, तभी मैंने आपको बताया, जैसे वन ऑफ माय स्टूडेंट इज द यातिश, इज द पब्लिश द 35 पेपर इन द PhD, और उससे 7 पेटेंट है, 7 चैप्टर है। इसके डायरेक्टली भी 65 पेमेंट था रामदेव बाबा में, एक साल में उसके 13 पेपर मैंने पब्लिश किए, आज उसका 85,000 रुपये पेमेंट हो गया। तो हमें किसको पैसे देने की जरूरत नहीं, हम अगर पेपर अच्छे पब्लिश करते हैं तो प्राइवेट यूनिवर्सिटी वाले अच्छे से जॉब दे देते हैं, और पेमेंट इज आल्सो वेरी इक्वलेंट गुड। और उसने इतना अच्छा काम किया कि JSP होप ने उसको मीटिंग के लिए बुलाया, जिस LED के नोबेल प्राइज को मैं नहीं मिल पाया, मेरा स्टूडेंट मिल पाया। 5 नोबेल प्राइज विनर्स के साथ मिल गया है जापान से। तो दिस इज द वेरी गुड सक्सेस स्टोरी। दिस इज अभिजीत कदम, जब भी मैंने इसका नाम लिया, नंबर ऑफ पेपर पब्लिश 43, और इज नाउ इज द पेमेंट इज 82,000 इन द वन ऑफ द इंजीनियरिंग कॉलेज इन द औरंगाबाद, और इसके भी 10 बुक्स चैप्टर है और 10 पेटेंट है। So all my PhD students also get the patent is felicitated by the Vice Chancellor. This is my research collaborator for the foreign and Indian. All this my international collaborator, मैं इसका डेली कांटेक्ट में रहता हूँ, ऐसा कोई दिन नहीं रहता मैं इनसे कांटेक्ट में नहीं रहता। कुछ डिस्कस करना, कुछ डाटा भेजना, कुछ डाटा डिस्कस शेयर करना, और कभी भी हमारे स्टूडेंट को बेनिफिट करते हैं, मेरे साथ में रहते हैं। So now 16 students selected for the postdoctor at PDF for the research in abroad. And this Karan Kumar Gupta, Taiwan में 1,80,000 rupees per month salary है, is also one of my students. जब भी मैंने भूषण कोरे के बारे में और गोविंद नायर के बताया, both are also now presently in the Germany and in the South Africa. So now total patent is 100. मेरे कल 100 पेपर हुआ, 100 ऑफ पेटेंट सबमिट करके आया हूँ, और ग्रांटेड 57 है, पब्लिश 22 और फाइल 21 है। और इसमें से लास्ट ईयर एक पेटेंट फेट हुआ था, और उसमें मेरा विदर्भ में सबसे ज़्यादा पेटेंट थे। तो देवेंद्र फडणवीस जो उप मुख्यमंत्री थे, उन्होंने मेरा फेलिसिटेशन सुरेश भट्ट सभागृह में किया, तब उन्होंने मुझे दिया, और जो ये उनके ऑफिस की न्यूज़ है, मेरी न्यूज़ नहीं है। तो उन्होंने अपने भाषण में कहा कि विदर्भ में अभी भी गुणवत्ता है, इसलिए ढोबले सर के विदर्भ में सबसे ज़्यादा पेटेंट है, ये उसने अपने भाषण में बोला। तो सुरेश भट्ट सभागृह में मेरी मिसेज बैठी हुई थी, और उसने सोचा की इतने बड़े आदमी से, देवा भाऊ के मुंह से अगर मेरा नाम निकला अच्छे से, त्या दिवसपासून माझ्या बायकोने मला कधी रागावलं नाही, आणि कधी काम सांगत नाही, आणि काम सांगितलं तरी मी करत नाही, काहीच फरक पडत नाही। आता मला एक अवॉर्ड मिळाला, त्यामुळे VC सरांनी माझी भरभरून तारीफ केली तिच्यासमोर। तर छान वाटतं. Like this one. All my research students is get the patent with the vice chancellor sir. Other student with the Bokhari sir also. तो डिफरेंट टाइम में अलग अलग पेटेंट, एक 3 महीने में 17 पेटेंट ग्रांड हुए थे. 3 महीने में 17 पेटेंट. All this my students. So our MSc student also are get the benefit. मेरे MSc student भी पेटेंट निकाल रहे हैं. Just you can see ये आपके स्टूडेंट है जो अभी मैंने येलो लाइट वाला बताया था, इन्होंने तीनों ने उसको इन्वेस्टिगेट किया. ये सभी MSc 4th सेम के स्टूडेंट हैं. ये MSc 4th की स्टूडेंट MSc हो चुकी है और MSc सेम 2 की स्टूडेंट है. इसका भी एक पेटेंट फाइल है, ये भी ग्रांट हो चुका है. मैंने यहाँ पे करेक्शन अपडेट करना भूल गया उसको. Now these 2 students also MSc it is also grant that. तो MSc के स्टूडेंट भी पेटेंट निकालते हैं. ऐसा नहीं कि टीचर ही पेटेंट निकालते हैं. तो जो नए यंग टीचर है वो भी आप पेटेंट निकाल सकते हो. एंड दिस इज द ऑल दिस स्टूडेंट आल्सो गेट द पेटेंटाइज. तो दिस इज वेरी इंटरेस्टिंग. ये आपकी मर्सिना MSc सेम 4-2 में इसके भी अभी पेटेंट हुआ है और उसने अभी एक पोस्टर प्रेजेंटेशन किया था नेशनल कॉन्फ्रेंस में नागपुर में. सो शी गेट द फर्स्ट प्राइज. मैं इसलिए बोल रहा था कि यहाँ पे जो भी MSc वाले या नए बैठे हुए थोड़ी एनर्जी आए. तो फर्स्ट प्राइज मिला उसको और उसने अभी हमने ये चालता वाहनातून होणारी स्वच्छ विजेती टायर के अंदर में एक मटेरियल डाला, पीजो इलेक्ट्रिक मटेरियल, और उसमें एनर्जी जनरेट की. तो दिस न्यूज़ इज पेटेंट भी मिला और बहुत पेपर में अच्छा. किसी बच्ची का अगर अपने पेपर में फोटा तो माँ बाप को कितना अच्छा लगता है आप अंदाज करके देखिए. तो ये सब पुण्य मुझे मिलता है, उनके चेहरे की रोशनी मुझे मिलती है, उसकी जो खुशियाँ मुझे मिलती है. सो दिस इज वेरी इंटरेस्टिंग. नाउ नेक्स्ट वन इज दिस इज आदित्य डी देशमुख. इसने भी हेलमेट वाला पेटेंट बनाया. जब मैंने न्यूज़ देखा कि 2 व्हीलर के लिए दोनों पर्सन के लिए हेलमेट कंपलसरी किया, दोनों के लिए, तो एक हेलमेट तो डिक्की में रखने के लिए जगह, दूसरा हेलमेट कहाँ रखेंगे? इट इज़ नॉट एनी स्कोप. तब मैंने सोचा और मैंने इसको बुलाया. ये पेटेंट करने में इंटरेस्ट थी, तो ओपन करके इसको फोल्डिंग हेलमेट बनाते. तो मैंने ये डिज़ाइन बनाया और इस डिज़ाइन को मुझे इंटरनेशनल पेटेंट मिला और ये अभी हमारा प्रोग्रेस में चल रहा है. तो ऑल दिस पेटेंट आर पॉसिबल विद द MSc स्टूडेंट. और जब भी मुझे अच्छी आइडिया आती है तो मैं अपने MSc स्टूडेंट और रिसर्च स्कॉलर के साथ में इकट्ठे, इन तीनों का ये वाला है. दिस इज वेरी इंटरेस्टिंग वर्क एंड ऑल दिस अदर में ये मेरे विजिटर सर ने बता दिया तो मैं इसको ज़्यादा एक्सपोज नहीं करूँगा. PhD अवार्ड 38 है, 31 बुक्स है मेरी. ये वाली इंटरनेशनल बुक है, सभी एल्जेब्रा स्प्रिंगर की बुक्स है. लाइक दिस वन. बस 2 मिनट. एक मैंने NEP में एक मराठी बुक निकाली थी बच्चों के लिए. इसमें बच्चों के लिए साइंस में स्टोरी लिखी थी. उसको मुझे महाराष्ट्र का फर्स्ट प्राइज मिला था, कुमार साहित्य का अवार्ड, और वो नागपुर में. तो दिस इज वेरी इंटरेस्टिंग. उसी के बेस पे हमने आगे बढ़ते हुए सेकंड बुक अभी निकाला. ये भारतीय वारसास्थ विज्ञानाचा चष्मा. तो ये सेकंड बुक अभी आ रहा है, उसका कवर कल आया मुझे. अभी 2-4 दिन में बुक भी मिल जाएगा. तो थैंक यू. ऑल दिस माय डिफरेंट केसेस. आई एम वर्किंग विद डिफरेंट सब्जेक्ट. इसमें मैंने आयुर्वेदिक, हिस्ट्री, पॉलिटिकल, सोशोलॉजी, आयुर्वेदिक, इकोनॉमिक, मैनेजमेंट, सभी सब्जेक्ट के साथ में मैं काम करता हूँ और तभी हर सब्जेक्ट के साथ मेरा आउटपुट भी है. तो बहुत अच्छा लगता है. हम अच्छा काम करते रहेंगे और स्टूडेंट हमारे साथ है. तो जस्ट इस क्लोज ना हो. ये हमारे साइंस जर्नल आ रहे हैं, जिसको भी पेपर अपना पीयर रूम में भेजना है तो हमारे मेरे ईमेल पे भेज सकते हैं. विदाउट एनी चार्ज आई विल पब्लिश योर पेपर ऑन द पीयर रूम. ये नागपुर यूनिवर्सिटी का साइंस जर्नल है. और मुझे अभी डॉक्टर धर्मेंद्र गांधी समाज शिक्षक पुरस्कार मिला था, जिसमें 1 लाख रुपये मिले मुझे. ये 1 लाख रुपये का चेक है. तो ये बहुत बड़ी सफलता है. वो अपने वाइस चांसलर के हाथ से मिला और पुलिस कमिश्नर के हाथ, धर्मेंद्र गांधी अवार्ड से. तो ऐसे कुछ अचीवमेंट मिलते रहे तो हमारा ग्रुप पूरा एनर्जेटिक हो जाता है. हम रात दिन काम करने के लिए तत्पर रहते हैं. और डेफिनेटली आई एम ऑलवेज वाइस चांसलर इन माई रूम. ये मेरे रूम में वाइस चांसलर आए कई बार है. माई लैब इज ओपन फॉर कोलैबोरेशन एंड रिसर्च लेबोरेटरी इज टेम्पल एंड माई रिसर्च इज प्रूफ. So this is my research group. Thanks to my research student and my collaborator. But anybody interested, so you can contact me. This is my email ID and this is the.
Big hands for Dr. Sanjay Dhobde sir. आवाजात दम पाहिजे. सरांची एक अजून सांगितलं, सरांनी एक लपून ठेवलेला आहे. सर खूप छान चित्रकार आहे आणि बसल्या बसल्या स्केच काढतात. माझा स्वतःचा अनुभव आहे, माझा स्वतःचा हे आहे. की मलेशियाला आम्ही सोबत बसलो होतो, सर माझ्या मागे बसले होते, सरांनी माझं केच केव्हा काढलं, माझ्या कागद समोर देऊन दिला. बसल्या विधीने 10 मिनिट्स. इतकं सुंदर. आता सरांनी हे सगळं सांगितलं, काय आपण कोर्स करायचं. मला असं वाटतं की समुद्राचा महाकुंभ झाला ना, आता हा एक फिजिक्सचा महाकुंभ आहे. फॉस्फरस फॉस्फरसचा महाकुंभ आहे. Any queries regarding luminescence, phosphorus? No query.
Thank you, sir. As we come to the conclusion of this session, I would like to extend my heartfelt gratitude to our session chairperson, Dr. Ajay Lad sir, for his valuable time, guidance, and insight. And special thanks to Professor Sanjay Dhobre sir for sharing his expertise with us today. Your contribution to the field of phosphorus and its versatile journey, LED technology, solar cell efficiency, nanoparticle for cancer therapy are truly inspiring. I also thanks to all the participants for their active engagement throughout provoking through their questions. With that, we formally conclude technical session 4. We hope to continue with the enriching discussion in the future also. Thank you. Thank you, sir.
Hello. A very good afternoon to all. I welcome all the delegates and participants in this paper presentation session of this international conference on emerging trends in physical sciences. We are elated to have Honorable Dr. Vivek Kapse, Professor,
Department of Physics, Arts, Science and Commerce College, Chikaldhara, Amravati, and Honorable Professor Dr. Piyush Dhalke, Assistant Professor, Shri Santa Gajanan Maharaj, College of Engineering, Shegaon, as the jury members. I would like to take this opportunity to introduce our jury members. Honorable Dr. Kapse sir has an extensive teaching experience of over 26 years and 22 years of research experience. Sir has published 47 research papers and 3 published books. He has delivered many talks on various subjects. Under his guidance, 3 students have been awarded PhD and 3 students are still pursuing. He is the recipient of Senior Scientist Award from the Board of Editors of Bio Nano Frontiers and Best Paper Award at state level seminar. I request Dr. Devde sir to kindly welcome Honorable Dr. Kapse sir. Thank you, sir. Moving forward towards our second jury member, Honorable Dr. Piyush Dhalke sir is an assistant professor at Shri Santa Gajanan Maharaj College of Engineering, Shegaon. Sir has published 10 research papers in various national and international journals and has 7 books published in his name. I request Honorable Dr. Devde sir to kindly welcome Dr. Dhalke sir. Thank you, sir. And now hereby, I give the mic to the 2 jury members. I hand over the session to both the jury members.
Okay, good afternoon to everyone. So without wasting much time, we'll start today's session. First, may I call to the Mr. Praful Hode. Here. So we have only 5 minutes presentation and 5 minutes for question answering. So be fast. Praful Khode. And the next candidate is R.S. Nikam. Where? R.S. Nikam, where? So be ready. Fast. Pen drive launch. So next third candidate is Atharva Bosre. So be ready. Huh?
Good afternoon, everyone. My name is Praful Khode. I am doing PhD under Dr. S.J. Doble, Department of Physics. My today's topic is tunable phosphor in La2O3 dy SMER phosphor prepared by co-precipitation using ammonia. Next. In this, we are going to first see introduction, XRD, PL study of code of phosphor, and conclusion. Next. In the introduction, we have to select for the LED material phosphor, we have to mainly select host material, dopant, and the synthesis method. All properties are depend on these 3. I select the host La2O3 because it is stable and it is cheaper as per industrial use material Y2O3. We have selected 3 dopant ER. This is mainly used for up conversion, but in this case, we are using for down conversion by using our methods. And next method is we are using co-precipitation. Co-precipitation is a cost-effective method, and we use precipitating agent as NOH. We have taken the XRD pattern of all the single dope and co-dope phosphor. As we seen, as the dopant ER dy SM dope in the La2O3 shifting toward the small angle. This is due to expansion. Because we dopant the SM dy ER, the ionic radii of these 3 samples are more than LA. Therefore, the shifting is toward the lower angle. As we see the co-dope, there is a saturation is to happen. There is a shifting toward right, but left to the as a standard data. Next. It is a PL study of dy 3 plus phosphor. We have taken the excitation factor at emission level 575 nanometer. We got 2 peaks. We have studied the emission spectra at 353 nanometer because it is useful for the LED application. In emission spectra, we have got 2 peaks that is shown in the figure, and the emission is found in the region in the white region. Then we dope the SM for the orange red phosphor. In that we have got the maximum two peaks. We have measured the emission factor at 410 nanometer because it is in visible range and it is useful for the LED. We have got three peaks in orange and two in red and one in far red. Then we have seen the concentration quenching. Then we have take the CR diagram for the emission color and we have found the emission in the orange red region. Then we have doped the ER. Basically, ER is the up conversion material, but by using our method, we are trying to get in down conversion. Yeah, we get the ER3 but emission in green, intense, with three peaks. As we see the CI diagram, the emission is in green region and the coordinate are shown in the figure. And this is the concentration quenching graph that shows the concentration quenching. Next. This is the code of the DYSM. First graph is the overlap graph, in which we have get the excitation overlap at the 366 nanometer. We studied the emission spectra at 366 nanometer. We have seen the intensity of DY is increasing continuously and the intensity of SM is increasing. And the CI coordinate shows the emission in this region. Then we have studied the code of phosphor of ER and SF. In that we are keeping the ER constant, and we also take the overlap graph. We get the maximum intensity excitation overlap at 666 nanometer. We have studied the emission spectra. Also, we have studied that the energy transfer is happen as the ER intensity is decreasing, and SM increasing. SM intensity increasing as the increasing the dopant. As the using ER is the green emitting and the SM in red region, we have conclude that by combining two phosphor we get the emission in middle of the green and red region. Next, then we code off with the DR, DY and ER. We get the overlap graph here.
Come with the conclusion. Be fast.
And we are at overlap graph. We have take a emission graph and we have get this energy transfer phenomena, and this is the CR diagram. Next. In conclusion, we have successfully confirmed the formation of L2O3 by comparing our XRD data with the standard data, and we have the dope the DY, ER, SM for the different, DY for the white, ER for the green, and SM for the orange red, and their code of phosphor for the color tonality. And this phosphor can be used for the solid state lighting, LED displays, and fingerprint. This is my some references, and thank you.
Question answer. So audience, if you have any doubts or questions, you can feel free to ask. So next, be fast. So next, Atharva Bochre and Nikam. Okay.
Good afternoon, everyone. Okay, I am Rahul Sabas, professor at and I'm
The next.
I'm going to Tapinox.
carboxyl. Hammers method, that modified Hammers method. Characterize the peak from 002 001 plane, lower angle. The interplanar space is location density. Graphite. Yes,
Hello, hello.
as Schottky diode, I need FTO. On that FTO, I have drop cast graphene oxide. On that, by thermal evaporation technique, I have used silver material for the electrode. And after doing the measurement of IV characteristics, there is a IV characteristics of current versus voltage and logarithmic curve. It is similar to the PN junction diode. From this IV characterization, some parameter have been found out like static resistance, dynamic resistance, and ideality factor. And swing method, from that we can also find out the series resistance. Now our diode has been, the ideality factor of our diode is 2.365, and in general the ideal diode, which is PN junction diode, if we consider the ideal diode, the ideality factor of ideal diode is 1, and our ideality factor is 2.365.
Okay. So what is your problem statement you are to addressing here? So which material you have identified? Why not alternative? Yeah, previously somebody has to elaborate.
Hello.
Material. So why you have chosen this particular material?
Because previously they have synthesized graphene oxide, but I am going to show that material application in diode, optoelectronics material also.
Okay. So thank you so much. So next, Atharva Bochre, please be fast. After the Atharva Bochre, please ready the Pranoti, madam.
Hello. Good afternoon, respected sir. Myself, Atharva Butran. I am from Sri Sant Gajanan Maharaj College of Engineering. I am at first year at Mechanical Department. And my topic is study and design concentrated solar thermal power plant. Actually, my abstract is that like we are using solar power thermal plants. Instead of that, otherwise we are using a coal thermal power plant, and due to that we are getting so much pollution diseases like lungs diseases, asthma and all. That is not good for our human being health and all. Basically, my introduction to concentrated solar power plants harmless that sun energy to generate electricity. That I have some key objectives that thermal power plant at mirrors lenses were used to get solar energy and converted into rectifiers and all that gets sun energy. Next slide. Introduction about my power plant is that CPS plants where mirrors or lenses are uses for sunlight into transforms to heat and uses into rectifier, and that is uh, like chemists having one of the salt which is used to sustainable energy like solar energy and all. The component like SAM software assessment management, the component like SAM software assessment management, SR DB National Solar Radiation. Through I have taken the data analysis and all. The system modeling is collector receivers, a power block and storage where the thermal power plant is useful for. And the parabolic dish system, those focus sunlight into a single point receiver that gates receiver and form good form of electric source and all. The costing of it is so basically low because thermal power plants cost so much types of coal, and it is not good for our human beings health and all. Conclusion of my topic is for basically we are using in this topic like mirrors, taking examples of basic way 16 square meter having dish, and in 16 square meter dish we can take 380 mirrors. Having 380 mirrors can get 120 sun energy at a time. That is so huge amount of sun energy we can get from this scenario. And having a receiver point 550 degrees Celsius to 650 degrees sun energy at one point. And we can generate 3,500 kg steam at one time due to 16 square meter dishes.
Questions? Very nice presentation. Next one, Pranoti.
Thank you so much, sir.
Bhavani. Pranoti Bhavani.
So next candidate Ajinkya Zogle. So be ready after that. Huh?
Good evening, everyone. My name is Ms. Pranoti Ravindra Khawne. My topic is determination of LD50 value for red laser, green laser, UVA, UVB, and UVC radiations for glycine max, brassica nigra, and study its effects on study germination. Next. Coming to abstract, the present study was conducted to determine the dose of the red laser, green laser, UVA, UVB, and UVC radiations at which the lethality of the seeds should be 50%. So for this purpose, the glycine max of variety AMS 139 Amba and brassica nigra of variety TAM 108 both were brought from Dr. Panjabrao Deshmukh Krishi Vidyapit. Those were irradiated with the laser radiations and UV radiations at different time interval, and they were treated with and the treated and untreated seeds were kept for germination in 2 replicates, and then accordingly the LT50 values were determined. So for fulfilling the demand of the ever increasing population, there are various techniques are used, and out of them use of pesticides and fertilizers is abundant, which causes the ecological imbalance. So there is a need for development of new techniques. So as far as the report says, there are 9 major oilseed crops in India, out of which soybean and mustard, they are major, having their area under cultivation as 42% and 24% respectively, and their total contribution in the oil production is 34% and 29% respectively. So the main objective of this study is determining the effect of pre-sowing laser UVA, UVB and UVC radiation treatment in glycine max and brassica nigra and determination of their LD50 value. So what is LD50 value? It is the amount of radiation which is given to the seedlings which cause the death of the 50% of the seedlings. So for the promotion of the oilseed, also Union also has launched an scheme which is called as the National Mission on Edible Oils for the promotion of the oilseed production. Next. So here are the materials and methods. Uniform sets of glycine max and brassica nigra of chosen variety were chosen, and they are treated with red laser of 632 nanometer wavelength and green laser with 532 nanometer wavelength, and with for irradiation time from 10 minutes to 60 minutes. Then they are given UVA radiations of 395 nanometer wavelength, and irradiation treatment was given from 10 minutes to 120 minutes. They are treated with UVB radiation of 297 nanometer wavelength from 10 minutes to 90 minutes, and UVC radiation that is of 280 nanometer wavelength, and treatment was given for 5 minutes, 8 minutes and 10 minutes, and then the germination percentage was calculated and accordingly LD50 value is determined. Next. So here are the graphs. First two graphs, first and second graph shows red laser and green laser treatment in soybean. Third and fourth graph shows red laser and green laser treatment in brassica nigra, that is mustard. 5, 6, 7th graph shows UVA, UVB and UVC radiation treatment to glycine max, that is soybean, and 8, 9, 10 shows UVA, UVB and UVC treatment for the brassica nigra. Next. So germination is the seed viability, which is greatly affected by the radiation dose, affected by the radiation as the dose of the radiation increases. So from the figure, it is seen that the seed germination percentage is found to decrease with increase in the exposure time. So this result is very well in agreement with the result that the higher irradiation reduces the seed germination, and the result shows the pre-sowing irradiation treatment shows positive effects on the glycine max and brassica nigra, and UV radiation shows higher UV radiation shows negative treatment in seed germination. So accordingly, the LD50 values for all the wavelengths are tabulated. Next. So conclusion, laser and UV radiation plays an important role in biostimulation at lower irradiation time. So determination of LD50 value, that is the irradiation treatment or irradiation time at which the survivability of seed is 50% is necessary to calculate to give the proper treatment for or to select the proper time radiation treatment for glycine max and brassica nigra. So next, here are the references. Thank you.
Good afternoon, everyone. Yes, very good afternoon, everyone. My name is Ajinkya Jogle. I am a research fellow at Mukesh Patel School of Technology and Engineering in Mumbai. My topic name is Experimental and DFT Study of Plant-Based ZNO-NIO Nanocomposites for Structural and Electrical Properties. As name suggests, my research is based on experimental and computational field. This work was conducted under the guidance of Dr. Aarti Hadap, my guide, and Dr. Vishal Panse. Please next. Now, we know that conventional synthesis techniques, including physical techniques, are costly and energy intensive. We know that physical synthesis methods require high temperature and low pressure setup. Chemical methods are environmental unfriendly, which generates toxic byproducts. So there is a need to synthesize nanomaterials by using green methods. Please next. So problem statement is clear. We have to synthesize nanomaterials by using green method, and also there is a gap in computational validation which supports experimental findings. So our objectives are simple: to synthesize ZNO-NIO nanocomposites using green solotherm method, and to analyze structural and electrical properties by using characterization techniques like XRD and UV, And third one is to evaluate potential applications of ZNO and NIO nanocomposites. Please next. Now we have used green solvothermo method. So in this method we have taken aloe vera pulp by using aloe vera leaves. So 40 ml aloe vera extract mixed with 2 millimole ZNO and 2 millimole nickel nitride. Then after 1 hour stirring by using magnetic stirrer, then this solution is transferred to stainless steel autoclave. Then then at 140 degrees Celsius for 12 hours, then followed by annealing at 450 degrees Celsius. Then we will get nanocomposite in powder form. Please next. Now structure characterization studied by using XRD. So XRD confirms hexagonal root side structure, average size of 13.91 nanometer, and lattice parameter as shown in slide. Next, please. Computational approaches. So we have used DFT, which is based on first principle, and we have employ GGA, PB, exchange correlational function to do DFT calculations. So lattice parameters are as shown in this slide. So there is a small corrections. Slight variations in the lattice parameter due to defects. Next, please. Now electrical properties was studied by UV visible spectroscopy. So energy band gap was found to be 2.52 electron volt by using Tox plots. We know that ZNO nanomaterial energy band gap for ZNO is 3.37 electron volt, and for NIO is approximately 3.5 to 4 electron volts. So when we mix two, then yes, please. Now here we to conclude, we have successfully synthesized ZNO and nano composites. Structure and optical properties have been studied, and applications also discussed, and future perspective. Thank you. Yes, any question?
Okay. Okay, thank you so much. So Mr. Rajat Sauji.
At outset, very good afternoon to. At the outset, very good afternoon to one and all. I am Rajat Vijay Sauji, a scholar from Department of Chemistry, Shankarlal Khandelwal College, Akola. My topic of presentation is synthesis of derivatives of curcumin and eugenol. My PhD guide is Dr. B.S. Pandesa, Professor and Head, Department of Chemistry, College, Akola. Next slide. The content of today's presentation. Next slide. So in India, from 5,000 years ago, Ayurveda is used for the treatment of many diseases. Herbal-based medicines are used from many years for prevention and protection from many diseases. In that medicinal plant, some active ingredient is present. We take two medicinal plant, that is turmeric and clove, and we take the two active ingredient present in each of this. From turmeric we take curcumin, and from clove we take a eugenol as an active ingredient, and we synthesize some derivatives from this active ingredient. Next slide, please. So this is the first active ingredient, curcumin. We isolated from the turmeric. The curcumin is a polyphenolic compound with a symmetric structure, contains two phenolic group, and the second one is the eugenol. Eugenol we extracted from the clove. It is a phenolic compound containing phenolic group. Next slide, please. So next is the extraction process of curcumin and eugenol. We extracted curcumin and eugenol by using Soxhlet extraction. The Soxhlet extraction method is a more yielding method for the extraction of this curcumin and eugenol, we extracted curcumin and eugenol, and then it is characterized by GCMS and other spectral analysis. Next slide, please. This is the synthesis of derivatives of curcumin. So for a synthesis of derivatives of curcumin, all AR grade chemical were used. Derivative of curcumin were synthesized in their body in presence of different reaction conditions. First, in the first reaction, we use a phenylhydrazine and pyrazole of a curcumin is formed. The melting point found to be 220 degrees Celsius. We confirm it by a spectral analysis, which we see later. Next slide, please. These are other derivatives which we form of curcumin. In the first reaction, we form the dimethyl curcumin. In second reaction, we form diacetyl curcumin in presence of glacial acetic acid. In third reaction, we form a derivative of curcumin in presence of benzoyl chloride, and benzoylated curcumin is formed. Next slide. Next is the eugenol. So for eugenol, we done a 3 reaction. In first reaction, acetylation of eugenol takes place in presence of base. In second reaction, the methylation of eugenol takes place. And in third reaction, benzylation of eugenol takes place. Here, the OH group is replaced by in first reaction, the OH group is replaced by acetyl group, and acetyl eugenol is formed. In second reaction, OH group is replaced by the acidoxy group, and acidoxy eugenol is formed. In third reaction, benzylation takes place. Next slide, please. These are the spectral characterization as we synthesize the different derivatives of curcumin and eugenol. For curcumin, that is for 2A, we characterize by the IR, and for H1, for eugenol derivative, we confirm it by H1 NMR and IR spectroscopy. We confirm all the derivative by this spectral analysis. Next. Resultant discussion, we successfully synthesized the derivatives of curcumin and eugenol. These derivatives of curcumin and eugenol were synthesized in different chemical reactions. These derivatives will have a prominent biological activity which will be studied later. Okay, thank you very much. These are the references of today's reference. Okay, thank you.
Swapna Rajankar.
Very good afternoon to all. Myself, Ms. Swapna Rajankar. I am from GS College, Khamgaon, and a research scholar student of Dr. S.P. Hargunani, sir. Today's my research paper title is Synthesis and Luminescence Characteristics of TB Dry Positive Activated KBA4BO3 by 3 Phosphor. Phosphor doped with rare earth ions and transition metal ions have attracted more attention due to their variety of applications in field of solid state lighting and medical science. The number of compounds including silicates, aluminates, phosphates and borates, among them borates have attracted much attention due to their excellent thermal stability and potential low cost synthesis. Next slide. Methodology that I have used for the preparation of the phosphor is solution combustion synthesis method. In that method, the starting materials that I have used for the preparation of the phosphor are potassium nitrate, barium nitrate, terbium sulfate, boric acid and urea. The chemical reaction is shown in there, that is KNO3 plus 4 into 1 minus X BaNO3 by 2 X TbNO3 by 3 plus 3H3BO3 plus CONH2 by 2. It results in the formation of potassium barium borate doped with TB tripositive ion. The XRD pattern of the KBA4BO3 by 3 TB tripositive dope phosphor is shown in there, which matches with the XRD pattern of KCA4BO3 by 3 and with JCPDS. Next. Photoluminescence study of TB tripositive phosphor shows green emission under UV excitation. Under 352 nanometer excitation, it shows 4 emission peaks. Out of that, first emission peak is observed at 492 nanometer wavelength. which associated with the transition from 5D4 to 7F6. And the major emission peak is observed at 544 nanometer excitation wavelength, and it shows the transition from 5D4 to 7F5 layer. Another two peaks are observed at 584 nanometer and 624 nanometer, which are again associated with 5D4 to 7F4 and 5D4 to 7F3 transition. Next. The CIE chromaticity diagram is shown. In that diagram, X and Y coordinates are taken, which shows the green emission in that region, and the correlated color temperature that is obtained from the X and Y coordinate of CIE chromaticity diagram is 6509 degree Kelvin, which shows that the desired phosphor is a cool phosphor, and it is promising green emitting phosphor application in PC LEDs or other display devices. Thank you.
So, madam, which point we have to innovate it in your projects? Innovative topics you have to increasing your efficiency in which corner? So, what is your problem statement you have to address in which area particular? Few minutes. Okay. Any question from others? So now we concluded the today's Viva. Okay. So thank you so much all of you to presenting here. Thanks a lot.
I would like to extend my heartfelt gratitude towards Honorable Dr. Kapse sir and Honorable Dr. Dalke sir for gracing the session. The valedictory session will begin shortly. I request all the participants to kindly be seated. A very good afternoon to all. I extend a warm welcome to all the dignitaries, delegates, research scholars, and participants in this international conference on emerging trends in physical sciences, organized by the Department of Physics, Shankarlal Khandelwal Arts, Commerce and Science College, Akola, sponsored by PM Usha Grants 3.0. As there are many perspectives, there can be many answers. Yet in the end, the best answer to why is why not. From invention of the wheel, Isaac Newton's gravitational theory, to the creation of the internet, physical sciences has been the core of these innovations. Physical sciences is the foundation upon which many technological advancements and modern convenience are built upon. It has led to the development of numerous technologies that have revolutionized our lives. We are at the forefront of pioneering research and technological development, seeking to make advances in physical sciences that will shape the technologies of our future. We are elated to have Honorable Shri Gopalji Khandelwal, Secretary of our parent society, Shikshan Prasarak Mandal, Akola, as the President of this valedictory session. We are honored to have Honorable Professor Dr. Sanjay Dhobre sir as the valedictory guest of this session. We are elated to have Honorable Professor Dr. Ajay Lad sir, Director, Innovation, Incubation and Linkages, Sant Gadge Baba, Amravati University, Amravati. On the dais are our officiating principal, Dr. P.S. Pandey sir, convener of the conference, Dr. Sanjay Devde sir, and organizing secretary, Mr. Rohan Shirsat sir. I request Honorable Dr. Pandey sir to welcome the President of this session, Honorable Shri Gopalji Khandelwal. Thank you, sir. I would like to take this opportunity to introduce our chief guest, Honorable Professor Dr. Sanjay Dhobre sir. Sir has obtained his MSc degree in physics from Rani Durgavati University, Jabalpur. He obtained his PhD degree in 1992 in solid state physics from Nagpur University, Nagpur. Sir has an extensive teaching experience of over 32 years and 31 years of research experience. Honorable Sir has delivered over 182 talks on various topics. He has published 997 research papers in various journals, edited and authored over 31 international books, and has over 14,788 citations. Respected Sir has published 95 patents, out of which 56 patents are already granted. Under his valuable guidance, 78 students have been awarded PhD. Sir has received research grants worth 2.5 crores from DST, BRNS, CSIR, UGC, and IUAC. At the global level, respected Dhobre sir's name is considered in top 0.05% in Scholar GPS and top 2% scientists in the world as per the prestigious list published by a team of Stanford University scientists. As per the recently published data on Best Materials Science Scientist India 2023, Dr. Dhobre is at third position in terms of research published in Scopus. He has been bestowed with India's Top Faculty Research Award in 2018 by Careers 360. He is also the recipient of late Dharnidhar Gandhi Social Teacher Award in February 2025 and Best Research Award in 2016 for the outstanding contribution in the field of research for university presented by RTM Nagpur University. He is also Academic Council member of Datta Meghe Institute of Higher Education and Research, Fellow of Luminescence Society of India since 2017, and Maharashtra Academic of Sciences since 2020. We are honored to have such multifaceted personality amongst us today. I would like to request Honorable Shri Gopalji Khandelwal to welcome and felicitate Honorable Professor Dr. Dhobre sir. Thank you, Gopalji. We are delighted to have Honorable Professor Dr. Ajay Lad sir as the guest of honor of this valedictory session. I request Dr. Sanjay Devde sir to kindly welcome Honorable Dr. Lad sir. Thank you, sir. Now I would like to invite the organizing secretary of this conference, Mr. Rohan Shirsat sir, for report reading.
Thank you, madam. Good afternoon to one and all. Respected dais, the president of valedictory function, respected secretary of Shikshan Prasarak Mandal, Honorable Shri Gopalji Khandelwal, respected Honorable Chief Guest, Professor Dr. S.J. Dhobade sir, respected guest of honor, Honorable Professor Dr. Ajay Lad sir, Director of Innovation, Incubation and Linkage of Sant Gadge Baba Amravati University, Amravati, all the respected dignitaries, esteemed guests, all the faculty members, research scholar, and most importantly, all the participants present over here, offline as well as in online mode. Growth is never by a mere chance. It is the result of forces which working together. That's why today, myself, Mr. R.K. Shirsat, as an organizing secretary of this conference, feel glad to be surrounded here by most of the enthusiastic and very talented dignitaries at this international conference on emerging trend in physical sciences. With the permission of chair, I am going to present my report. First of all, the event began with the arrival of esteemed guest, followed by the university song and the ceremonial lighting of the lamp, which has symbolized the triumphs of light over darkness, excellence over ignorance, and good over evil. It has also marked the beginning of new chapter, new journey, and a fresh start filled with the prosperity. Respected officiating principal, Honorable Dr. Prasanna Pandey sir, welcome the participants and honorable dignitaries, followed by the commendation of our honorable guest present over here. The convener, respected Dr. S.K. Devde sir, provided an introduction of this conference, which outlining its objective and its significance in the evolving field of this emerging trend in the physical science. The Honorable Professor M.D. Shirsat sir, who is the Dean of Faculty of Science and Technology from Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, glorified the session as a guest of honor and shaded the lights on us. The presidential address was delivered by the respected President of Shikshan Prasarak Mandal, Honorable Dr. Taratai Hatwadne, who reinforces the importance of scientific advancement. In the world of professional gathering and knowledge sharing, these conferences are formidable platform which bringing together the erudite thinkers. Today, we feel proud to catch the moments with our renowned chief guest and keynote speaker, Honorable Dr. E. Seng Tan from Sunway University, Kuala Lumpur, Malaysia. Sir delivered an engaging keynote address on chemical molecular dynamics structural transformation. His presentation provided in the depth the knowledge of molecular behavior and structural transformation, captivating the audience with insight into the modern chemical research. The first technical session featured an invited talk by Honorable Professor Dr. Meng Lin Tisai from the Department of Material Science and Engineering, National University of Science of Technology, Taiwan. He marked us about the functional films for the next generation display technology, discussing the advancement in the material science for high performance display technology. The session was chaired by Honorable Professor Dr. Gigi Mule sir from PG Department of Physics, Sant Gadge Baba Amaravati University, Amaravati. Honorable Professor Gigi Mule sir emphasizes the importance of such innovations in advancing display technology and their potential impact on various industries. Now moving toward third technical session. The resource person, Honorable Professor M.D. Shirsat sir, spark out chemi-resistive and chem-FET sensor. Sir has highlighted application of chemical sensor in various domains, including environmental monitoring and healthcare. And they epitomize the actual research in the world of science from atom to AI. So that was very informative session by Dr. M.D. Shirsat sir. The session was chaired by the coordinator of Internal Quality Assurance Cell of Sant Gadge Baba Amaravati University, Amaravati, Honorable Professor Dr. S.A. Wagode sir. These first two sessions were anchored by respected Dr. Jayashri Sakarkale Madam and concluded with the vote of thanks. Now about the technical session 3. Honorable Professor Tibor Heineck from the Department of Nuclear Physics and Biophysics, Comenius University, Bratislava, Slovak Republic, Europe, delivered a lecture on biosensor based on DNA aptamers for monitoring food safety. His presentation delved the development of application of the biosensor, which is necessary to quality control and food safety also. The session was chaired by Honorable Professor Dr. Abhay Deshmukh sir from Rashtrasanta Tukadoji Maharaj University, Nagpur. The fourth technical session was featured and invited talk by Honorable Professor Dr. S.J. Dobde sir from the Department of Physics, Rashtrasanta Tukadoji Maharaj University, Nagpur. Sir has imprinted the multidisciplinary application of the phosphorus and challenges, addressing the broad application of phosphorus in various technologies. The session was chaired by Honorable Professor Dr. Ajay Lad sir. The third and fourth technical session was anchored by respected Dr. Dipti Petkar Madam and concluded with a vote of thanks. As we all know that science is a borderless. So let's turn out toward the fifth technical session, which comprising of exclusive offline as well as online reading, paper reading. This last technical session was fully loaded with almost registered 33 oral and 61 poster presentation by several researchers. Honorable Professor Dr. V.D. Kapse sir from Arts, Science and Commerce College, Chikaldara, and Honorable Dr. P.A. Dalke sir from C. Sant Gajanan Maharaj College of Engineering, Shegao, were the jury member for this oral presentation, while the poster presentation was judged by Honorable Dr. M.R. Velkhedkar sir from Shivaji College, Akola, and Honorable Dr. P.P. Devhate sir, Department of Chemistry from RLT College, Akola. This oral and as well as this poster session, it allows researchers to showcase their contribution in the field of research in the trends of these emerging fields of physical sciences, which has provided a platform for knowledge exchange and fostering collaboration, research collaboration for future scientific advancement. And all those was possible because of the power that we get from our honorable management. Respected Honorable Shri Gopalji Khandelwal, Honorable Shri Arunji Kulkarni, and all the respective member of Shikshan Prasarak Mandal, where dedication to education is an inspiration to every student and teacher, which has engrossed us with the national PM Usha, this grand strengthen to college. So it is a new vision to a mission. We are pleased to announce that we get a total number of 235 registrations, among which 110 to 108 full-length paper were accepted, and they are going to publish in International Journal of Scientific Research in Science and Technology with impact factor 8.627, comprising of 33 oral and 61 poster presentations. So this conference proved to be an insightful event which has brought together the students, the academicians, and the researcher to build up the innovation and research. And last but not least, I would like to express my sincere thanks to every chair to make this conference very fruitful. Thank you one and all. Thank you so much.
Thank you so much, sir. Without any further ado, I request the chief guest, Honorable Professor Dr. Dhobre sir, to guide us on this occasion.
Namaskar. Today's chief guest, Honorable Khandelwal sir, convener of this conference, Dr. Devati sir, Sirsat sir, Raj sir, my dear friend and IL director, Dr. Ajay Ladji, and Dr. Kapse sir and other my friends, all participants. हम जब किसी कॉन्फ्रेंस को अरेंज करते हैं उसमें बहुत से उद्देश्य होते हैं और वी आर ट्राइंग टू डेवलप आवर रैंक फॉर द NAC एंड NRF रैंकिंग, लेकिन उसमें सबसे बड़ा उद्देश्य मुझे यही लगता है कि अपन कोई ऑर्गेनाइज करते हैं तो उससे बेनिफिशियरी कौन है, बेनिफिट कौन किसको मिल रहा है, वो अगर बेनिफिट मिलता है तो उस कॉन्फ्रेंस या उस प्रोग्राम का मतलब होता है। मैं चाहता हूँ अपने हमेशा कार्यक्रम वैसे ही होना चाहिए जिसमें हमारे स्टूडेंट बेनिफिट हो या जो नए रिसर्चर है उसको सपोर्ट मिले। इससे मेरा जो टारगेट है कि आई एम ऑलवेज वर्किंग फॉर द सोशल इम्पैक्ट, इसके लिए मैं स्टूडेंट को हमेशा साथ में लेता हूँ। वो फिर MSc का रहे या PhD का रहे, मेरे लिए मायना नहीं रखता, लड़का हो या लड़की वो भी मायना नहीं रखता। मेरा एक ही उद्देश्य है, मुझे पगार केवल स्टूडेंट के लिए मिलता है, मेरे खुद के लिए नहीं मिलता। जब मेरे पेपर है अभी 900, अभी मैंने बताया कि 998 पेपर है, तो लोग बोलते हैं कि इसमें से आपके फर्स्ट ऑथर कितने, मतलब बहुत शुरू में होंगे, अभी नहीं है। 10 साल से मैं कोई फर्स्ट ऑथर नहीं करता और ना सिंगल ऑथर तो करता ही नहीं। तो व्हाई यू आर नॉट योर फर्स्ट ऑथर? मैं केवल पगार मुझे स्टूडेंट के लिए मिलता है, वो फर्स्ट ऑथर रहता है, वो MSc का हो या PhD का हो। मेरे यहाँ MSc के प्रोजेक्ट के भी स्टूडेंट आते हैं, उसे अगर अच्छे रिजल्ट मिले तो दो स्टूडेंट आल्सो पब्लिश हिज हर पेपर इन इंटरनेशनल जर्नल विद गुड इम्पैक्ट फैक्टर, बट शी और ही इज फर्स्ट ऑथर। बोला आपको उनका तो कोई कंट्रीब्यूशन नहीं, बोला वो करते हैं, उनका कंट्रीब्यूशन होता है, उसको अपन अभी से अप्रिशिएट नहीं करेंगे तो आगे कब बढ़ेंगे? उनको कौन आगे बढ़ाएगा? मुझे पगार केवल उनको उनके लिए मिलता है, मेरे लिए पगार नहीं मिलता। लेकिन ये बहुत सी चीज़ें कुछ लोगों को पचती नहीं है, वो फिर उसमें लाभ में कुछ ऐसा प्रॉब्लम क्रिएट होता है कि उनके लाभ में वो तो फर्स्ट ऑथर नहीं डालते, आप क्यों फर्स्ट ऑथर है, वो तुम्हारा प्रॉब्लम, मेरा प्रॉब्लम नहीं है। मैं 15 अगस्त 1947 से स्वतंत्र हूँ, मैं अपने हिसाब से काम करूँगा और मेरे रिसर्च में कोई टांग आड़े नहीं डालेगा। मुझे जो अच्छा लगता है मैं करूँगा, मेरे को स्टूडेंट के लिए पगार मिलता है, स्टूडेंट का ही करूँगा। इसलिए आपने मेरे प्रेजेंटेशन में देखा होगा, हर पेपर में स्टूडेंट फर्स्ट ऑथर, हर पेटेंट में भी स्टूडेंट फर्स्ट ऑथर है। तो फिर MSc सेकेंड ईयर सेम का भी हो, फर्स्ट ईयर का स्टूडेंट हो तो भी वो क्रेडिट लेता है, और उनको हम नहीं क्रेडिट कौन बढ़ाएगा? जब हम उस लेवल पे थे, हमारे क्या प्रॉब्लम थे हमें पता है। हम जब पीछे मुड़ के देखेंगे तो हम कहीं के नहीं थे, कैसे तो भी लोगों को हाथ पकड़ के उस सामने जाते जाते ही बहुत ठोकरे खाए, गिरे उठे और हुए, लेकिन हमें जो मिला उसमें बहुत परिश्रम करना पड़ा। लेकिन जो मेरे साथ प्रॉब्लम हुआ मेरे स्टूडेंट के साथ नहीं होना चाहिए, यही मेरा मूल उद्देश्य है और उसी हिसाब से मैं काम करते रहता हूँ। और मैं उसमें कोई कमीपना नहीं आती, मुझे कुछ कमकुवतपना नहीं आती कि मेरे स्टूडेंट इतने अच्छे हो रहे हैं। बहुत अच्छी बात है, मेरे स्टूडेंट आगे बढ़ते रहे, यही मेरा उद्देश्य होता है। कहते हैं कि हमेशा कुछ चीज़ें नीचे ऊपर होती रहती है, कुछ प्रॉब्लम आते हैं। आपने भी देख लिया होगा, एक दिन ऋषभ पंत को कितने प्रॉब्लम आए थे, उसे जलते हुए गाड़ी से बाहर निकलते हुए अपन ने देखा, लेकिन आज उसने अपनी टीम बना ली है, टीम में स्थान प्राप्त कर लिया है। जो आज हर क्रिकेटर का देखो, वो एक क्रिकेट टीम में जाने के लिए कितना प्रयत्न करता है, सही में अपन उतना प्रयत्न करते हैं। हमारे पेमेंट देखो कितना है, तुम्हारा पर डे पेमेंट 4 डिजिट में है, पर डे। और आपको इस पेमेंट के लिए आपने कितना काम किया है, और ये आपने सोचना चाहिए। इसलिए मैं यहाँ जो टीचर बैठे उसको बोलने का मेरा हक नहीं है, लेकिन एज ए दोस्त के नाते बोलता हूँ कि तुम जिस भी इंस्टीट्यूट में हो, वो इंस्टीट्यूट का नाम अगर अच्छा हो, उसका क्रेडिशन अच्छा हो, उसका ग्रेडेशन अच्छा हो, तो आपका इंस्टीट्यूट का आपका भी नाम होता है। और आपको अपना नाम करने के लिए इंस्टीट्यूट का वो भला करना चाहिए, और उसके लिए आप जो भी प्रोग्राम लेते हैं उसमें आपने कड़ी मेहनत करना चाहिए, और उस इंस्टीट्यूट के लिए आपको हमेशा करना चाहिए। आज जैसे ये कॉलेज ए ग्रेड है, बहुत अच्छी बात है, हमें A+ और A++ के लिए भी ट्राई करना चाहिए। इतना बड़ा इंस्टीट्यूट है। सर आपके यहाँ पे एमएससी फिजिक्स नहीं है, मैं आपसे रिक्वेस्ट करता हूँ सर, वो डेवाटे सर को कितनी भी तकलीफ हो, कितनी भी वो मुझे गाली दे, आप एमएससी फिजिक्स जरूर खोलिएगा सर। आपके बाजू में IL डायरेक्टर बैठे, वो आपको सपोर्ट करेंगे, क्योंकि इतने बड़े कन्वेनर बैठे और उसके यहाँ पे मास्टर डिग्री नहीं है, क्या बात है, ये गलत बात है डेवाटे सर। आप छुप नहीं सकते, हम आपको छुपने भी नहीं देंगे। हाँ, तो आपने एमएससी फिजिक्स सर, आप उनको एक कीजिए और उनको बोलिए कि एमएससी फिजिक्स, आपका एमएससी केमिस्ट्री फिजिक्स क्यों नहीं हो सकता है सर? फिजिक्स में बहुत सी एडमिशन मिलती है, 22 सीट रहते, 22 के 22 फुल हो जाती है। तो आप थोड़ा सा प्रेशर दीजिए, डेवाटे सर को जरूर रहेंगे। और आपका कॉलेज का, क्योंकि नाक में फिर मास्टर डिग्री देखी जाती है सर, आपके कॉलेज में कितनी मास्टर डिग्री है, उसके ऊपर आपका ग्रेजुएशन होता है। और सर इतने अच्छे गुड रिसर्चर है, उनके स्टूडेंट को मिलेंगे, उससे अच्छा उनका रिसर्चर अच्छा होगा। वो सोर्स ऑफ एनर्जी है सर, स्टूडेंट है ना, सोर्स ऑफ एनर्जी रहते हैं अपने साथ में, उसको अपन ने बढ़ाएंगे तो कौन बढ़ाएगा? तो मेरे आपसे रिक्वेस्ट है सर, ये थोड़ा सा ध्यान आप कॉलेज की तरफ जरूर दीजिएगा। डेवाटे सर को कितनी तकलीफ होती है उसको बिल्कुल मत देखिएगा सर, उसको तकलीफ देना आपका काम है, उसको आगे बढ़ाना हमारा काम है, उसके साथ हम हैं। हमेशा मैं आपके कॉलेज के साथ में रहूंगा, और जो भी आप वक्त पे काम बताएंगे मैं आपके साथ रहूंगा सर। लेकिन यहाँ पे मैं नेक्स्ट टाइम आऊँगा तब एमएससी फिजिक्स दिखेंगी, ऐसे मैं आशा करता हूँ। और मैं जो आपने बुलाया यहाँ तक वैलिडिटी में चीफ गेस्ट बनाया, इसलिए आपको धन्यवाद देता हूँ, और मैं आपके कॉलेज के लिए बहुत शुभकामनाएं। थैंक यू वेरी मच।
Thank you, sir, for your words of motivation and encouragement. Feedback from the participants is the reflection of the efforts taken in organization of this conference. Your valuable feedbacks will prove beneficial in our future endeavors. First of all, I call upon Dr. P.A. Saure from Jalgaon to give their valuable feedback.
नमस्कार. या इंटरनॅशनल कॉन्फरन्स चे कार्यक्रमाचे अध्यक्ष सिनियर प्रोफेसर डॉक्टर JS ढोबळे सर, या संस्थेचे सेक्रेटरी माननीय श्री गोपालजी खंडेलवाल, अतिथी प्रोफेसर अजय लाड, या कार्यक्रमाचे ऑर्गनायझिंग सेक्रेटरी शिरसाट, RK शिरसाट, आमचे मित्र डॉक्टर SK देवडे सर, या मंचावर उपस्थित पांडे सर, आणि या कॉन्फरन्समध्ये सहभागी झालेल्या विविध महाविद्यालयाचे विद्यापीठानिधी आणि विद्यार्थी मित्र आणि मैत्रिणी. एखादा इंटरनॅशनल कॉन्फरन्स इव्हेंट घ्यायचा आहे तर त्यासाठी जवळजवळ 1 ते 2 महिन्याची तयारी लागते, आणि त्यासाठी एक मोठं टीमवर्क पण लागतं. तर ही कॉन्फरन्स सक्सेसफुल करण्यासाठी या कॉन्फरन्सचे जे कन्व्हेनर आहेत त्यांनी खूप मेहनत घेतली. एक आढावामध्ये ऑर्गनायझिंग सेक्रेटरी यांनी या कॉन्फरन्सला किती पेपर सादर झाले, किती पेपर जर्नलसाठी एक्सेप्ट झाले, लोकांनी इथे पोस्टर प्रेझेंटेशन केलं आणि किती लोकांनी इथे पॉवर पॉईंट प्रेझेंटेशन केलं त्याबद्दलची आकडेवारी दिलेली आहे. ही कॉन्फरन्स सकाळी 9:30 वाजता सुरू झाली. त्याला अगोदर नाश्ता देण्यात आला, त्यानंतर घटनाच्या समारंभानंतर ते या इंटरनॅशनल परदेशातील जे अतिथी होते त्यांनी एक्सपर्टाईज वेगवेगळ्या विषयांमध्ये आपल्याला जे रिसर्च आहे ते रिसर्च आपल्याला समजून सांगितलं. त्यानंतर MD सिरसाट सर यांनी आपल्याला मराठवाडा विद्यापीठामध्ये त्यांनी जी लॅब इस्टॅब्लिश केलेली आहे त्या लॅब इस्टॅब्लिश केलेल्या लॅबमध्ये कोणकोणचे कॅरेक्टरायझेशन टेक्निकचे इन्स्ट्रुमेंट्स आहे जे की आम्ही जेव्हा रिसर्च करतो तेव्हा मुंबई वगैरे, तर आता औरंगाबाद विद्यापीठात ते सर्व XRD, AFM, ATM वगैरे आहेत. या सगळ्या कॅरेक्टरायझेशन टेक्निक नवीन विद्यार्थ्यांसाठी जवळच्या जवळ उपलब्ध झालेल्या आहेत. त्यांनी जरूर माहिती घ्यावी. ते रिसर्च करत आहेत त्याचा लाभ उठवावा. त्याचबरोबर आजच्या कार्यक्रम ढोबळे सर यांनी मल्टीडिसिप्लिनरी रिसर्चच्या संदर्भामध्ये खूप त्याला प्रोत्साहन, जे नवीन विद्यार्थी आहे किंवा जे रिसर्चर्स आहे त्यांना प्रोत्साहन देण्यासारखं बरंचसं काम सांगितलं आहे की तुम्ही एकच विषयामध्ये PhD सब्जेक्टमध्ये जरी ग्रॅज्युएशन केलेलं असलं तरी तुम्ही मल्टीडिसिप्लिनरी रिसर्चमध्ये कशा पद्धतीनं वेगवेगळ्या इन्स्टिट्यूटमध्ये कोलॅबरेशन करून चांगल्या पद्धतीचं आणि वेगवेगळ्या समाज उपयोगी रिसर्च कसा आपण सादर करू शकतो किंवा रिसर्च करून समाजासाठी त्या रिसर्चचा कसा उपयोग करू शकतो, एक मूर्तिमंत उदाहरण म्हणून आपल्यासमोर ते आज बसलेले आहेत. त्यांच्यापासून आपण जरूर प्रेरणा घ्यावी आणि रिसर्चला एक नवीन आयाम देण्याचा प्रयत्न करावा जे रिसर्च करत आहेत ते. त्याचबरोबर ही कॉन्फरन्स आहे त्या कॉन्फरन्सला आपण सर्वांनी इथे उपस्थित झालात, त्यांना खूप सहकार्य केलं आणि तिने सहभाग घेतला, आभार व्यक्त करतो. केला ना सर मी असल्यानंतर दुपारी छानपैकी आपल्याला जेवण दिलेलं आहे. एवढं इन्फ्रास्ट्रक्चर इथं उपलब्ध आहे, एवढा चांगला हॉल उपलब्ध झालेला आहे. फक्त एक टेक्निकल सेशनमध्ये थोडंसं इंटरनेटचा प्रॉब्लेम आल्यामुळे जे परदेशातले ग्रुपमधले जे होते त्यांचं आपल्याला थोडं डिस्ट्रक्शन झालं आणि त्यांनी आपल्याला PPT व्हॉट्सअपवर पाठवून पुन्हा आपण ते कंटिन्युएशन केलेलं आहे. सगळी इंटरनॅशनल जी कॉन्फरन्स आहे जे आयोजक आहे त्यांनी छानपणे ऑर्गनाईज केली, त्यांचे मी मनपूर्वक आभार व्यक्त करतो. संधी दिली त्याबद्दल त्यांचे आभार व्यक्त करतो. इथे थांबतो. जय हिंद, जय महाराष्ट्र.
Thank you, sir. Now I would like to invite Dr. Piyush Darke, Sant Gajanan Maharaj Engineering College, Shegaon, to give his valuable feedback.
Okay, good afternoon to everyone. I know that there's a very limited time here. So without wasting your time, we'll conclude today's feedback. First of all, I congratulate the management and to entire the team of Dr. S.K. Devde sir. Because we know that as per the NEP 2020, so this theme is fully appear to the emerging trend in physics, science, interdisciplinary concept. I know that the interdisciplinary concept that's been come with all the technological students will be come together. यहाँ पे जो कॉन्फ्रेंस हुई है वो आप देख सकते हैं कि सब स्ट्रीम के विद्यार्थी यहाँ पे आ गए, जो साइंस टेक्नोलॉजी से इंजीनियरिंग बैकग्राउंड हो, आर्ट कॉमर्स का सब स्टूडेंट का संगम यहाँ पे आपको दिखाई दे रहा है. जो हम बोलते हैं उत्कृष्ट भारत जो कंसेप्ट हम चला रहे हैं पूरे जग भर में, तो यहाँ पे अकोला में मुझे इस कॉलेज में दिखाई दे रहा है. Why not we'll start from with first institute. तो विकसित भारत 2047 का जो उद्दिष्ट हमारे जो प्राइम मिनिस्टर ने रखा है उसका फुल फेज यहाँ पे जो अपनी जो कॉन्फ्रेंस है वहां से आपको दिखाई दे रहा है. तो प्रीवियसली our PM Modi has to say that IT plus IT is equal to IT. What do you mean by 1 plus 1 is equal to 1? First IT means information technology plus Indian talent is equal to India tomorrow. If you want to build a India, so we have to develop the creative such practices. So these practices is very important. I know that is a Akola is the first, I think, institute they are organizing the interdisciplinary concept approach. यहाँ पे इंटरनेशनल भी कोई ऑथर्स यहाँ पे आके गया, हमारे तो लोकल के आते ही रहते हैं, मगर मलेशिया, थाईलैंड और बहुत सारे विदेश से के भी यहाँ पे आपको बहुत सारे लोगों ने जो भी उनकी ऑथर्स पोजीशन की जो विशेषता है यहाँ के आपको दिखाई दे रही, राइट. तो मैं मैनेजमेंट टीम को भी कॉन्ग्रेचुलेट करता हूँ कि ये जैसे आपने आयोजन किया इंटरनेशनल कॉन्फ्रेंस, तो ये अपने क्षेत्र की सबसे बड़ी और अच्छी कॉन्फ्रेंस आपको यहाँ पे मैं दिखाई देता हूँ, क्योंकि मैं भी बहुत सारे सेक्टर में जाता हूँ, मुंबई, पुणे और विदर्भ में स्पेशली, जो हम बोलते हैं विकसित भारत का जो एक पार्ट जो विदर्भ का हार्ड है, तो वहाँ पे भी ऐसी कॉन्फ्रेंस आ रही है, तो व्हाई नॉट वी आर कंट्रीब्यूट टू दैट एक्टिविटीज. So thank you so much, sir, for inviting me such a wonderful programs that align with the NAP 2020. Thank you so much. Thanks a lot.
Thank you, sir. Next is Shantanu Raulkar from Amravati. He will give his valuable feedback.
A very good, a very good evening to one and all present over here, dignitaries on the dais, respected teachers, and my fellow research scholars. I would like to thank you all for the opportunity to let me speak. First and foremost, generally what happens in international conferences is to have some sort of cost cutting. What they do is they have only online sessions. To have an actual international research scholar physically present here takes a lot of expenditure. You have to book their tickets, you have to make sure their arrangements are there. So it's quite a costly affair. So I was very glad that an actual international research scholar was here physically present. We all know that online lecture don't have that sort of impact. So to have him physically present here, it was a very nice change. Then secondly, eminent personalities like Dr. Shirsat sir, to have the choice of guests is also very important. See, what happens is when you are young, you are entering the system. You are all about changing the system. But as you climb the hierarchy table, you forget about changing the system and start reaping the benefits. To have such a person who is at the top of its position and still thinking about changing the system at the grassroots level, to have such a person speak at an international conference has a very positive impact on the new research scholars who are going to be faculty members, who are going to be in position powers in coming years. As is rightfully said, now the onus is upon us teachers, us young teachers, to implement all the schemes that are coming like NAP. It's very difficult to implement, but the onus is on us. So to have such personalities guiding us from the start is very important. So what happens is generally in international conferences, like in private institutions, only the permanent faculty members are generally, in the peak of the things. So I was very glad to see MSc students, the visiting faculty members of these institutions actually participating in the management of the function. So, and of course, the food was great as well. And with that, I would like to thank you all once again for giving me the opportunity to speak. Good day.
Thank you so much. As rightly said by Albert Einstein, learn from yesterday, live for today, and hope for tomorrow. But the most important thing is not to stop questioning. Now I would like to request Honorable Professor Dr. Lad sir to please guide us on this occasion.
संत गाडगे बाबा आणि ज्यांची आज जयंती आहे यशवंतरावजी चव्हाण यांच्या प्रतिमेस विनम्र अभिवादन करतो. आणि आपण भारत मातेचे ऋणी आहात आणि त्या भारत मातेला सर्वप्रथम मी नमन करतो. आजच्या व्हॅलेटरी फंक्शनसाठी आवर्जून उपस्थित असलेले त्यांना या इंटरनॅशनल कॉन्फरन्स इमर्जिंग इन फिजिक्स सायन्स इंटरडिसिप्लिनरीसाठी मी त्यांना बघितलं की त्यांचा उत्साह त्यांच्या चेहऱ्यावर दिसणारे सगळ्यांचे आदरणीय पितृतुल्य खंडेलवाल साहेब, मंचावर उपस्थित नागपूर विद्यापीठाचे आमचे सगळ्यांचे गुरु, आमच्या सगळ्यांचे गुरु म्हणतो आमचे ढोबळे सर, महाविद्यालयाचे ऑफिसिटिंग प्रिन्सिपल पांडे सर, कन्व्हेनर्स, एवढे सरांचं तर कौतुक करणं फार महत्वाचं आहे. खंडेलवाल तीन कोणत्यातले तीन माणसं, एक वन फ्रॉम द मलेशिया, वन फ्रॉम द तायवान, वन फ्रॉम द युरोप खंड, त्या तिघाला एका ठिकाणी अकोल्यात आणलं ते गरमीच्या वेळेत 37-38 डिग्री. म्हणजे हे जुगाडच काम आहे ते, आपल्या भाषेत म्हटलं, साध्या भाषेत म्हटलं तर. ते खूप सुंदर ह्या सँडविच ह्या तिघांचं
जो आपल्याला फूड मिळालं असेल आणि त्यासोबत सर आणि ढोबळे सर हे 6 टेक्निकल सेशन कम्प्लिटेड इन 1 डे. इट्स अ ग्रेट सक्सेस ऑफ द कॉन्फरन्स. सोबत त्यांचे सिरसाट सर आणि आमच्या सोबत बसलेले आमचे सगळे कापसे सर, पियुष सर, उन्हाळे सर, सगळ्यांची नाव घेऊ इच्छितो. आणि सोबत बसलेल्या सगळ्या महिला भगिनी. तर महत्वाचं म्हटलं म्हणजे बऱ्याच लोकांना प्रश्न पडते की डायरेक्टर, इनोव्हेशन, इन्क्युबेशन आणि लिंकेज नाव कसं पडलं. मी तर म्हणतो सर याला इतकी सुंदर कोंडी दिलेली आहे. मी मुद्दामून मराठीत बोलतो. सगळे जण म्हटलं आपण NEP ला फॉलो करतो, भारत माता की जय म्हणतो, पण मातृभाषा कुठे. म्हणून आम्ही ट्रेंड सुरू केला आहे की मग इनोव्हेशन, इन्क्युबेशन अँड व्हॉट अबाउट द लिंकेजेस. तर म्हटलं ब्रह्मा, विष्णू, महेश. ब्रह्मानी जन्म दिला, विष्णूनी सृष्टी बनवली आणि महेशनी सगळं या गोष्टीवर बोलत नाही. आपल्या सगळ्यांचा सक्सेसचा भाग आहे. पण इनोव्हेशन स्टार्ट फ्रॉम क्रिटिकल थिंकिंग, क्रिएटिव्हिटी, रिसर्चचं निर्माण होणे म्हणजे हा प्रकार विद्यार्थ्यांमध्ये निर्माण करणे म्हणजे इट्स अ इनोव्हेशन. आणि त्याचा घडवण्याचं काम ज्या टीचर ढोबळे सरांसारख्या MSCच्या विद्यार्थ्यांना पेटंटच्या दृष्टिकोनातून त्यांना एक पाहत निर्माण करून देणं म्हणजे इट्स अ इन्क्युबेशन. आणि तो चांगला झाल्यानंतर त्याला नॅशनल, इंटरनॅशनल मोठ्या मोठ्या इंडस्ट्रीसोबत किंवा मोठ्या सगळ्या इन्स्टिट्यूट सोबत जोडणं म्हणजे इट्स अ लिंकेजेस. हे आहे म्हणजे इनोव्हेशन, इन्क्युबेशन अँड लिंकेजेस. आणि याच्या अंतर्गत सगळ्यात महत्वाचा पार्ट येते की संशोधनाचा. मग सगळेजण संशोधन म्हणजे रिसर्च इज ओनली रिलेटेड टू द सायन्स अँड टेक्नॉलॉजी. सायन्सवालेच लोक करू शकतात, फिजिक्सवाले असो किंवा व्हॉट एव्हर द इंजिनिअरिंगचे लोक, टेक्नॉलॉजीचे लोक असो. फॉरगेट अबाउट. साधा NEPने म्हटलेला आहे की मग रिसर्च अँड इनोव्हेशन इज रिलेटेड टू द ईच अँड एव्हरी फॅकल्टी. ती फॅकल्टी कोणती असो, तुमची 4 फॅकल्टी दिली आहे, त्या 4 फॅकल्टीमध्ये तुमच्या याच्यातून तुम्हाला इनोव्हेशन करता येते. घरी बसल्या बसल्या साध्या स्वयंपाक खोलीतून आपल्याला इनोव्हेशन करता येते. नवीन नवीन मिलेट सारख्या याच्यामधून आपल्याला संशोधनातून आपल्याला सगळ्या गोष्टी करता येते. तर ह्या सगळ्या गोष्टीला तुम्ही तुमच्या दृष्टिकोनातून आपलं संशोधन आपण हे स्टार्टअप कडे तुम्ही कसं जाऊ शकतो. PhD बाय स्टार्टअप कन्सेप्ट विद्यार्थी. प्रत्येकाला रोजगार. मला असं वाटतं की 15 पासून जेव्हा ऍक्शन प्लॅन आला स्टार्टअपचा, आदरणीय आपले पंतप्रधान नरेंद्र मोदी सरांनी दिला की तुम्हाला जॉब क्रिएटर बनायचं आहे की जॉब प्रोव्हायडर बनायचं. हा सगळ्यात महत्त्वाचा झाला की तो कन्सेप्ट दूर गेला पाहिजे की मी 15-16 लोकांचं काम देऊ शकणारा माणूस तयार झाला पाहिजे माझ्या PhDच्या कामातून. PhD ऑन स्टार्टअप और बाय स्टार्टअप. PhDचा रिसर्चचा कन्सेप्ट तुम्हाला आपल्या एंटरप्रेन्योरमध्ये आपण कसा घेऊन जाऊ शकतो. आता सर आम्ही 2 रेग्युलेशन पास केले. एक रेग्युलेशन नंबर आहे वुमन एंटरप्रेन्योरशिप सेल प्रत्येक कॉलेजमध्ये सुरू झाला पाहिजे आणि प्री इन्क्युबेशन सेल इन अफिलिएटेड कॉलेजेसमध्ये प्रत्येक कॉलेजमध्ये म्हणजे विद्यार्थ्यांना ह्या सगळ्या आयडियाचं ऑनलाईनच्या माध्यमातून, गुगलच्या माध्यमातून न ठेवता त्यांना बेसमध्ये आणायचं आणि त्याला आपल्या कॉलेजच्याच इन्क्युबेशनमधून त्याला आपण कसं आपण इंडस्ट्री सोबत त्याला आपल्या आजूबाजूच्या सराउंडिंग मध्ये सोशल जो प्रॉब्लेम आहे त्या प्रॉब्लेमला आपण ठरवून आपण आपल्या समस्या कशा आपण त्या महाराष्ट्र गव्हर्नमेंटकडनं असो किंवा सेंट्रल गव्हर्नमेंटकडनं फंडिंग कसा. फंड भरपूर आहे देश ढोबळे सर, फंड भरपूर आहे ना, फक्त काम करणारे हात कमी आहे. फंड ओढून आणावं लागते, मागा लागत नाही. मला असं वाटतं की मी एक ऐकलं होतं, पैसा बनाना पडता, पैसा कमाना नाही पडता. एक चांगला कुठेतरी एका नाव नाही घेत, पैसा बनाना पडता, पैसा कमाना नाही पडता. आणि स्टार्टअपच्या दृष्टिकोनातून तुम्हाला तो कसा करता येईल आणि कशा दृष्टिकोनातून तुम्हाला तुमचं इनोव्हेशन, रिसर्च आणि ह्या सगळ्या गोष्टी आपण आपल्या माध्यमातून पुढे कसं घेऊन जाता येईल हेच काम आपण आता भविष्यामध्ये ह्या NEPच्या माध्यमातून आणि यांनी म्हटल्याप्रमाणे, पियुष सरांनी म्हटल्याप्रमाणे IT = IT आपल्याला इंडिया टुडे पाहायचा आहे. आणि इंडिया टुडे हाच रिसर्च, हा एंटरप्रेनर, हाच सगळ्या गोष्टीचा आपल्याला असला IPR, आपल्या सगळ्या गोष्टीचा असला सगळ्या म्हणजे आपण आपल्या कॉलेजमध्येच उद्या असं होईल की एडमिशन मध्ये कसं ना अपने को यार जॉब कहाँ मिलता है, खंडेलवाल कॉलेज में कहनी बहुत अच्छी ये है, इंक्यूबेशन भी ऐसा बन गया है कि वहाँ पे अपने को एडमिशन मिलने के बाद में जॉब की तो गारंटी है क्योंकि आजू बाजू के सेक्टर में अपने को मिल जाता है. तो असे पुढच्या भविष्यामध्ये अशा ऍडमिशन होणार आहे. एरा इज चेंजिंग. एरा फक्त तुमचा विचार बदल करायची गरज आहे. आपला विचार आपण त्याच ह्याच्यात घेऊन चालतो की बा हे असं बस आपलं मागं पुस्तके असं होतं आणि NEPने असं केलं. फॉरगेट अबाउट द क्रिटिसिझम. फोकस ऑन द अवर एम. फॉर द ओनली स्टुडंट, फॉर द ओनली स्टुडंट. थँक्यू सर, मला इथे बोलावलं आपण सगळ्यांनी. आणि सर मी आज माझ्या गुरुच्या मी वाचलं की मला 2:45 आपल्याला सेशन आहे आणि माझं काम करत करत मी 1:15 निघालो विद्यापीठातून. आणि मला म्हटलं 2:45 पोहोचत 10-15 मिनिटं आपला इंडियन कल्चरमध्ये चालते. मी बरोबर सरच्या सेशनला पोहोचलो, कारण मला सरांचं म्हणजे आमचे संबंध 30-35 वर्षापासून आहे. आणि तो सहयोग आला, त्या सहयोगाचं मी देवळे सरांचं सर्वांचं मी आभार मानतो. आणि इथं मला बोलावल्याबद्दल सर्वांचा आभार मानतो. जय हिंद, जय विज्ञान, जय भारत.
Thank you so much, sir, for your words of enlightenment. The moment we all have been waiting for are the results of poster presentation and research paper presentation competition. For poster presentation competition, the third prize goes to two winners. The third prize goes to Farhan Ahmed. The next third prize goes to Payal Mule. The second prize goes to Priya Chopde. The second prize goes to Priya Chopde. And the first prize goes to Shantanu Raulkar. The winner of poster presentation competition is Shantanu Raulkar. For oral presentations, for the third position, we have two winners, Atharva Bochre. The third prize goes to Atharva Bochre. The third prize goes to Rahul Nikam. The second prize goes to Praful Khode. And the first prize of oral presentation goes to Pranoti Khawne. The first prize goes to Pranoti Khawne. I congratulate all the winners and thank you to the dignitaries. Now I request Honorable Shri Gopalji Khandelwal to deliver the presidential address.
बराच उशीर झालाय, जास्त बोलणार नाही.
आजच्या या कॉन्फरन्सला लाड सर, बोबडे सर, अन्य सगळे जे वक्ते आहेत त्या सगळ्यांचं मी शंकरलाल खंडेलवाल महाविद्यालयातर्फे हार्दिक स्वागत करतो. मला जे बोलायचं आहे ते लाड सर सगळं बोलून गेले. मला खूप जास्त काही सांगायचं नाही. एवढंच म्हणणं आहे, जीवनामध्ये तथ्यांना खूप महत्त्व आहे. हे पण जर सत्यतेवर चालत राहिलो मग आपल्याला कधी कोणाबद्दल खूप कंप्लेंट्स करण्याची वेळ येत नाही. पण आपण ते तथ्य ओळखत नाही. आपण नेहमी दुसऱ्यांचे दोष बघतो. त्यांचे दोष बघता बघता आपण भरकटून जातो. जे काही या देशामध्ये आज प्रगतीचे पावलं उचलल्या जात आहेत त्याच्यापासून योग्य राहतो. आजची खरी स्थिती अशी आहे, भारत हा अत्यंत गतीने पुढे चालतो. फक्त चालतच नाही आहे की आर्थिकच विकास झाला असं नाही, तर आज भारताने प्रत्येक क्षेत्रामध्ये खूप माइलस्टोन्स उभे करण्याचा सातत्याने प्रयत्न सुरू केला आहे. आणि ह्या सगळ्या प्रयत्नांमध्ये आपल्यासारखे विद्वान लोकांनी जर हा प्रश्न विचारला स्वतःला, स्वतःच्या मनाशी, माझं योगदान या सगळ्या प्रगतीमध्ये किती आहे, तर आपल्याला अनेक गोष्टी लक्षात येतील. आपण ज्या भावनेने हे प्रयत्न करायला पाहिजे त्याच्यात कुठेतरी कमी पडतो. आणि ह्या सगळ्या याच्यामध्ये आपण ज्या प्रगतीच्या या सगळ्या प्रवाहामध्ये आपलं योगदान आपण फार कमी ठेवतो. आणि त्याचा परिणाम असा होतो की देश ज्या गतीने वाढायला पाहिजे त्याच्यात कुठेतरी आपल्यामुळे खोळंबा निर्माण होतो. मला दोष द्यायचा नाही आहे, मला हे सांगायचं आहे की कोणती गोष्ट आपण जेव्हा करतो त्याच्यात त्या कार्याचा उद्देश काय आहे. त्या कार्याचा उद्देश जर आपण पाळला आणि त्या उद्देशासाठी आपण चांगल्या दृष्टीने प्रयत्न केला तर संसाधनांची कमी सध्या नाही. आता देश इतकं प्रत्येक क्षेत्रावर पैशाचा हे सुरू आहे, खर्च करणं सुरू आहे की ज्यामुळे आज आता अनेक गोष्टींमध्ये भारत हा जागतिक नंबर 1 वर येण्याच्या प्रयत्नांमध्ये सातत्याने धावपळ करत आहे. त्या सगळ्या याच्यामध्ये आपल्या ह्या सगळ्या प्रयत्नांमध्ये आपण जर त्याच्यामध्ये थोडंफार कॉन्ट्रीब्यूट केलं तर मला असं वाटतं की ही जी गरिबी किंवा ज्या असे प्रश्न, ज्या प्रश्नांनी गेली 50-60 वर्ष या देशामध्ये दुसरे विषय यूज दिलेले. गरिबी हा असा विषय आहे की न संपणारा विषय आहे. त्याच्यावरच सगळ्या शासनांच्या सगळ्या योजना सुरू असतात. त्यापेक्षा आपण उत्पादक कसं बनू शकतो, आपण एखादी गोष्ट कशी क्रिएटिव्ह करू शकतो, आपण समाजाला आपल्या या संशोधनातनं समृद्ध कसं करू शकतो, ह्यावर जर सगळ्या लोकांनी विचार केला मला असं वाटतं की आपण येणाऱ्या काळामध्ये भारताला 2047 पर्यंत जागतिक महाशक्ती म्हणून उभं करू शकतो. मला असं वाटतं आजच्या कॉन्फरन्समध्ये निश्चित त्या दृष्टीने काही पावलं उचलल्या गेली असतील. आपण या कॉन्फरन्सला फक्त एक कॉन्फरन्स म्हणून न बघता काही प्रेरणा घेऊन जावी आणि आपल्या भावी जीवनामध्ये ह्या देशाला समृद्ध करण्यामध्ये, इथल्या प्रत्येक नागरिकाला समृद्ध करण्यामध्ये कसा हातभार आपण लावू शकतो. शक्य नाही आहे, हे फार करण्याची फक्त आवश्यकता आहे. तेवढं जर आपण या कॉन्फरन्समध्ये भाव घेऊन गेले, मला असं वाटते आज जो काही दिवसभर हा सगळा जो उहापोह झाला त्याचा भावी जीवनामध्ये निश्चित या देशाला विकासामध्ये परिवर्तित करण्यामध्ये हातभार लागेल. आपण प्रेरणा घेऊन जाल एवढीच सगळ्यांना शुभेच्छा देतो.
Thank you, Gopalji, for your words of wisdom and encouragement. To extend the gratitude towards all those who have put their efforts in organizing this conference, I would like to invite the treasurer of this conference, Dr. Kharat sir, to propose the vote of thanks.
I know actually we are leading half an hour, even though I should follow the protocol.
It's compulsory for me. Um, Firstly, I would like to congratulate all the winners of poster and oral presentation. Respected dignitaries and on the dais and off the dais, Namaskar. It's honor and privilege for me to extend the vote of thanks of his remarkable international conference on emerging trends in physical sciences. On behalf of Department of Physics and Shankarlal Khandilwal College, Akola, firstly, I would like to express my heartfelt gratitude towards the President of today's function, Honorable Gopalji Khandelwal, Secretary of our Parent Society, Shikshan Prasarak Mandal Akola, for his valuable guidance and encouragement. I would like to express my deep sense of gratitude to our esteemed chief guest, Professor H.J. Doble, Department of Physics, RTM University, Nagpur, for gracing us with his presence and delivering such an insightful address. Your words have been truly inspiring, sir, and have provided us with invaluable perspectives. I would like to thank our guest of honor, Professor Ajay Lad, Director, Innovation, Incubation and Linkage Sales, Sant Gadge Baba Amravati University, Amravati, for their support and guidance in this conference. Special thanks to our chief guest and keynote speaker, Dr. Tan from Sunway University, who traveled a lot and came over here from Malaysia, and Professor Menglin Sai, Department of Material Science Engineering and National University of Science and Technology, Taiwan, Professor Tibor Heinig, Department of Nuclear Physics and Biophysics, Slovak Republic, Europe, who shared their knowledge, expertise, and thought-provoking ideas throughout all the sessions. Your contributions, sir, have greatly enriched the discourse and have undoubtedly left a lasting impact on all of us. I would like to express my gratitude towards the guest of honor and invited speakers, Professor Mahendra Sirsat, Dean of Faculty of Science and Technology, Dr. Babasaheb Ambedkar, Marathwada University, Chhatrapati Sambhajinagar, for sharing his ideas, expertise, and explore the RUSA Center at Sambhajinagar, and he also explored the emerging trends in science and technology in India and in abroad. I am grateful for the involvement of Dr. G.G. Mule, Department of Physics, Sant Gadge Baba Amravati University, Amravati, Dr. S.A. Waghule, Coordinator IQSC, Sant Gadge Baba Amravati University, Amravati, Professor Abhay Deshmukh, RTM University, Nagpur, who chaired the technical sessions by spending their valuable time and enriched the discussions. Thank you, sir, for your valuable guidance and encouraging us. I am thankful to Professor V.D. Kapse, sir, from Arts, Science and Commerce College, Khildara, Dr. P.A. Dalke, sir, Sri Sant Gajanan Maharaj College of Engineering, Shegaon, Dr. P.B. Devate, sir, Sri RLT Science College, Akola, and Dr. M.P. Belkadkar, sir, Sri Shivaji Science College, Akola, who worked as a jury members and observed the presentations and encouraged the participants for recent advances in physical sciences. This conference has its genesis at the footsteps of inspiration of Honorable Taratai Hathwalne, President of Shikshan Prasarak Mandal Akola, and all the honorable members of SPM. We are deeply indebted for their encouragement to come across all the hurdles in the pathway to make his conference see the daylight. Incessant support and all-round supervision of our beloved principal, Dr. J.M. Sabu sir, and officiating principal for today, Dr. P.S. Pandey sir, have been an absolute necessity for his conference throughout. Sincere thanks to you, sir, for guidance and support. I would like to extend my deepest appreciation to all the delegates who participated and presented their research work in this conference. Your engagement throughout, thoughtful questions, and the wealth of ideas you have brought to the table of the conference have made this conference a truly enriching experience for everyone involved. Our heartfelt thanks to go to the organizing committee and technical committee who have worked tirelessly behind the scenes to make this conference a resounding success, and for that we all are truly grateful to them. I express my sincere thanks to all the international, national and local advisory committees for their guidance and kind support for organizing the international conference on recent trends in physical sciences. I acknowledge and express my gratitude to the PM Usha grants to strengthen the colleges for financial support which have made this gathering possible. I am thankful to teaching, non-teaching staff and students of the college who have made this event successful. I am thankful to media for giving support and wide publicity to the conference. Thanks to Rajeshwar Printers and the International Journal of Scientific Research in Science and Technology for timely support in printing the materials and publishing the research papers in the journal. As Ajay sir said that I should not forget this one to pronounce here. I would like to thank the caterer, Mr. Amit Utada, for providing delicious food. I want to put on record, this is very important for me, I want to put on record a special thanks to the convener of the conference, Professor Dr. S.K. Devde, and organizing secretary of the conference, Professor R.K. Sirsat, Dr. Praful Ghuge, Mr. Tushar Sapkal, and all staff members of the Department of Physics for their continuous efforts and dedication for making this international conference successful. Finally, I would like to thank each and everyone for your active participation, enthusiasm, and for making this conference a truly memorable event. We look forward for continuing the discussions and collaborations that have been initiated here. Once again, thank you all, and we hope to see you again at future events. Have a wonderful day ahead. Thank you. Thank you all. Thank you very much.
Thank you, sir. This conference will conclude with Vande Mataram. I invite Mr. Sanjay Patil for the same and request everyone to stand up in their place.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल वंग विंध्य हिमाचल यमुना गंगा उच्छल जलचित रंग तव शुभ नामे जागे तव शुभ आशीष माघे गाये तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे भारत माता की।
With the permission of the President, this conference is over.